noite a conferência anual da Associação Portuguesa de Energias Renováveis. Esta é a principal conferência dedicada ao setor renovável em Portugal, com uma história de mais de 10 anos. É neste evento que a APREN reúne as principais entidades públicas, governamentais e privadas para debater as novidades do setor no que diz respeito a políticas, estratégia, investigação e regulação da eletricidade renovável. Antes de darmos início ao evento, gostaríamos de deixar algumas indicações. O evento tem tradução simultânea de português para inglês. Existem dispositivos de tradução simultânea no balcão do Bengaleiro, à entrada mesmo deste auditório. O evento tem uma aplicação de suporte. Pode aceder a esta aplicação utilizando o QR Code impresso no seu badge de identificação ou agora presente no ecrã da sala. É através desta aplicação que pode consultar o programa do evento e as outras informações úteis, fazer networking com os restantes participantes, participar ativamente nos painéis de conferência colocando perguntas e respostas e respondendo a sondagens. Pode também aceder ao programa da conferência no site da APREN. Posto isto, vamos então dar início ao evento. Para dar o pontapé de saída à edição 2023 da Conferência Anual da APREN, chama ao palco o Presidente da Direção da APREN, Pedro Amaral Jorge.
Muito bom dia a todas e a todos. Vamos então dar início, apesar de ainda termos pessoas a deslocar-se, ao que parece há um problema com o trânsito aqui nas proximidades, mas vamos ter que arrancar para conseguirmos manter o mais possível o nosso calendário e horário. É um grande prazer, e em nome da APREN, receber-vos todos aqui hoje. Sintam-se muito bem-vindos à conferência anual, o que nós normalmente designamos por Portugal Renewable Energy Summit, na nossa edição de 2023. Uma nota importante, graças a todas e a todos vocês que assistem presencial e remotamente a este evento, realçar que é efetivamente o grande evento nacional do ano sobre energia, sendo também aquele que nós consideramos mais reconhecido e com maior notoriedade em Portugal. Obviamente, o nosso muito obrigado pela vossa adesão e participação. São todos vocês que fazem deste evento um sucesso e a APREN está-vos muito grata por isso. Quero também agradecer a todos os oradores e moderadores que aceitaram o nosso convite para estar aqui nestes nossos 2 dias, onde iremos debater o vasto programa que certamente vocês já observaram. Um especial agradecimento a todos os nossos patrocinadores. A vossa adesão massiva este ano é muito gratificante, pois para nós traduz um sinal cristalino da relevância do evento para todo o setor de energia renovável em Portugal, Ibéria e Europa. Não deixar de dar um agradecimento ao contributo e ao trabalho de todos os nossos parceiros e fornecedores e, por fim, e com especial realce, o meu grande agradecimento à equipa da APREN, sem a qual este evento não seria possível e no qual eles colocam muito empenho e desempenho nas atividades para que consigamos ter um nível de qualidade adequado às vossas expectativas neste evento. 4 ou 5 notas que nos parecem importantes. Obviamente que não podemos deixar de referir o contexto político da guerra na Ucrânia e o conflito no Médio Oriente entre o Hamas e Israel, porque eles são 2 dos exemplos de instabilidade geopolítica com impactos diretos, como no desenvolvimento das principais variáveis macroeconómicas e, obviamente, com impacto fundamental e direto nos preços de energia. Uma nota também para que tenhamos em mente que o contexto macroeconómico que estamos a viver, e simplificadamente só com 2 indicadores, a evolução da inflação e a evolução das taxas de juros dos bancos centrais do Norte Atlântico, porque nós sabemos que aumentos de inflação no CAPEX e aumentos das taxas de juros aumentando os chamados custos médios ponderados de capital impactam direta e negativamente aquilo que é a celeridade de desenvolvimento e instalação de centros eletroprodutores renováveis, e é uma realidade com que vivemos em 22, vivemos em 23, mas os indicadores económicos são favoráveis e dizem-nos que, de acordo com as perspectivas e as previsões económicas hoje, final de 24 e início de 25, estaremos novamente, entre aspas, num enquadramento macroeconómico regular, com taxas de juro muito abaixo daquilo que temos hoje, controlando também a inflação que foi gerada. Como sabemos, a transição energética é cada vez mais uma urgência, e não só em termos ambientais, económicos, na competitividade das empresas e nos preços de energia para os consumidores, e também financeiros no desembolso que é necessário para que todo este ecossistema se desenvolva, mas nós em 22 trouxemos às renováveis a questão da autonomia energética, da segurança de abastecimento e da independência energética. A segurança e a independência energéticas nacionais e europeia só podem ser asseguradas através da instalação de centros eletroprodutores no território, e é fácil de perceber porquê, porque a previsibilidade de custos de eletricidade só consegue ser assegurada com centros eletroprodutores renováveis. Os combustíveis renováveis, como todos nós sabemos, são sol, vento e água, e por enquanto estes são gratuitos e não geram emissões nem de CO2, nem de gases com efeito de estufa. Ou seja, o facto das renováveis terem custos marginais zero ou negligenciáveis faz com que nós consigamos traduzir um caráter de previsibilidade a longo prazo de custos e preços e, portanto, conseguir dar ao input do desenho de mercado uma estrutura de energéticos que não depende da volatilidade de preços de combustíveis fósseis cotados em mercado internacional. Uma nota que nos parece importante também é referir-vos o relatório de síntese da 6ª avaliação do IPCC, que transmite uma mensagem, eu diria, extremamente preocupante, referente à nossa capacidade coletiva de aderir a uma trajetória de aumento máximo em 1,5 graus da temperatura média do planeta. No tempo que nos resta, na década que estamos a viver, o nosso sucesso na redução de emissões determinará, de acordo com o modelo, a que nível de temperatura média que nós iremos chegar em 2030 e em 2050, e as consequências de aumentos de temperatura acima desses valores estão demasiado totalmente ilustradas e referenciadas em bibliografia científica, e eu não vou debruçar-me sobre isso, mas todos conhecemos os nefastos impactos das alterações climáticas. Como é óbvio, as renováveis têm um papel fundamental na redução das emissões de gases de efeito de estufa e, ao contrário do que insistentemente e ultimamente tem vindo a ser referido, as renováveis promovem a biodiversidade, e nós temos exemplos nos últimos 20 anos monitorizados que isso ocorre em centrais eólicas. Restaura os ecossistemas, isso também está claramente demonstrado e temos evidências empíricas de que isso acontece, e ajuda até a desenvolver novos ecossistemas em solos que, por estarem demasiado expostos e demasiado pobres ou estéreis, com a instalação de centros eletroprodutores com sombreamentos, consegue dar-se, no fundo, a origem a acolher novos habitats de fauna e de flora e, portanto, temos que ter isso em linha de conta e desmistificar aquilo que nos passam a vida a referir. Não queria deixar de referir aquilo que já vos referi o ano passado, que são os desafios de tudo isto. E, obviamente, que a modernização das instituições afetas ao licenciamento, sejam elas direções gerais, agências ou os municípios, precisa de se adequar àquilo que é a sua, no fundo, capacidade de gerir e de processar todos os inputs que hoje temos. Eu relembro que nós instalámos cerca de 5 gigawatts em 20 anos de eólica e que temos cerca de 28 a 30 para instalar nos próximos 6. E, portanto, é óbvio que a máquina, como está montada, não é por má vontade das pessoas, é mesmo por incapacidade processual. E, portanto, nós temos os profissionais com um elevado nível de capacitação, mas temos que definir e agilizar processos e procedimentos, temos que proceder à reorganização dos sistemas, temos que capacitar e formar as pessoas que não têm os conhecimentos necessários para se sentirem confortáveis para para ter e determinar determinadas decisões passando pelo pleonasmo. Temos também que digitalizar todas estas instituições, temos que criar sistemas de informação transparentes, rápidos e temos que ter portais de informação disponível para que tenhamos a noção exatamente onde é que os nossos processos estão e quanto tempo demoram a ser licenciados, porque isso é uma variável fundamental para os investidores e financiadores. Ou seja, em resumo, temos que implementar o artigo 15 do Decreto-Lei 15 de 2022, que define a tal plataforma eletrónica e que efetivamente se torna cada vez mais urgente a sua implementação e operacionalização. Obviamente que este não é o único desafio, todos nós sabemos que o acesso à rede elétrica de serviço público, seja em Portugal, seja por toda a Europa, começa a ser o elemento crítico do desenvolvimento das renováveis e, portanto, nós precisamos de pensar que modelo económico é que vamos ter para a expansão da rede, para a sua otimização, para o seu funcionamento não determinístico, mas probabilístico, mas também para o aumento da sua capilaridade geográfica e cobertura, para que consigamos efetivamente tirar partido do território e das condições naturais que Portugal apresenta. Não nos podemos esquecer também que temos que fazer uma mais cuidada gestão do território. Hoje temos atividades económicas concorrentes nos municípios e no território onde estes centros eletroprodutores têm que ser instalados e, portanto, o cuidado que sempre tivemos tem que ser redobrado, porque há atividades económicas concorrentes e nós temos que ser capazes de coexistir, não dando predominância a determinadas reclamações que não são efetivamente, eu diria, legítimas na forma como são apresentadas. E, obviamente, tal como já referi, temos que enquadrar tudo isto numa ótica de preservação da biodiversidade, restauro dos ecossistemas e até, no fundo, o renascimento, se me permitem a expressão, de ecossistemas que não existem, mas que podem ser promovidos com a instalação de centros eletroprodutores renováveis. E, obviamente, e o momento que vivemos de instabilidade política todos nós conhecemos, mas uma coisa que é fundamental para que estes investimentos decorram em tempo e custo adequados é a estabilidade regulatória. A estabilidade regulatória tem um impacto diretamente na percepção dos investidores e essa percepção dos investidores faz com que os custos, quer de capital, quer de dívida, quer maturidade desse capital e dívida, possam afetar os levelized cost of electricity e não beneficiarmos nós, Portugal, das condições naturais que temos e também de todo o ecossistema de instituições e de indústria e empresas que aqui estão. Uma pequena nota só para vos deixar uma mensagem que é importante. Nós fizemos, no dia 7 de novembro, o nosso evento anual de apresentação dos resultados do impacto das renováveis do ano 2022 e, se todos nós nos recordamos, 7 de novembro foi o dia em que efetivamente foi apresentada a questão das buscas e, portanto, isso tomou conta da agenda e nós não conseguimos passar a mensagem que era relevante, que era que 2022 foi um ano fundamental para as renováveis em Portugal, eu diria que o melhor ano dos últimos 10 anos, e apenas um indicador, em 2022, fruto do efeito da ordem de mérito e do facto de termos tido ciegas negativos, porque os preços a que os produtores renováveis entregaram a eletricidade ao comercializador do último recurso era muito inferior aos preços praticados no mercado spot, Portugal, ou melhor, os promotores de eletricidade renovável pouparam ao país 14 mil milhões de euros, em que 11 mil milhões são praticamente oriundos do efeito ordem de mérito e 2,4 mil milhões são um sobreganho direto que reduziu a componente de energia de todo o custo do sistema elétrico nacional. E gostaria de dar uma nota que é importante. Portugal foi, é e será sempre um país com excelentes condições para atrair investimento e financiamento para o setor das renováveis. E isso nós podemos observar ao longo de todas as crises que tivemos nos últimos 25 anos e acho que nos temos que orgulhar disso e tentar que o setor e as instituições, independente destas instabilidades políticas que acontecem, consiga manter o seu rumo, a sua serenidade e continuar a trabalhar como tem vindo a trabalhar até agora. Nesta conferência tivemos como grande objetivo analisar os temas que estão na agenda da Comissão Europeia e que têm impacto hoje nos produtores de eletricidade renovável, bem como nos produtores de hidrogênio verde e de combustíveis renováveis de origem não biológica. E, sucintamente, para não vos tomar muito mais tempo, temos o papel do operador da rede de transporte e do gestor global do sistema na transição energética e os desafios da regulação que isso tem em termos ibéricos e em termos europeus. Esse é um tema fundamental e aproveito para referir que no dia 24 de novembro houve um leak da Comissão Europeia do tal Grid Action Plan, ou seja, como é que vamos efetivamente desenvolver a rede elétrica a nível europeu para conseguir implementar os planos nacionais de energia e clima que estão previstos. Vamos abordar o Net Zero Industry Act e o impacto que tem na transição energética e também deixar aqui algumas pistas, comentários e oportunidades que possam vir a surgir para a indústria ou que já esteja localizada em Portugal e queira dedicar-se a outras unidades de negócio, ou mesmo indústria que não está ainda em Portugal e que possa olhar para Portugal como um país competitivo, fruto de baixos preços de energéticos e suportado por financiamentos dos quais o Net Zero Industry Act é um chapéu que agrega. E, obviamente, vamos falar também de hidrogénio verde, do ato delegado e da vantagem competitiva da Península Ibérica. Aqui, permitam-me só deixar duas notas. Nunca é demais realçar que, no cumprimento do ato delegado, Portugal tem claramente vantagens. Nós temos hoje cerca de 64% de incorporação de renováveis na produção de eletricidade. A meta que temos é de 85% em 2030. Temos, efetivamente, uma única bidding zone e conseguiríamos cumprir claramente o princípio da correlação temporal e da correlação geográfica. Além disso, se conseguirmos trabalhar para cumprir as metas do PNEC, vamos conseguir não só gerar sistemas de autoconsumo remoto e localizado para a produção de hidrogénio verde e subsequentes combustíveis renováveis de origem não biológica, como temos também a possibilidade de conseguir ter na própria matriz do país elétrica muitas horas do dia com mais de 90% renováveis na produção de eletricidade. Isso torna Portugal um país altamente vantajoso e competitivo para este tipo de projetos e não devemos deixar de referir isso sempre que tal for questionado. Num sistema em que vamos ter cada vez maior incorporação de renováveis na produção de eletricidade, o equilíbrio em termos de potência do sistema instantâneo é fundamental e daí irmos abordar a flexibilidade do sistema elétrico, como é que ela pode ser, no fundo, operacionalizada, quer do lado do consumo, quer do lado da produção, como é que estes mecanismos de remuneração têm que estar no mercado e, portanto, é fundamental passarmos também por esse tema e percebermos o que é que conseguimos aprender e, neste caso específico, temos até um exemplo do Reino Unido para nos ajudar a fazer benchmark. Depois temos um tema das renováveis ibéricas. E aqui o que nós vamos abordar é a história que já conhecemos, não é? Ou seja, o que é que caracteriza o facto da Península Ibérica ser uma ilha energética, vantagens, desvantagens, oportunidades e desafios. Que desafios temos em termos ibéricos, Portugal e Espanha, individualmente e conjuntamente, no cumprimento dos Planos Nacionais de Energia e Clima? Qual o impacto, uma vez que os Planos Nacionais de Energia e Clima são policy-driven e não market-driven, e, portanto, que impacto é que isso terá se o consumo energético, especialmente o elétrico, não acompanhar? E, obviamente, uma coisa que temos falado, temos que analisar a necessidade de ter uma estratégia e política de armazenamento o mais rapidamente possível, e perceber como é que isso tem que ser feito em termos coordenados, uma vez que o mercado elétrico ibérico é um só. Vamos passar por o eólico offshore em Portugal e trazer os principais desafios que temos ainda para perseguir este caminho dos 2 gigawatt até 2030 e da atribuição dos 10 gigawatt até 2030, a atribuição de direitos em 10 gigawatt, mas a tentativa de implementar 2 gigawatt até 2030. Vamos passar pelos desafios dos centros eletroprodutor da atualidade, desde o licenciamento à operação dos mesmos em mercado. E, obviamente, vamos ter um painel que todos os outros são importantes, mas este parece-nos claramente irrelevante, do desenho do mercado europeu de eletricidade e as implicações que isso tem em tudo o que está para montante e para jusante, e nomeadamente na bancabilidade e na aceleração da implementação destes centros eletroprodutores. Passaremos pelos desafios do autoconsumo e das comunidades de energia. Há a necessidade de trazer a SER do papel para a realidade. E, no fim, com CEOs e CEOs de algumas das maiores empresas eletroprodutoras instaladas em Portugal, vamos falar dos desafios europeus e nacionais para as renováveis, quer no cumprimento do PNEC 2030, quer na operacionalização em mercado, quer na taxa de execução que precisamos de ter e que mecanismos é que são necessários para que este investimento aconteça. Posto isto, desejo-vos 2 dias de produtivo trabalho, na expectativa que deem por bem empregue o tempo que decidiram investir connosco nas próximas 48 horas e bom trabalho até daqui a pouco. Obrigado.
Está dado o pontapé de saída e passamos então, sem demoras, ao primeiro painel do dia, intitulado O papel do operador da rede de transporte na transição energética e os desafios da regulação. Este painel pretende descortinar o caminho para criar uma rede mais forte, digital e resiliente para a transição energética. Convido então a entrarem em palco os oradores do painel. Christian Zingelslein, diretor da ACER, Agência Europeia para a Cooperação entre Reguladores Energéticos. Concepción Sánchez Pérez, General Manager System Operation da REE, a Rede Elétrica de Espanha. Damián Cortinaz, Chair of the Board da ENSOE. João Conceição, COO da REN. E o moderador, Pedro Carvalho, professor catedrático no Instituto Superior Técnico.
Good morning, everyone, ladies and gentlemen. So, the title of this panel, let me recall it in English now, is the role of the TSO, transmission system operators, in the energy transition and the challenges of regulation. So we have here with us distinctive officers that work every day on those topics, and we will have, I believe, the chance of discussing with them this very important topic. So I prepared a small introduction to the topic, and then a few questions that I will share in a few minutes. So let me start by quoting the very recent IEA report on electricity grids and secure energy transition. It starts like this. Modern, smart, and expanded grids are essential for the successful energy transitions. This is how the executive summary starts. And it starts like this because it seems that the grids are lagging behind on that purpose. So the infrastructure today is no longer the main driver of transformation as it was 100 years ago at the beginning of electrification. And this is something that may come up as a surprise, but many people think that this is true. So the new electrification that is central to the objectives of energy transition seems to pay very little attention to the grid infrastructure, its expansion and modernization, those needs. And instead, it focuses on replacing conventional generation by renewables as if replacement would be sufficient to undertake the energy transition. It is not. So replacement is obviously not sufficient. So the question is, something seems not to be functioning very well. This year, the UE Commissioner for Energy, Kadri Simpson, I think, said, we need solutions to turn a potential barrier, the grid, into a powerful enabler and the clean energy transition. A powerful enabler of the clean energy transition. And she said also, solutions to make our grids, so that enabler is the solutions to make our grid stronger, more digital, and cyber-proof and resilient. So Europe needs to invest hundreds of billions, that's a big number, hundreds of billions of euros by 2030. So it's not a very short, it's not a very long time. And that needs to be invested in modernizing the grids. So in a century, looking back again to 100 years ago, in a century, a lot has changed in the way the transmission and distribution are regulated. Okay, so a lot has changed in regulation, and that can partially explain today's lack of momentum in expanding and modernizing the grid. Changes have also taken place in public perception and the willingness to pay for that transformation. Okay, so getting electricity for the first time is one thing. It's very life-changing. Okay, and getting it green instead of gray is not the same. So the challenges are huge. The case of Portugal and Spain is distinctive because we are here in a kind of a electric island. And because of that, they are particularly difficult as well. So distinctive and difficult at the same time. So we have on the panel distinguished officers from the Iberian TSOs. Concha is an officer of the transmission system operator of Spain. We have João Conceição from REN, the Portuguese TSO. And then two representatives of one of the European TSOs, and COE, Damien, and Christian, that is the representative of ACER, okay, so the energy regulators, the Association of the Energy Regulators. So we have a great opportunity to understand some of the challenges that we are facing. So I'm going to start with a question that can start being answered by Concha and then followed by João and so on. So the first question is, given the growing ambition for renewables integration in the Iberia, what can be done to accelerate grid expansion and operation modernization beyond the existing plans? So what are the main pain points and the most critical risks of delaying such expansion, and what is holding back the modernization that relies on smart grid operations? So those are two questions. One is what is holding back the investment in the grid, so the planning, so it's from the planning perspective. The other one is what is holding back modernization from the operations perspective, from smart grid operations perspective. Concha.
Thank you very much, Pedro. Thank you very much, first of all, for the invitation to participate in this interesting forum. Well, there are many questions. I can start, and I think it's something completely known for everybody, that grids are as a backbone of the electric system, especially in this energy transition. But we are not talking about grids as, how can I say, a passive infrastructure only and deploying a lot of infrastructure with no sense. We are facing a lot of problems common with the rest of Europe about permitting, about the lack of issues in order to get faster deployment of grids. Perhaps we have some problems about the flexibility of planning processes. And of course, we need to face somehow a social opposition to any infrastructure. And of course, as it's said, without transmission, there's no transition. But we cannot only stay on this infrastructure, as it was shown. We need to be smart in our system operation, and being smart involves getting all users as actors in order to provide not only energy. We are not talking about only energy and efficiency in terms of the price of cost of energy. We are dealing with a huge moment when energy is very important, but flexibility is a very key issue in order to get this efficiency in terms of providing energy. And providing energy and flexibility should be something shared in Europe, because as small as the system we have to operate, it's huger. The goals and the threats to reach it. So Europe has decided to make this transition. We have to share our resources. We have to share our main learned lessons, main problems already solved. and go all together in this path. And for this, I think there are many things to say. For example, in terms of collaboration of all actors, how to deal with this collaboration with observability, with controllability by the TCOs, not in terms of control, because we are over this group of actors, because we need them in order to collaborate with balancing services, with congestion management, with non-frequency services, and so on. And that's something to be provided by renewables. If not, other generation should do it with demand, with our operational procedures, and so on. I think it's a very, very common goal, and everybody is named to provide as far as possible. And the grid and system operators should be like the glue in order to provide this.
Thank you. Thank you. João?
Well, to start, I would like to thank APREN for the invitation. And picking up a little bit what Concha has just said, I think that we were caught in the moment that everything changed at the same time. It's not that the energy sector is going through a monumental revolution, that all the variables happened at the same time. It's a matter of security of supply. If we go back 2 or 3 years ago, before the Ukrainian crisis, no one was speaking about security of supply. In fact, each time the TSOs or the system managers spoke about that, they were accused of creating an issue that was not existing. It's a matter of changing the normal role of a sector that was well-behaved, in the sense that you have the generators, you have the consumers, and you have a unidirectional flow from generator to consumers. Nowadays, you have no longer consumers, you have prosumers, you have active players in the system. It's at the same time a change on the structure of the sector, because we all want to be sustainable, we all want to go greener, we all want to go renewable, and these all together pose a huge challenge where suddenly everyone realized that grids are important and grids are essential to make this transformation possible. So I would start to say that the needs are identified. So it's not a matter of are the grids useful or not. I think for that we have already reached an agreement. The problem we face is basically a more, I would say, an implementation problem. And the implementation problem, we have different causes for this implementation problem. We have a lead time from when a decision is made to do some grid development until the moment that this grid is put into operation is still very, very long. It's still a very long time, and it's no longer consistent with the needs that the other actors and the other stakeholders are requiring from the grid. What the cause for that? I would say they are also quite well identified. Very heavy licensing processes. We have an issue on the so-called not in my backyard reactions. And everyone wants to have electricity or energy at home, but no one wants to have a grid in the backyard. We are now facing an issue from the grid operator's perspective of a competition between grid operators in terms of supply chain and availability of goods and equipments, because the need for the grid is not an issue of Portugal or Spain or France or Germany, it's an issue everywhere. And the value chain was not adapted to this high demand all at the same time. So I would say that the risks are identified. The second point I would like to highlight is the fact that I'm not so sure if the willingness to pay is already a consensus. Because each time we speak about grid development, everyone is in agreement that grids are needed. But when we present the bill, the reaction is always, it's too expensive. I'm not going to pay that. And for that, my perspective, or the perspective of REN, is clearly we need to find a consensus of what I would call a risk sharing. This needs to be something that all the stakeholders need to participate. To start, the grid operators, we need to develop methodologies, and we need to develop an approach that is more efficient. We need to bring some risk into the grid operation. We need to decrease the needs of the grid development, but at the same time having the necessary response. We need to go into dynamic network planning. We need to have more sophisticated congestion management instruments, and so on. But on the other hand, the other stakeholders need also to participate. We need policymakers and regulators to develop more stable and solid regulation. Not only technical, but economical, because the economic incentives need to be there for all the actors to react accordingly. And we need also the participation or the involvement of the two extremes, the generators and the consumers. And we need they to be part on this risk sharing and this cost sharing approach. If we are not able to find a compromise with all this, I'm afraid that all these efforts will continue to be discussed. We'll continue to have very nice documents and papers and publications. But if we come back in 1 year time or in 2 or 3 years time, we will be saying everyone knows that grids are needed, but nothing is honestly and seriously happened for grids to show up.
Thank you, João. Very, very good. Damien, I suspect those problems are shared by the other TSOs in Europe. What do you think?
Yes, they are. That's the short question, but I'm going to develop a bit more. First of all, thank you, Pedro, and thank you, APREN, for inviting me. It's a pleasure to be in Portugal, to be in Lisbon today. Before directly answering your question, I'm going to give a bit of context of where are we coming with this answer. So as Pedro said, I am the chair of the board of ENSOE. ENSOE, we are not a very well-known organization, even if we should probably be, because we are the association of all European TSOs. We have 39 members, of which Red Electrica and REN are, of course, part of it, but we cover the whole of Europe. And we have been working together for a very long time. This was a voluntary association at the beginning. It has grown with a number of tasks. And one of the things we have been working for the past 2 years is what we call our vision, or what would it take for the European power system to be fit for a truly carbon neutral Europe, for a full continent. And a lot of the things I'm going to say, not only to this question, but this morning, is going to come from this work. Because in this work, we put together all the different parts of what needs to be done. And one of the things that clearly this needs to be done is grid infrastructure. No transition without transmission, as Concha said before, which is a very good way of putting it. It was a bit the forgotten part of the equation of the energy transition, on the fact that we need grids to connect the new generation and the new patterns of consumption. And not only for that, we will need grids in order to share everything that will be needed to run this power system fit for a carbon neutral Europe. We will also need to make the grids smarter, and this is something we are all working on it. And my two colleagues have several examples of the things that can be done to make the networks smarter. But even when we apply every technology available to the grids, we still need to build new grids, because the energy generation is not at the same place as it was before, and this is particularly true for offshore, and there is a huge offshore potential in Europe for the future, because we need more transmission. Because as you all know, renewables, most of them are what we call weather dependent. When there is wind, there is power. When there is sun, and there is power. When there is no wind and there is no sun, there is no power. One of the ways to solve this equation is to be able to share. And knowing that when there is no wind in Spain, sometimes there is in Germany. And there is a way to share that. And transmission is extremely important for that. There are other things that will need to be done, but they are more related to what we call flexibilities, more related to the market design of the part. But grids are essential. And we are very happy that at the beginning of September, the European Commission tasked ENTSO-E to organize what we call a grid conference. We put together in Brussels all the main decision makers from every part of the value chain, from generators to consumers, from the Commission, regulators, national member states, and of course ENTSO-E, and of course our DSOs of distribution system operation friends, who are also part of the topic, everyone in our room. And the conclusions were very clear. Today we are not very bad at planning what we need to build, even if there are things to be improved. And this is something we are going to be working on with the TSOs, with also the DSOs and all different parts. The problem here is how we go from planning to delivering. And as Joao was saying today, the lead times between the moment we decide to build an infrastructure and the moment the infrastructure is used, they number today in sometimes close to a decade, which is simply not acceptable. And this forum identified 4 main things that need to change. And I'm coming now mainly to your questions that need to change if we want to be able to deliver the grids that we need for the energy transition. One is financing. We need better access to finance and the different parts in order to build everything that will be needed. We are talking about hundreds of billions of euros at the scale of Europe, and this is something that will need to be addressed. The second is the regulatory framework, from which I'm sure my colleague is going to say a few words. But from TSO point of view, most important things is to be able to do what we call anticipatory investments. We do not need wait for the renewable to be there in order to build the grid, but we can do it by anticipation. And another thing is permitting, how to simplify the permitting procedures. Third thing we need to change is the supply chains. Today, one of the main bottlenecks is the fact that we don't have today the manufacturing and supply chain capability to build what needs to be done in a timely manner, and this is something we need to address with all the value chain that is here. And the fourth, and again I build on what my colleague said, it's what we call the public engagement. The fact that this is going to cost, and the fact that this is going to create new infrastructure that will need to be physically there. And how can we engage with the general public on the fact that we need absolutely that in order to get to the energy transition? And I finish by saying the energy transition today is very clear for Europe. This was started as a need to save the planet from global warming. But for Europe today, this is also, after the Russian aggression of Ukraine, an issue of sovereignty. Through the energy transition, we could finally have a continent that is energy independent. And this is a goal that today is as important as the environment one, and this is why I think every government in Europe today clearly follows it. But I come back to that. It's extremely important that the grids are there. There will be no transition without transmission. And just to finish, yesterday the Commission published an action plan for grids that we worked a lot with them, and from which we feel this is clearly a first step in the right direction, even if a lot still needs to be done in order to get there. Thank you.
Thank you, Damien. Thank you very much. Just before giving the floor to Christian, I just want to make a note that Concha talked about sharing, João talked about sharing, you talked about sharing. So the infrastructure seems to be something, an infrastructure, the purpose of an infrastructure is to share. And this is why the infrastructures are the signs of civilization, right? So any barbarian can make a resource. To make a civilization, to make an infrastructure, you need a civilization. And to talk about the representation of civilization, we have here Christian, right? So he's a representative of the regulators.
That's a tall order. Okay.
So Christian, the floor is yours.
Thanks a lot. Thank you. It's nice to be back in Lisbon. I've been back quite a few times since I started as head of ACER 4 years ago, roughly. I would come in with a few, maybe pick up your point about it's about sharing. I think that's a nice notion. It is, both at the very macro continental level and also at the local level. That has obviously implications for the connectivity of that sharing concept, namely grids. I agree with that. At the end of the day, someone has to pay. That's just how it works. And I think you were making the good point that you're not fully convinced yet that there's absolute consensus about the willingness to pay in all quarters, which I also agree with. Maybe I had three elements I want to touch upon. At the very macro picture, at the continental scale picture, if you will, I would align myself completely with what Damien said. We have firsthand witnessed the resiliency asset of an interconnected grid, actually an interconnected network, so not just in electricity but also in gas, because some countries were highly vulnerable and frail because of Russia's actions, as it were. And yet, most countries across Europe got through it, albeit with exorbitantly high cost for consumers and industry, but got through it without lights going off, at least to any noticeable degree, or heating being turned off to a notable degree. Part of the reason for that was ingenuity and hustle and whatnot in many quarters, but part of it was also an integrated energy system, both spanning electricity and gas. So the security of supply benefit of having that macro system was played out in real time against a tragic background. That's the macro picture. Then there's the micro picture, which I think is at the local level. I think a lot of grid investment and reinforcement and flexibilizing, if you will be done relatively locally with a lot of distributed assets in the system. That comes with a lot of benefit. It also comes with some cost to reap those benefits in terms of grid reinforcement, as it were. So there is definitely a case there, as well as the macro level for increased interconnection. And that brings up then how to do it in a way which increases the willingness to pay. I would take some of the examples that you mentioned of challenges. I would agree with. I think there is a challenge of accelerating permitting. I had a talk a while back with a state secretary, let's say in the broader region, who said he spent 80% of his time in local communities trying to discuss how to make the way for needed infrastructure. That's quite a large time expenditure. I'm sure he had other things on his to-do list as well, but he probably prioritized it because he saw it as very necessary. So there's something about local engagement, making sure that local communities in some ways see benefit from these investments. That could be monetary benefit, could be other types of benefits. I think that's needed. I think there are very good examples of that across Europe, probably also here. I had some examples of that shown to me when I was in Ireland not that long ago. So there are good examples to draw from. I'll close with what I think will be a defining feature both for the macro grid challenge of interconnection across countries, across the continent, and the more micro-local challenge. And I think is to prove the case that the grid is, or the grid challenges are being approached as efficiently as possible. There's a lot of digital innovation happening. Flexibility in the future will be many assets providing flexibility to the system in a highly integrated way. That in and of itself alleviates the need for a fair share of grid investments that would otherwise be required. So the notion of how to make system operators, whether at distribution level or transmission level, how they can show that they are being maximum, let's say, efficient, innovative, on the technological avant-garde, as it were. Also to show the public and the stakeholders that the investments needed are the genuine investment needed, because things are already done in a very advanced and integrated way. And we have some thoughts on that on the regulatory side, how to put up a framework which also benefits system operators such that they are, let's say, willing to take on certain actions which may in the short term increase system duress, but in the long term could make the system operation more efficient.
Thank you, Christian. So, continuing on this trend of sharing, so we know that reinforcing the cross-border interconnections and their capacities is key for the sorry, my question just went out. Is key for the integration of the European markets. So increasing the interconnection capability with France is crucial for Iberia, right? both for the market efficiency and for the security of operation. So progress towards the so-called 70% target for cross-border capacity available for trade is scattered and is uneven as well. So the costs for redispatching are rising rapidly, right? And the review by the bidding zones by the TSOs configurations is being delayed. And there are difficulties in building new grids, as we already talked about, to alleviate the existing congestions. So the question is, do we continue as is, or do we need something different to reach the 70% cross-border capacity target? I can start with you, Christian, now, because this is a little bit one of your concerns.
We go from civilization to capacity allocation.
Yeah.
Which is a nice bridge. No, indeed. Let's come back to this concept of sharing, which I totally believe in. I think it's a beautiful continental vision of how we can decarbonize and secure our systems at much lower cost than we would otherwise be able to. Part of that is having the facilitative grid, also cross-border. And of course, the Iberian Peninsula is in a very special situation here with priorities for the future to increase that level of interconnection. But of course, not just about building the physical infrastructure and the pylons. You need to make the systems interoperable. That requires a lot of work on the market framework, market coupling and the likes, but it also requires that you have faith in interconnector capacity being available for trade. First, because of the investments already made, some of the investments require or will benefit from access to a larger geographical area that lowers volume risk, offtake risk, as it were. And so it lowers, let's say, whatever support mechanism is in place, it lowers the exposure to, let's say, that otherwise greater risk. But there's also a political component to it. If we envisage a much more interconnected Europe, it means we are becoming more reliant on each other, more interdependent, for the sake of lower cost decarbonization, for the sake of energy independence vis-a-vis Russia and other third countries that we don't want to be very reliant on. But that also brings about, let's say, a structural dependence from some countries. Not all countries can be exporters all the time, as the saying goes. So one would be an exporter, importer, maybe it fluctuates over weeks or months, or maybe some are just structural exporters year on year on year, and others would need to be comfortable then with being structural importers year on year on year. So how to make countries, whether they're stakeholders or governments, comfortable with that proposition, the sharing concept, structurally ingrained. I think part of the reason there, part of the answers there lie in the credibility of the framework that we have and making sure we can trust these energy flows coming when system signals warrant it. And that is what is today at least partly captured in the so-called 70% rule, which I think most would agree is a relatively crude rule, but it comes from the perception, this basic political concept, that we need to have faith in interconnector capacity being available for flows. Where actually the Iberian is also doing pretty well here, according to our difference. So I'm not in any way having a subtle message towards my fellow panelists, not at all, quite the contrary, actually functions quite well here. But that, let's say, level of progress is not so evenly shared across the rest of Europe. So this is something, even though it's couched in a bit of a technical language, I think it represents a much more fundamental notion where if we don't improve progress here one way or another, I think it will cast doubt as to whether countries will be willing to go down this, let's say, sharing route because of the dependencies that such sharing will encompass. And I think that would be a shame.
Thank you, thank you. Damien, your view on this?
Thank you very much, and thank you, Christian. We are completely in complete agreement on the fact that if I come back to what I said before, what will it take for a power system fit for a carbon neutral Europe? This future power system will need more Europe, and we will become more interdependent with one another. That's the only way to go. That's not the only conclusion. There is another one that maybe will be for another time. It would also be more local. Yes. We say more Europe and more local.
I agree.
A lot of the things will be very locally dependent. So we see this future of both more European integration, but also more adaptation to the local need, and particularly the work we need. We are already doing with ESOs, we will continue, but this will be another topic. But on the more Europe, we will become more interdependent, and we fully share the goal that Christian has exposed here of the fact that we need to be able to use the existing network and the network we're going to build in as smart way as possible. A smart way means to be maximize this network for to be available to trade electricity between different countries. This 70% rule, we tend to have a slightly different view on the way it works. We call 70% what we call a magic number, but this needs a bit of explanation because it becomes very technical. In the end, when you talk 70% of the capacity available for trade, the question we always have is why not 100%? Because this is usually the question we have. And it's not 100% because this is not how the physics of the system works. Because we need a system that is reliable. Reliable means that it needs to be able to withstand the fact that something can happen to any given element. You can have strike in one power line, you can have a generator that goes off, you will have a lot of different things, and the network needs some redundancy built into it in order to keep the lights on, whatever it takes. The fact that in Europe today we have a network that is extremely reliable, that is a factor of competitiveness. If you compare to the United States, for instance, of the North America, the average number of minutes on what is cut from electricity in Europe, it's 1/10 of what it is there. And this is because we have a network that is reliable. Reliable means a bit of redundancy. This redundancy comes into the 70% rule. That is kind of an average of what is the redundancy you need to have in order to be able to have a secure system. But this average is a magic number that today tries to apply to the whole of Europe, and we see that it's not the same, the redundancy you need, for instance, in Central Europe, where the network is extremely meshed between France, Germany, Benelux, Switzerland, etc. Or, for instance, if you take the islands like Ireland, or you take the Iberian Peninsula, which is also weakly connected. So this is why, for us, 70%, yes, it's a rules in the regulations. We have a discussion about how to comply, but it's not the end goal. For some connections, you need more than 70%. 70% will be inefficient. It's too low. And for others, it's too high. And this is the discussion we're having today. But in the end, what's important is not, again, this magic number. What's important is what it represents. It represents the willingness to use the network as much as is possible, all while keeping the reliability. The best way to stop the energy transition is if we start to have a reliability of the system that is lower than before. We need to keep it as high as it was. The energy transition will only happen if we keep the competitiveness of the European economy. This comes from a cheap and reliable power available to us.
Very good, very good. João, the Portuguese pains on cross-border capacity. Can you comment
Well, I
on
think
that?
that we have very good examples how this interconnection is important. Not only in terms of market conversions, but even in security of supply. And Concha can help me to reinforce. We had an issue last year in Portugal. As you know, we had a very dry year until November. Our electricity system depends significantly on the hydropower. And we had moments where it was due to the existence of the interconnection capacity that we were able to keep the lights on. And I think that in addition to the market convergence, interconnections, I would say, are, if not the best example, I think they are one of the best examples of a possible KPI for all of us to assess in the future if this energy policy that Europe is developing is being effectively implemented or it's just a policy. And from the TSO perspective, I keep both ideas that Damien and Christian said. I would tend to be a little bit more pragmatic in terms of these magic numbers. We can play with the numbers, we can do magic if it's 70%, if it's the so-called ratio between the interconnection capacity versus the installed capacity of the system. We can do magic about all these numbers, but I would pick the idea that Christian said, that interconnection are a must-have in terms of confidence, that stakeholders and the market agents, they need to believe that they are there. What is, I would say, from the consumer or the society perspective, it's quite difficult to understand and to explain how in 2022 we had an overall wholesale price in Iberia of 167.5 euros per megawatt hour, and in France the overall price was 276. And this as a reason. There is not enough interconnection capacity between the two systems in order for the prices to stay in equilibrium. So I think, to conclude, interconnections are a good, or if not the best example to evaluate if we are in the right direction or not. Yesterday, we got the new PCI lists from Europe, so the project of common interest. I leave a challenge to everyone here, is the projects are there. Europe made a very detailed and in-depth assessment on the quality of those projects. I leave a challenge of how long it will take for these projects to become a reality. I mean, if in 10 years' time we are still discussing that most of them have been lost, or if some of them have been implemented. And this, for me, it's a must in terms of all what we are speaking, all this idea of civilization to put forward on the energy market and the energy policy in Europe.
Thank you, João. Concha, can you comment on this, on your neighbor, France?
Well, our common neighbor.
Our common neighbor, yeah.
For Iberia, I think. Well, first of all, I fully agree with this sharing spirit, and for the electric system, sharing involves interconnections. We can talk about this 70% or several magic numbers. I fully agree with some outcomes of market giving us the main idea that I think all here we can share. The Iberian Peninsula is a very, very weak interconnected system with the rest of Europe, and we are common goals in order not only to fix a pattern in terms of Iberia is going to export continuously renewables to the rest of Europe or something like this. Interconnections go beyond this. System operation involves very different situations, changing not only by seasons, but changing by hours. We are experiencing that, for example, in this interconnection between Iberia, Spain, and France, things are changing every day. We are exporting, importing, sharing support for balancing services all time. The final figures of mean values is only showing a part of the tale. So I think it's very important to show as clear as possible what are the benefits for future interconnection. There's a cost-benefit analysis, but not very well explained, or at least very well understand for everybody. We need to fix this analysis, adapting them in order to give reasons for local partners and sharing benefits where the benefits are allocated. They are always allocated in both parts of a border. I think it's a question of explaining it very well to the society, because we are investing in our security, investing in our efficiency, investing in our sharing, and there are benefits for all actors. And this should be explained. I think TSOs, as a primary phase, there are the deployment phase after this, we need to get involved all society, all grid user actors in the system, in the electric system, in order to get a common thinking. We need interconnections. And if we talk about Iberia, of course, our main interconnections, and I'm not paying attention to for Spain, Portugal, but I think this is a success case and not the success case between Iberia and rest of Europe. We need to foster the reinforcement of this interconnection. I think everyone knows we are just starting the construction of a new interconnection between Spain and France, the Biscay Gulf. Someone can think, okay, that's okay, we are going to go to 5 gigawatts. Very good number. Okay, I have a desire. I need to explain that this is not enough. It's far from being enough for all this efficiency and sharing. We are talking, France and Spain, and of course Portugal is participating, about 2 new interconnections additional to this Biscay Gulf, because if we are talking about magic numbers, it should be around both 9 gigawatts of net transfer capacity in the interconnection between Spain and France. We are now about 3.5. So we need to foster, to make real this interconnection in order to foster the participation and the provision from Iberia to the rest of Europe, and on the other side, in the other sense too. I think it's a clear message, and we'll try as TSOs to give it clearer and giving this explanation in order to get the compromise of everybody for this.
Thank you, Concha. Christian, you want to make a small comment?
To come back, not to comment on the specific issue about the lackluster level of interconnection between the Iberian Peninsula and France per se, but more bring an insight or some reflections I have from different trips across Europe. And you were quoting the price differentials between Spain and France right before, João. I have an impression sometimes that this is a tricky conversation in different parts of Europe. If you're a high-price environment, you would think that the socioeconomic math would say, well, let's interconnect more and benefit from a lower price resource. That's pretty basic economics. But then some will say from the political level, I don't like the sound of that because then I become structural dependent on those imports and I don't control the resources. That's arguably why we have the EU with market frameworks, etc., but there's a constituency from that. Obviously, then there are generators in that jurisdiction who look to be outcompeted by the better priced resource, as it were. And that's probably a valid point of view from the generator's point of view, but not necessarily from a societal point of view, if you were to ask me. Then there's the low price jurisdiction, and I sometimes come across the notion that, okay, well, we have an attractively priced resource, let's share it, let's export it, and earn the associated revenue. But then often there is a constituency in that particular environment that says, no, let's not do that. Let's keep that lower priced resource for ourselves because that's good for households, good for industrial competitiveness, etc. Which from that, let's say, perspective in itself is probably a legitimate view. I would argue from a societal perspective, there is socioeconomic benefit, and as long as you redistribute some of the revenue, you're better off in the aggregate, as it were. And I think this is sort of maybe at the political level, the conversations which sometimes comes, these different types of perspectives where sort of the understanding or the deal a little bit needs to be, if we want to move in this direction, is we can make this work both for those who are in a more structural import and those who are in a more structural export type situation. I'll close with a bit of anecdote from my own country. I'm Danish, from Denmark, and for whatever reason, we have a huge export of bacon. We have it to the rest of Europe, we have it to the US, we have it in Japan. I don't know the economics of bacon, but it seems to be going well for us. And so sometimes, once in a while in Danish politics, you have this somewhat fringe standpoint that why don't we restrict the export of bacon so as to lower the price of bacon? That may be a near-term laudable goal if you're a fan of bacon, but I would argue maybe some of the bacon producing capacity over time would find its way out of my own country and move elsewhere if one were to do that. Right. So I think that's part of the discussion, albeit not in bacon terms, obviously, but in somewhat more sophisticated terms at political level in the next coming years. Can we make this work, given the different constituencies and thoughts? I just wanted to add that as a broader perspective, not focusing specifically on the
Thank you. Thank you, Christian. So Kocha was talking about this idea of sharing, again, and the idea of sharing between countries, between member states. But the grid also allows to share between not just bidding zones, but also locally. So one way of looking at it, and it's a way of getting public perception, the public perception right about the importance of the grid, is looking at the grid as a way of sharing in space, by opposition of other ways of sharing, which is sharing in time. So if I have a surplus of energy in one place and the deficit in another, the grids allows us to share in space the deficit of the surplus in one zone with the deficit of another. The other way of doing this is to share in time by building a storage facility. So the storage is a way of, so I don't need it now, so I store it in time and use it later. So those two ways of sharing can be interchanged, and we need both. Okay, so this is just to talk about this interplay of centralized utility scale generation and the decentralized resources. This is an important thing. And this idea of the localized balancing and energy sharing, that is key for the future here. So the question is, in your opinion, what are the no regret options we can put in place now that would allow each other to play their role for the benefit of all? Concha, I start with you.
Well, I think it's clear no regret option is to develop a strong grid, very well explained, very well based decision, because the time for developing the grid is longer than all the other processes we are experiencing. So this is first. When I talk about transition, I think this is a good recipe when there are many ingredients. We are not talking about one factor and not the others. I want to point this. We are talking about grids, storage, of course combined. We are facing a complete different system where our resources are linked to meteorological conditions. We are facing a completely change of the game, of the flux, the power coming from one places to others. And we will need all tools. And we are not only talking about centralized tools. I think there should be a common centralized vision, but allowing the participation of any that could provide a service to the system. And that involves different points. We are talking about grid, the way we are sharing all these behaviors. We are talking about storage, because sometimes we need additional delay in time, we can say, but we need observability. I'm going to say it again. We need to give all actors the possibility of playing a game. And this involves not only thinking about, for example, for renewable production, being a provider of energy. We need renewable generation providing balancing services, providing non-frequency services, being able to support certain circumstances in the system when there's a short circuit. We are not thinking about having a back solution for renewables. We need renewables taking part of these renewables, demand, consumption, and so on. And that means very well-linked communications with a global visions. We are talking sometimes about possible solutions at a local level, but we need the upper level and the coordination level. We need to change our mind involving, I've said, demand. In Spain, we have worked a lot of on it. For example, we have pilots. We had finished a pilot on voltage control for renewable generation. It's foreseen to have a new procedure in order to share this participation and not relying on classical generation, for example. And we expand this pilot to consumption because we need both. I think one of the main images we should change, TCOs are interpreted or are seen as controllers and not as facilitators in order to coordinate all actors. That's our role. I think we are very valuable, and all of you are valuable, but we need this coordination. We are talking about distributed or dispersed resources, but we should go all together in a coordinated way to reach the goals. And that's important. Technology is helping us. Communications are helping us. We need liquidity, participations, engagement. And that's what we will provide, our technical knowledge and the path in order to coordinate all these efforts. I think is the main message I can give. All should be together, but all of us will be coordinated, national, European, and so on level.
Thank you, Concha. Thank you. João, how do you see this coordination between local markets and centralized? You have an opinion?
I'm probably going to repeat many of many things that Concha has just explained. If sharing is the must-have word of this panel, I will try to add a second important word, which is flexibility. And responding directly to your question, I think, and bringing up what I tried to say on my first intervention, we have two very active and important stakeholders in the energy world. It's renewables and consumers. They are no longer passive, they are active players. And if they are active already in what we call the traditional market, the consumption of energy, we need to bring them strongly, a strong participant in these secondary markets, in these reserve and ancillary service markets. These markets are markets that are quite technical. They are not known by many people, but they are absolutely essential in this move into this renewables world. And if you want to ensure a stability and if you want to ensure that to keep the lights on all the time, and at an affordable price. And I give you an example, a specific example that happened in Portugal last summer. Due to the stronger penetration of solar, we had a day where solar combined with some wind, we were in some moments of the time, together with the articulation with Spain, we were above in terms of generation versus what was the consumption. So as a consequence, the wholesale price went to zero. It's normal. More offer, less demand, prices dropped. But at the same time, our dispatchers in our national control center, they were paying a fortune to traditional generators for them to provide the reserve to the system. Because if things were going well on the direct, apparent direct issues, like the energy generation, things could go wrong because suddenly we could have a sudden drop, and that happens, sudden drop of wind or solar, and we would need to have the backup, the necessary backup to immediately respond. As renewables are not, it's not mandatory for renewables to participate in these ancillary service markets, and because they are not so well-known markets, this was generating something that is completely difficult to explain to a normal person, which is you have a wholesale price is zero and you are paying a fortune to traditional generators to give the reserve to the system. So, to sum up, bring these new active players, renewables, and consumers by aggregators and other ways of bringing these active players to provide flexibility to the system. The second word is the time sharing. Until now, I thought it was called storage, but now I will call it from now on time sharing. Storage is something that also needs to be addressed at the political, the energy policy and regulatory level. If storage is not a very powerful instrument, even for TSOs like Renewable or REN or other TSOs. We totally understand that storage brings a question mark, which is storage is a powerful instrument that can interfere in the market development. And of course, TSOs are forbidden to participate in the market. That's the rule, and we all comply with the rule. But storage can have also some other benefits, like solving constraints in the grid, like anticipating new elements in the grid, and we should work with policymakers and regulators to open this possibility of having storage or time sharing in the system, also to bring flexibility and to bring a better response as the TSOs have to do it.
Thank you.
Let me give you only some figures about renewable participation in these services, and not only giving energy. In Red Eléctrica, we were quite fast beginners in terms of a renewable control center, and now the benefits are shared not only for the operation, the TSO, but for renewables. In real-time congestion management, for example, in this year, the share for wind production and photovoltaic production is about 30 and 25% of this part of ancillary services in Spain. When we talk about balancing energy, replacing reserves, we are talking a share from photovoltaic and wind plants, about 40% of these services. And if we go to secondary reserve, one of the most technical services, we are talking about sometimes being 25% share by photovoltaic, for example, these very, very sharp ramps. That's something we should go further, not only in Spain, but in all our operational uses. And that's something that comes from renewables.
Thank you. Thank you, Concha. So, Damien, the other TSOs in Europe also share the same opinions?
Yes, we do. I'm going to give maybe a broader perspective to that. Going back to your question, what are the no-regret things that needs to be done to fasten the integration of renewables into the European system? There are two things, grids and flexibility. Flexibility, I'm going to build on what Joao said. I think you will not be surprised at that. Grids, we already discussed at the beginning. For us, the European Union Action Plan that was unveiled yesterday, it's a very good step in the right direction. Those are all no-regret things to start. It's a start, but this needs to be pushed, this needs to be encouraged, and this is something we are going to work with all the institutions in order to make it happen. Flexibility. Flexibility is really the key word for tomorrow for renewables. Within N2E, we define flexibility as everything that is going to compensate the weather dependency of renewables and the complexity of the system. And which means that we will put services, we will put consumers, we will put storage, we will put all the different things that can come into that. And flexibility will be essential, because otherwise the system will simply not work. And we believe there are two kinds of flexibility that will need to come into that is what we call short flexibilities and long flexibilities. To be clear, storage will be clearly one of the solutions to that, and the participation of consumers. I was with my friend here in Berlin on Monday in a workshop organized by the German government on contribution from electric vehicles to the flexibility of the system, how to unleash them. And there is huge potential there. There is really huge potential there. To give you an example, every electric vehicle has a battery. You buy the vehicle because you want the vehicle, not because of the battery, but the battery is there. If you can inject 3 kilowatts from one electric vehicle, you put 1 million of them. 1 million is nothing compared to the figures you will have in the next 10 years. It's 3 gigawatts. 3 gigawatts, it's, the reserve is much more than the reserve that Joao is calling every day. The problem with them is that they are going to last only for a few hours. And so if you don't have wind for 3 weeks, vehicles will not solve the problem. So you will need the other kind, the long flexibilities. Long flexibilities that are carbon neutral, there are not so many of them, is hydroelectricity and hydrogen. Today, they are the only two we have. Iberian Peninsula, particularly Portugal, you have a lot of potential of hydroelectricity. You will be very lucky about that. Hydroelectricity will be the gold mines of a carbon neutral future. You can quote me on that if you want.
I will.
Not every country in Europe has the luck to have rivers and mountains in order to have that, so hydrogen will be part of the equation. For this flexibility to happen, you need two things. You need the technology to be there. For instance, electric vehicles need to be possible. You need to have the possibility, physical possibility, for them to fit into it. You need to build all these flexibilities in order to happen. The second one, as you said, you need a market design that is going to give value to that. That when you have your electric car, you will have a monetary incentive to use it. And it should be there, because the cost is very high to the system at some moments. But you need a whole value chain to be built into that. You need a market design that's going to provide value to those kinds of flexibilities. And what we believe at ENSOE, just to finish on the market design part, for flexibilities, the market design reform that is now on the table have very good provisions going into this direction. It will not be nearly enough. This is a topic that will need to stay open into the next commission, so we can have a market design that is going to provide value to all these flexibilities to happen. No regrets, the things that are already in the place. These are the things that need to happen if we want to build this future carbon neutral system for the whole of Europe.
Your comments on this?
Yeah, thanks. I'd align myself with several of the statements. I think the key no regret in the sense we don't know what the share of big utility scale centralized solutions will be in an interconnected Europe vis-a-vis what will be undertaken and done and dealt with and solved, quote unquote, at the local level. We don't know that share. That will play out in real time and will be influenced also by relative economics and technological innovation and policy, obviously, policy preferences. So the key no regret for me is exactly this, of enabling participation at the in the localized environment, enabling it. I'll give you a few examples of what some probably a bit surprising barriers today. There are 12 member states across the EU today who have less than 25% rollout of smart meters. That is going to be tricky, isn't it, to deploy distributed assets also in urban environments. We have 9 member states today who lack in their national policy framework and a definition of aggregation. Then it's going to be difficult to come in and come with an aggregator value proposition and start gaining business. This is a bit odd. This you don't need to wait for Brussels and other entities to do. You just need to get on with it, basically. Obviously knowing that it looks differently from country to country. I agree completely with what you said about the system operator role being a facilitator and a coordinator, not a controller, etc. I think that's exactly right. One of the takeaways from this meeting in Berlin that Damien and I were at, which was like a regional roundtable trying to get bidirectional charging or EV assets to be a participant in the electricity system of the future, is there is so much technology and business innovation out there, just needs to be facilitated and enabled, and good stuff will come. And that's also why, I don't know if you were mentioning this, personally I would be a bit skeptical as to whether system operators should own some of these storage assets in the future, because I could see a risk that could maybe come to the detriment of some of the private players coming into the market. It may look different from jurisdiction to jurisdiction, but that would be one initial sort of hesitant caution I would have. So this issue in the no regret about enabling participation also at the distributed level, there is a surprising amount of barriers across the 27 EU member states, not because of malicious intent necessarily, but there is a legacy framework, and there are some things which are being done by certain policy priorities which have inadvertently a negative effect on the level of flexibility. That's sometimes how public policy works. But what we try to advocate as ACER, at least bring it on the table, have it looked at, have it discussed. Should this be changed, or should it be kept exactly the way it is? And then each national jurisdiction will make their own choices given the different priorities that they may have. This is something we invest quite a lot in. So in 3 weeks from now, we'll have a relatively comprehensive report on this barrier mapping to demand response and distributed asset participation. Will come out in mid-December-ish. Not as like this type of hand-scolding hand from an EU agency, but rather as an informational tool with which one at national level can discuss whether this set of barriers is something we should adjust and change or whether we should keep as is.
Thank you. Thank you, Christian. We are running late, so we are 20 minutes behind the schedule. So, but we have questions from the audience. Some of them are very specific, and I think the authors of the questions may address the question to the members of this panel if they find them in the coffee break. But there is one, I will take the chance just to read one of them. Mm-hmm. And I don't know who wants to reply, but the answer, but the question goes like this. Shouldn't we analyze interconnections with Europe in a different way? New ideas as big submarine cables should be considered to connect to other countries. So we have this idea of the British, right, of the UK being is planning to have a cable to Morocco, right? Mm-hmm. Is that so? I think the question goes in that direction. Should we consider to make those big interconnections with submarine cables between countries that are very far away from each other?
If I may start, and then, of course, and we are already doing it. If you look at, and so we publish every 2 years what we call the 10-year network development plan, where we put all the interconnections that are going to be needed with Europe. There is always a strong push on the Iberian interconnections, but we have a lot of under-the-sea cables being planned. Two of the main ones, if I may give an example, one is from France to Ireland, and this is going to start to be built very soon. This comes from the Brexit, so that Ireland can have a direct connection to the continent. If you see at a map, you see that there is a huge distance there. And probably the record-breaking, there is a plan also in the TYNDP to build an interconnection between Greece and Cyprus. Connecting the island networks. To today, clearly, yes. And the number of interconnections that are being built in the North Sea between the UK, the Nordic countries, and the north of the continental Europe is huge. And will also be used, and I think this is probably something, I don't know in Portugal, but I think should be used also to connect wind electricity, offshore wind.
Thank you so much. I think, thank you, Concha, thank you, João, thank you, Damien, thank you, Christian. Let's take a pause then. Thank you. Thank you.
Convidamos agora a fazer uma pausa e a aproveitar o primeiro coffee break do dia. Marcamos encontro novamente às 11h45 para o painel O Impacto do Net Zero Industry Act para a transição energética. Que futuro para a indústria da energia renovável europeia. Até já. deve evoluir para acompanhar os objetivos europeus. Recordamos que podem participar diretamente em todos os painéis através da aplicação de suporte ao evento, à qual podem ter acesso utilizando o QR Code do vosso badge. Chamo agora o painel Giles Dixon, CEO da Wind Europe, e Valburga Emstenberger, CEO da Solar Power Europe, estarão acompanhados por Joaquim Nunes de Almeida, diretor da DG Grow da União Europeia, e o moderador da sessão, Pedro Almaral Jorge, presidente da direção da APREN.
All right. Good morning once again. We are now going for our second panel in the morning. The panel structure will have two initial presentations, and then we will have a debate regarding the Net Zero Industry Act. So please, Giles, the floor is yours.
Thank you very much indeed, Pedro. Good morning, ladies and gentlemen. Wind energy is 17% of all of the electricity we consume in Europe today, and the EU want much more of it. This is the capacity we have today. Dark blue is onshore, light blue is offshore. By 2030, the EU wants this amount. By 2050, this amount. But today, we are not building enough new wind farms in Europe to meet these targets. This is what we have built in each of the last 3 years. This is what we expect to build in each of the next 5 years. If we wanted to hit the new 2030 targets we have, we should be building these volumes. And even if we did that, we'd still have a lot of work to do in the last 3 years of this decade. Why are we not building enough? Because of bottlenecks in permitting and grids. And the fact the volumes are not enough is hurting Europe's wind energy supply chain. The supply chain is hurting also because its input costs have gone up in the last 2 years, higher steel, commodity prices, and so on, and yet its revenues have not gone up by the same amount. It's also facing increasing competition from Chinese wind turbine manufacturers who are starting to win orders for wind turbines in some corners of Europe. Now, the vast majority of all of our wind farms that we're building today are still made in Europe. Very good. But we have a crisis in Europe's wind energy supply chain. Here are some of the newspaper headlines. Most is still made in Europe by these 250 factories, making all the different components you need for wind turbines. And you have some very important factories here, of course, the blade factories in Viana do Castelo and Vagos, the tower factories, CS, their facilities in Cerveira do Voga and Alvero, and then the Vestas Engineering Centre in Porto. And the European Union is very clear. Europe's wind energy supply chain is the jewel in the crown of Europe's clean energy manufacturing. It's the one thing that is still primarily made in Europe. And it must continue to be made in Europe. And the EU want this supply chain to grow, because we've got to make more turbines to build all these new wind farms that the EU and national governments want to build. And that means a clean energy industrial policy. It means the Green Deal Industrial Plan and the Net Zero Industry Act. This act has a lot of good things in it. The EU have given us more flexible state aid rules. National governments can spend money now in manufacturing, which they couldn't before. They can give investment tax credits, for example. Net Zero Industry Act also says governments must stop doing their auctions on price only, because that drives a race to the bottom that's no good for anybody. Instead, the auctions should value and reward the extra things that the European wind industry offers on sustainability, recyclability, how we can work together with batteries and electrolyzers and all of that stuff. Good, get that in the auctions. And then the Net Zero Industry Act says the EU must be able to make 36 gigawatts of wind turbines every year. Today we're slightly below that. This is all very nice, but doesn't come into legal force until 2025 at the earliest. And given the crisis we have in Europe's wind energy supply chain today, that is too little, too late. And the European Commission have recognised that. And in September, when she gave her annual State of the Union address, the President of the Commission spoke at length about the crisis in Europe's wind energy manufacturing and said they need extra help. We're going to give them a wind power package specifically for them. New EU funding, grant funding for their factories. The European Investment Bank will finance factory investments. They've changed their rules already. They offer counter guarantees as well to support us. Not only will we have these non-price criteria to decide who wins the auctions, let's raise the bar on who can enter the auctions. Only those offering the really good turbines can enter the auctions. Only those offering full compliance with global labour and environmental standards, full commitments on cyber security, data security, data residency, that the data can only be stored and analysed in Europe or the US. Only those people can build wind farms in Europe. Good. Let's raise the bar. It's what our citizens want as well. And then when you have the auctions, governments, make sure you're indexing the prices that come out so that if there is inflation, those projects can still go ahead. And finally, let's make sure we've got a level playing field. If the Chinese are coming in with unfairly subsidised turbines, no. We will use our large toolbox of trade defence measures to fight back against unfair competition. And she ended all of this in her speech by saying this, very explicitly, made in Europe. That is what the Commission want. Good. And then, a month later, the Commission published the package. It's got 15 specific actions in it that can be taken immediately. The best thing is, we're not waiting for legislation. This is immediate action to support Europe's wind energy supply chain along the lines that I have described. Great. Now, there are some good things happening already out there, not least on permitting, with these new EU rules that have come in with the new Renewable Energy Directive. There's this new legal concept that the expansion of renewables is a matter of overriding public interest. I understand it's in your draft laws. It hasn't yet come into Portuguese law. It must do so as soon as possible. It applies already in German law, and do you know what? We are winning court cases that we used to be losing. People are challenging our permits and the judges are saying, no, they should build this wind farm. It's a matter of overriding public interest. Great. Doesn't matter if we kill a few birds, fish or animals, so long as the overall population levels of different species remain stable. You've got to decide on all the permits in 2 years, and you must digitalise your permitting processes. All of that is now coming into EU law and has to be implemented. The wind power package actually adds a few things onto this, which is all quite nice, and this will help not only wind but also solar. Especially on the digitalisation, there's going to be EU funding now to support the deployment of new software that will help the permitting authorities act more efficiently. And in Wind Europe, we've developed our own software package, in fact, to help this. We've done it with Amazon Web Services, who are the largest provider of IT services to public administration in Europe. And we've started piloting this software in Denmark and Poland. And the civil servants who are processing the permitting applications now using this software say they are 3 times more efficient because they got all the paperwork online now. They can share it with anybody. They get immediate access to every document they want. And it's good for citizens as well because they can log in and see where the project is. It's good for transparency. The Wind Power Package also proposes new actions on the workforce for wind. This is great. These sort of things need to happen. And again, solar will be benefiting from this as well. So the Wind Power Package, alongside the Net Zero Industry Act, it's all about immediate action. 15 actions. Some are for the European Commission, some for the European Investment Bank, and some are for national governments. Now, normally when the EU wants national governments to do things, it brings in a law and it obliges them to do it legally. We're not playing that game. Now, there are no new laws. This is all about immediate action which requires political commitments. And so to secure those political commitments, next month, the energy ministers are going to sign a wind energy charter, saying to the European Commission, thank you for the Wind Power Package. We like it. We endorse it. There are actions in there that you will take, the Commission, some the EIB will take, some the industry will take. Off you go and take them. And there are many actions that fall to us, the national governments. We will take our actions. And that will enshrine the political commitment for the Wind Power Package on all of these actions, and we hope keep the wind industry in Europe. Thank you.
Giles, thank you very much for the presentation. I now pass the floor over to Valburga. Thank you very much, Valburga. The floor is yours.
So, thank you very much for inviting Pedro. I'm very happy to be in Portugal, not just because the weather is much better here than in Brussels, but also because I'm lately mentioning Portugal a lot in my public interventions as front runner when it comes, for example, to energy sharing, a big topic that we're discussing at the moment in Brussels, where there's very nice examples, best practice examples to share with other member states how you can share your own energy that you're producing, not just on household roofs, but also on bigger roofs with people in the vicinities. And the second example I'm usually mentioning is hybridization, so combining solar, combining wind, combining storage, because there's also some very nice examples in Portugal that are worthwhile looking into from others and replicating. So happy to be here. Solar industrial strategy is a topic of today. I want to first start where we stand on solar in Europe. We installed more than 40 gigawatt in Europe last year. 40 gigawatt of solar. That is one other record which has been broken last year, and we are heading to the next records. What you can see here is that we grew some 43% in the last year, and we have further very strong growth ahead. We will be coming up with the latest figures of what we do think has been installed this year in a couple of weeks' time. We're launching our latest European market outlook on the 12th of December. But I can already tell you a kind of a sneak preview that we'll be landing pretty close to our medium scenario that we forecasted last year, which is 54 gigawatt of solar installed this year. So yet again, a 2-digit growth up from last year. And we will be further growing. So it doesn't stop here. We hope to have around about 100 gigawatt installed yearly installations by 2027. If nothing is coming in our way, and you know better than I that there's a couple of challenges that need to be tackled. Grids have been mentioned already. Permitting is an issue also for solar, and trade defense measures. At the moment, my biggest job is to make sure that we do not get import tariffs again in Europe, completely ruining the solar market. So we need to make sure that this is not happening again, because it is just a lose-lose strategy. We've been gathering in the last couple of days basically more than 400 signatures of companies opposing to trade defense measures because it is highly debated again, and this is something that just does not have to happen, because what would happen is that the market would plummet by 30 to 50%. So this is a complete no-go for us. Because we want to head to our 2030 targets. The European Commission asks us to install 750 gigawatt of solar by 2030, up from the 260 gigawatt that we have installed at this point in time. So it is quite a way to go. We do think with the right framework conditions we can even do more. We've always been outperforming our own forecasts. So from our own data, we see that we can land on some 920 gigawatt of solar by 2030. But again, it needs the right framework conditions. But the question of today is, will all of that growth be made in Europe? What you can see here is the Commission's main building. We have our office in Brussels just opposite. And it shows a great advertisement for solar. Why? Because a couple of months ago, the European Commission, together with the Repower EU package, also launched a solar strategy. And it's really great, and you mentioned it, Giles, that some of the things that have been launched already in the solar package are now also taken up in the wind package, and that we're jointly working further on permitting and on many other things that both sectors share and where we need to progress together. But this is really showing the importance that solar by now has. But indeed, will it be made in Europe? And part of the solar strategy was also dealing with an industrial strategy and with reshoring solar to Europe. That is Commissioner Simpson, who already in March 2020 at our Solar Power Summit said we will reshore manufacturing to Europe whatever it takes. And that is the latest statement that also Giles mentioned. The future of a clean tech industry has to be made in Europe. That is from the State of the Union speech of Ursula von der Leyen. A quick fact check where we are today. We have a great proposal on legislations. We will discuss about it later on. But on the ground, what's happening is that we see a lot of those companies who have been really preparing for gearing up and for manufacturing more and enlarging the capacities going bankrupt at the moment. SolarWatt announced 85 layoffs just last week. We have an insolvency in Norway with Norwegian Crystal, and Norsun, also one of the other in ingots and wafer manufacturers, is laying off people as well and has stopped production. So this is what is happening today, and I hear many of the European manufacturers telling me the next couple of weeks are crucial for their survival. So those companies we're banking on in order to reshore manufacturing to Europe at the moment are facing huge difficulties surviving. And that's just to show you, that's a graph taken from an IEA report, that today solar supply chains rely mostly on China. You know that. We rely more than 85% on imports coming from China. And this absolutely needs to change because we need to build up our own resilience. The European Commission has set forward, and we're very much supporting that goal, that we need to have a certain level, 30 gigawatt at least, of manufacturing in Europe again, latest by 2030, and this is what we're all working on. So I said already, there's great proposals on the table. We're discussing them at the moment, in particular the Net Zero Industry Act. What from our perspective is still missing is adequate financing, the state aid rules that need to be further adapted, and happy to go in more details in the discussions afterwards, because at the moment member states are just not able to finance manufacturing adequately yet. But then also establish a European financing tool. I know everyone is asking the European Commission to put in financing into technologies and into all kinds of areas, and there's only so much money the European Union has. But still, if we focus on the key technologies that we need for our energy transition, this is also where the money should go. And then demand measures, where we do think we need to make sure that there's a build-up which creates visibility for manufacturers of manufacturing capacity. And what we are calling for are resilience auctions, specific auctions, which help stepwise to build up capacities again in Europe. And again, this shows that we should not make any mistake when it comes to the measures we're choosing in order to build up an industry again in Europe. Trade defense measures are a lose-lose situation. We know it because we've gone through it. And this is showing you what we have been going through in terms of solar growth, where the solar growth is going down and is going down to 4 gigawatt basically yearly for years, as opposed to the 40 gigawatt that we're installing now. This is when Europe had trade defense measures, when we had the minimum import tariffs in Europe, and we don't want to go back to that anymore. Because there's a lot of jobs, and that's one of my last slides, a lot of jobs which we are providing in the solar industry. We just issued our 3rd edition of the job report that we are issuing now continuously every year. Last year, we employed some 650,000 people in Europe, the solar industry. 84% of those jobs are in the deployment of solar. 7% of those jobs at the moment are in manufacturing. And when I say manufacturing, most of those jobs, 35,000, are in the manufacturing industry, which are producing inverters. So not the core solar chain, it is inverters, which, by the way, also need much more visibility in the whole discussion, because we still have an industry when it comes to inverters. We have some very successful companies in Europe, and we need to make sure that those companies can further thrive and help us to also make sure that our energy security is safeguarded. So most of these jobs in inverters, what we have modeled, if we would go down the road of trade defense measures, is that those jobs would be plummeting by at least 30%. So huge jobs, and 650,000 jobs, by the way, that is last year. We do think that's the forecast that we have, that in 2025 already we'll have 1 million jobs, in 2027 1.2 million jobs, following the growth curve of solar. And this is what we need. So we need to balance those goals that we have set ourselves out, because there's not just one goal that we need to follow. It is both. It is making sure that solar can further thrive, contributing to achieving our climate goals, contributing to achieving our energy security goals, having a competitive Europe with low electricity prices, and on the other side, also making sure that we are not fully dependent from a third country when it comes to sourcing those products that we need for our energy transition. These are equal goals that need to be followed equally and not just one over the other. Thanks very much.
Thank you very much, Walburga. So we're going to start our panel, and I would like to give you, Joaquim, 2 or 3 minutes if you want to have some initial statement. Otherwise, I'll go straight to the questions I would like to ask the three of you.
Talvez fosse só fazer uma introdução em português sobre quem eu sou. O meu nome é Joaquim Nunes de Almeida, sou diretor no DG Grow, que é, digamos, o Ministério da Economia da União Europeia, chamemos-lhe assim, na Comissão Europeia em Bruxelas, e sou responsável sobre net zero e matérias-primas. Portanto, tenho imenso gosto em estar aqui, agradeço imenso o convite.
Nós é que agradecemos.
Vamos às perguntas, então.
E
aí vamos falar em inglês, não é?
Yeah, we're going to do it in English.
Switch to English.
Otherwise, although their Portuguese is excellent.
No, I know.
Except if you want to say something we don't understand.
No, and the point is we only have 45 minutes.
But they would tell you.
No, we only have 45 minutes, so with the translation, that will take a lot. So basically, now that both Wind Europe and Solar Power Europe made their initial statements, at the end of the day is what do you think are, what does the Net Zero Industry Act offers from the point of view of the Commission, and what do you think as associations that it's lacking or missing for this to actually have a match? And basically what I would like is to get your vision on what problems does the Net Zero Industry Act tries to solve and how does the Commission see it? Yeah. And then the two of you, we can start with Giles and then after Valburga, what do you think it's missing to try and understand on the discussion exactly if we can take some, let's say, initial lessons of what we need to do, what member states need to do, and exactly how fast do we need to go to actually achieve the 40% of manufacturing of new technologies in Europe. Joaquin.
Okay. So, first of all, I think that there are probably two cornerstones in net zero. One is somewhat more classic, which would be accelerated permitting. By saying somewhat classical, I'm not neglecting its importance. It's a very important thing. Just that we understand what we're talking about in the Net Zero Act, the acceleration of permitting is the acceleration of the manufacturing industries of net zero technologies. And the discussion that is occurring between Council and Parliament right now, the trilogues have not yet started. There's still the aim of achieving this clearly before the end of the present political cycle, before the next Parliament's election, is to what extent extend the accelerated permitting provisions to the decarbonization processes of the energy-intensive industries. So is this going to be only about net zero technologies, or are we going to try and bring in as much classical industries as possible into the Net Zero Act? The argument that the member states tell us is, yes, okay, this is great, but our administrations only have limited capacities. You can't tell us that everything is urgent and everything is fast. Where are the resources to process all these things fast? The environmental acquis is exactly the same. The rules that we have to check are exactly the same, and you're asking us to do this at the same time. By the way, it's important also to notice that very recently there has been the political agreement on the Critical Raw Materials Act, which has some connections with this whole story, because it's great to say we want manufacturing industries of solar and wind in Europe, but where do the raw materials that supply all of that come from? So that's also an important aspect to be, and there too, we're asking the member states to accelerate their permitting processes on critical raw material projects. But that's the argument. But what I see as the major novel aspect of net zero is what we call the access to market provisions. I think it's the first time that the EU gives a helping hand to domestic industry by asking authorities that are putting out auctions or are procuring or are giving subsidies to be forced to take into account resilience and sustainability considerations, to ignore price differentials if not of a certain level. It's the first time. i.e., procurement authorities always had the possibility of buying based on price, but they were never forced to. Here there's a discussion going on to what extent will you force the authorities that put out auctions, procure or subsidize, to consider resilience and security of supply considerations. And also the discussion in Parliament and Council is about what resilience means. And the starting point of the Commission meant resilience means if you are 65% dependent on a single source. But that, I think, is probably the biggest, revolutionary, is a strong word, but still it is the first time that the EU forces authorities to give a nudge to Made in Europe.
Joaquin, thank you very much. Giles, I hand over to you. So what's your view on this?
Joachim is absolutely right. The market access provisions are the most important part of the Net Zero Industry Act, and they are revolutionary for the reasons you have just described. So well done, and good luck.
If you start trading compliments, I'm going to grant you. Okay?
Sorry.
No worries.
Yeah.
Go ahead.
Just speak the truth. Good luck also with how you deal with the even more revolutionary amendments you've now got from the Parliament and the Council on this. It's going to be very interesting where it lands. The permitting, Joachim, it is useful what's in the Net Zero Industry Act to speed up the permitting for building new factories, for making wind and solar. Very useful. And it's permitting also for investments in port infrastructure and the other infrastructure we need for the build-out of renewables. Speeding up the permitting for lithium mines, dare I mention it here, and for other key infrastructure needed to reduce our dependencies on China for the critical raw materials.
Absolutely.
That's also very useful. But the most important part of permitting is to speed up the permitting for building new wind and solar. And without that, there's no point in having these factories to make the kit, because there'll be no wind or solar projects to build it for. So that has to be the starting point. All the stuff that's in the other legislation, the Renewable Energy Directive, and so on, is crucial. Now, you mentioned energy-intensive industries. 2 points. They are part of the renewable supply chain. The chemicals companies make the lubricants and the composite materials that are in wind turbines. There's a lot of steel in wind turbines. Plus, the energy-intensive industries want to decarbonise. They want to be running their factories on wind and solar energy. And they agree with us totally that the permitting of wind and solar has got to be sorted out and accelerated. They co-sign our letters now. They used not to like us because they thought we were expensive energy and intermittent and messing up their supplies. Now they can't get enough wind and solar. So when member states say, oh, leave the energy-intensive industries out of that, you should stick to your guns and explain to them why they are integral to this.
Thank you, Giles. Walburga, your turn now, please. So what is there? What is missing?
I cannot congratulate your...
You can. I'm just saying.
No, because I was pretty impressed in the, what you put forward in such a short time frame, because Ursula von der Leyen was making her speech, and then a couple of weeks later you were supposed to come up with legislation, which from our perspective strikes the right balance. You mentioned already, that there's a huge discussion around what technology should be in there. I do think that the Commission has been striking the right balance of putting forward the 5 technologies that you see core in the energy transition and where we cannot lose out and be completely dependent from other parts in the world. So I know that you're challenged in the Parliament and also in the Council to make it much broader, but where do we get to? If we just look at many, many different technologies, we'll just not focus anymore on those who are the most important ones. So this is worrying us, because that means that in the end, we will not get the focus that we will need. And on the market access rules, just to say that indeed, we've been very much welcoming the non-price criteria that you've been putting forward. At the same time, reflecting further on it, we don't think that all auctions, at least not for solar, should have these criteria from the outset. So what we are asking for, and what I mentioned, is that for an industry where we don't have basically a base yet, or sufficient base yet in Europe, and just to highlight, if you would want to have 100% made in Europe solar panel, we would have less than 3% at the moment that we could cover from what we're installing every year, less than 3%, so there's nothing basically. Even if there's some parts of the value chain where we have a bit more, like polysilicon and also modules at the end of the value chain. So we need to phase it in again, and it doesn't make sense from the outset to have 100% of the auctions applying non-price criteria, and for sure not pre-qualification, because then you would not have any solar in auctions anymore. So what I'm saying is we need to really take a very technology-specific approach in this, and not a one-size-fits-all. And for the solar sector, have specific auctions where stepwise we're trying to build up that 30 gigawatt of solar production capacity that we are aiming at. And we should not forget inverters in this whole story.
No, I was going to actually
just to
hand it over
react
to you.
quickly. There was a lot of, I mean, thanks for your compliments. It's having done critical raw materials and net zero, it's nice to get people to tell you that we're actually doing things that interest European industry. It's not every day that the European Commission hears that. Second, I mean, there was a lot of 3 a.m. drafting, Walburga, and I think that there was always something that said, except if there are no local supplies, I mean, in the print. So there are, I think we catered for the I mean, if the resilience, security of supply or sustainability provisions would lead to the dry out of supply, I think that there were enough provisions in the initial proposal to cater that. But I mean, I understand what you come from. I see your point about that you need to act differently depending on how powerful we are on the various technologies and industries. But you also need to find rules that mean something in the end. And what we want to avoid is a situation where we just offer a panoply of choices that then everybody will find very complicated and will do exactly what they do now, which is nothing.
But if you would, for example, set the general rules,
Go ahead.
sorry if I can.
No, it's fine.
And then, take a little bit more time in implementation guidelines to look at it more technology specific and really adapting those rules to the needs of the relevant industry. I think that would be the right way forward, and pre-qualification again for our industry would be detrimental.
And also on your point about being worried about including many technologies. I mean, we're agnostic in the sense that we want decarbonization. If there are many promising technologies, why not allow them to get from favorable permitting and favorable access to markets? What does it take away from you by giving something to them?
Funding? Just funding.
It's about funding in the end. Yeah.
Funding, yeah. But we don't have any automatic provision on funding coming out of net zero. So,
which is a pity.
But there is one point that...
If ocean will demonstrate to be a great thing in the next 10 years, well, let it.
Oh, of course.
You see?
We hope so.
Yeah.
We are betting on it.
I know. You're good at the ocean. Yeah.
We are betting on it.
In practice, Joachim, nearly all of the renewables auctions that happen in different countries around Europe are technology-specific auctions.
Yes.
And national governments set the rules for different auctions.
Yeah, so that should
and so it's quite natural that they will be setting different pre-qualification criteria and post-auction award criteria, non-price criteria for different technologies.
Before we go to the second question, I would just like Joaquim to comment one thing that Giles mentioned, which for us as electricity generators is quite relevant. Because at the end of the day, speeding up the license and permitting of manufacturing capabilities for technologies for net zero is absolutely relevant, but industries, they need a pipeline of orders. So in order to have this pipeline of orders, that means that we need to speed even further or faster the license and permitting of the generating systems, being solar, wind, batteries, electrolyzers, you name it. Is DG GROW doing anything to try and speed up also the license and permitting of the renewable power stations up to a point that you can create a link where you are always licensed and permitting more projects to make sure that you are filling the manufacturing capabilities with orders, trying to avoid that anyone goes bankrupt?
DG GROW is responsible for the manufacturing of the technologies, but the deployment of technologies, I'll give you a slightly bureaucratic reply, but that's the truth of the matter. The deployment of such technologies is is under DG ENER's remit.
Yeah, but without being inconvenient, do you think that those dialogues between DG GROW and DG Energy, they are, I'll end over to you.
They're perfectly aware about the permitting issue being key for sorting out this issue. That I'm sure. I mean, there was somebody this morning that said that 80% of the time of the relevant people was spent on getting the approval of local communities to projects. And I think everybody recognizes that we've got a permitting bottleneck that is slowing down the deployment of renewables.
Rakim, your colleagues in DG GROW are doing some fantastic work to speed up the permitting of wind and solar. The Single Market Enforcement Task Force, SMET,
yes,
you call it. It's helping member states on how to apply single market rules in a nice way. It's not that we're going to take you to court, frequent commission approach. It's helpful advice. And you have decided, your colleagues, that renewables permitting is a focus of your activity under the Single Market Enforcement Task Force. Fantastic. Yeah. And you're working with the 27 member states, giving them best practices on the nitty-gritty of their permitting rules and procedures. Things like positive silence. You should all have this principle. Different permitting authorities, if they've not responded on a permit application by their deadline for comment, silence equals consent. And you're pushing this actively. And Valburga and I spent a whole afternoon on Monday with the Italian government, with your colleagues, pushing all of this stuff. It's great. You're doing some really good stuff.
Thank you. Another compliment. I don't know what's going to come next.
Be aware. Suspicious.
Be aware. If you compliment you twice,
it's getting suspicious.
Okay, I would. So let's focus on another topic also inside the Net Zero Industry Act. And basically, what I would like to have your opinion on, and we can start with Valburga, is Net Zero Industry Act provisions aim at facilitating funding and financing for the net zero manufacturing projects and technologies. Is the funding and the financing leverages sufficient to support the industrialization of net zero and strategic technology? Or is Europe at the risk of jeopardizing the objectives of NZIA due to the lack of funding instruments when you compare this with other world markets, and the ones that we are benchmarking in APREN is the US and Japan? So please, Valburga, 3 minutes.
So if you ask European manufacturers whether they want something similar to the IRA, they would immediately say yes, because it's very straightforward. But Europe is just working differently. So what we have is state aid rules that have been adapted in order to accommodate for more funding for industry. In the past, there was just no possibility to fund any manufacturing in Europe because we had some very stringent rules when it comes to state aids and competition rules. So that has been eased now so that member states can invest in manufacturing capacities. At the same time, we're not there yet because the state aid rules at the moment are only allowing for CAPEX support, but not for OPEX support. Even if we're talking to your colleagues, Joachim in DG Comp, they are telling us, yeah, but if member states would just file a state aid request, we would look into it and would see whether we could maybe also grant OPEX, but it's just unclear. And then it is also very unclear just because it would take such a long time in order to get clearance from your colleagues in DG Comp. It takes more than a year, and that's already a fast procedure, I was told, in order to get to know whether you could get funding from a certain member state, and it's overly complicated. Companies are telling us that in order to get this clearance from DG Comp, they would first need to prove, and that's the so-called matching aid, they would first need to prove that anywhere else in the world they would get a certain amount of funding. So first they need to go to the US, ask them how much funding they would get there, that takes some time in order to then hand it in to the European competition authorities to get an answer in a year's time, maybe 2 years' time, when in the US you get your answer in 2 months' time. So this is clearly something where, and it's not DG GROW, but this is clearly something where we are lacking behind in Europe, that we can get clearance on state aid very quickly and also be more generous in what member states can chip in. But that's the member state side of things. And there, obviously, you have the discussion. Some member states have deeper pockets than others. And this is something where there's a lot of discussions also happening at member state level. And then the second thing is what we're very much advocating for is to perk some European funding for the key technologies you want to develop in Europe. China is doing that. India is doing that. The US is doing that. I know that the means that the European Union has are limited. I'm very happy that Ursula von der Leyen has been pushing this idea of a sovereignty fund, which hopefully at some point, from the step that the so-called STEP instrument we have today, could develop in a true sovereignty fund. In the meanwhile, we have been raising this idea of a solar manufacturing bank, a little bit similar to the hydrogen bank, where you would have some manufacturers which can bid into a platform with the best offer they can make on the products that have been made in Europe, and then off-takers who can bid in with their best price, and then the funding gap. We could look into the innovation fund or other possibilities. I know it's a difficult discussion, and it for sure has to be further discussed in the next budget discussions at European level. And I know it's very difficult because everyone is knocking on the door of the European Commission. But if we really want it, we also need to make sure that there is money to fund what we want to have in Europe.
Joaquim, before I hand over to Giles, do you want to address this?
Yeah.
Please.
So, okay, I'll pick it up from a different angle. So the net zero needs assessment document focusing on the 5 key technologies, or identified as 5 key technologies. There was a big calculation of how much private and public funding there was available to support such industries, and the conclusion was that there was a gap of 10 billion euro to support net zero.
Per year? In total?
In total. Okay. In total. But if you see, if you confront this with the carbon prices are going up, which means that the member states have at this state sort of a wealth of 130 billion euro generated by the ETS price. You've got the Commission's Innovation Fund managed by DG Klima that has 30 billion from here to 2030. I know it's not as easy to use as the IRA. You have to put into a competition, you might lose, but still, it's a sizable amount of money that is there. Why can't we do the IRA? Well, we don't simply have the constitutional architecture that allows for that. We don't have anything like the American budget. We cannot give tax exemptions. Yes, it looks great, but we won't be able to do anything like that anytime soon. And I would also like to remind that the post-COVID RRF fund asked the member states to spend 37% of the 600 and something billion euro on green-related transformation, which is therefore a huge amount of money. What I'm saying is that there might not be a lot of money in the hands of the European Commission to decide, let's do A, B, or C. But there is, what I'm quoting with these examples, is that throughout Europe, in the member states, there clearly is a lot of money that could support net zero. I get your point about the rigidities of the state aid analysis of the Commission. Your example about the matching aid. we indeed need to keep a good dialogue with industry because we have to come with cogent arguments with our colleagues from the Competition Directorate General, in the sense that, you know, we're a bit in a chicken and egg discussion. They say, well, we put out these possibilities, but the member states are not notifying any state aids. And we're sort of saying back, they're not notifying because your schemes aren't attractive enough, and there you go. So you have to, feedback loop here is quite important so that we, possibly if you just allow me, still on the point, on the first point on access to markets.
We have 11 minutes to wrap this up, but I still have a question for you, but let's go.
No, it's just very
It's a huge
quickly.
challenge, but
on
like
the
always.
access to markets thing, I mean, let it be clear. It is difficult for them to be applied by the various Portuguese hospitals and schools buying solar panels. I'm not neglecting that. And there has to be a lot of guidance and support given to the to the purchasing authorities of the authorities responsible for hospitals and schools and prisons in Portugal that want to install their solar panels, about how to do it in conformity with net zero. So I don't want to neglect, but giving the impression that the member state resistances to the complexities of what we're bringing forward should not be respected. I mean, we do need to help the authorities make these provisions understood and applicable.
Giles, on this topic.
2 points. State aid. There is this perception, fear out there that Germany and France take all the money.
Yeah.
And it's unfair. We are talking to lots of small member state governments about using the new flexibility to support investments in wind turbine manufacturing, and that seems to be fine. And if, let us say, Latvia supports one factory and Germany supports 10, 15, 20, well, that's kind of relative to population and proportionate, and that's absolutely fine. There's a fear not just that France and Germany get the money because they got the financial firepower, but also they know how to play the system in DG Comp because they got lots of their national officials seconded in there and they know the people. No, that perception is real. Yeah. In small member state capitals, DG Comp is the big inaccessible policeman. Very different if you're sitting in Berlin and Paris. No. You kind of shape and influence how DG Comp work. Well, indeed, indeed. Now, there's a comms point here. You've talked about the feedback loop, and you're putting your finger on something. People don't know if DG Comp will approve, so they're frightened to apply, and they're frightened not only will DG Comp say no, but they'll get told off for applying, and so they sit back. You need to be communicating more proactively, and you've got to get DG Comp to do this, or somebody in the Commission has got to do this. What is now possible? It's not enough simply to put out a press release saying there's now more flexible state aid guidelines, send us your stuff. No, go out and explain it. And be positive and warm about it. You must do that.
As a nuisance,
exactly, exactly. Right, second point. The Innovation Fund. It's still far too much about innovation.
Okay.
Yeah, there are two problems. One, as you've said, you have to apply, you wait, they process all the applications, you're in an open competition. The IRA has an open door. When you need money, you go. And they will say yes or no, do you meet the criteria? You get your answer straight away. And that's like a competition. You're competing, do you meet the criteria? It's not against your internal rules for you to apply an open door approach, rather than making everybody wait and sweat on whether they're winning a competition that lasts several months. And please get away from the slavish adherence to you must be innovating. It's not a technology challenge, building new clean energy manufacturing. It's a volume challenge. You know how to make solar panels, don't you? Yeah? Yeah, we know how to make wind turbines. Imagine you're sitting in the British government and it's 1939.
Really?
And you know what's coming. You know what the threat is, but your clever scientists have invented the Spitfire. And you know it's a bloody good aeroplane. What you haven't got is many of them. And you haven't got many factories making them. And you just need more of the same. That is where we are today, Joachim.
No. Well, we are not bullying you, okay? And we are running against time, but there is still time for one last question that I would like a comment from the three of you, and we'll try to do it, if possible, 3 minutes each, and I will start with Joaquin. As we all know, strengthening the industrial production capacity of key net zero technology products in the EU will not be possible without a sizable skilled workforce, and Europe is already facing, as we all know, large skills shortage in net zero industries. The Net Zero Industry Act introduces measures to boost the availability of the skills required to pursue the clean energy transition in the EU. How can Europe be competitive with other markets regarding the availability of working force, and how can these measures respond to the EU ambition? And I will start with you, Joaquin, and then Valburg, and then Giles.
Yeah, that's unfortunately one of those that no politician will be able to say, I'm going to settle that problem in 2 weeks. You can decide.
Are there problems can be sorted out in 2 weeks?
Well, no, but you can say, you can say the permitting process for this type of installation will now not take more than 24 months of 12 months. You can decide that tomorrow.
Mm-hmm.
And then it might not happen, but it's illegal. It is doable. But you cannot say, I'm going to be I'll train 60,000 people in the next 2 weeks that are lacking. So what the Net Zero proposes is the establishment of Net Zero academies to start developing these skills. And what we're also offering is, I'll be short, so I won't fill in too much of your time, is to bring these professions within the mutual recognition schemes that you have at European level for regulated professions. So to avoid Portugal saying that, no, we don't want the solar panel installer coming from Spain because he misses this certificate and that certificate and the etc. So to reduce all that, we're trying to bring in the free movement dimension into these professions to allow at least, we can't increase the cake, but at least we can make the cake more fluid so as to have Polish operators going to France to do the job.
Well, thank you.
With less bureaucratic resistances.
Valburga, your point on this, please.
Yeah, I mean, I was already mentioning, how many jobs we need in the solar sector in the next couple of years, from the 650,000 we have today to the 1 million 2 years and 1.2 million in 2027. So indeed, skills is one of the biggest bottlenecks we're looking at, and we're very happy to have the proposal on Net Zero Academy. What we need the Net Zero Academy to also look at is this certification, so that there's more movement in Europe on those skills that we have. So this is something which, anyway, I understand that the Net Zero Academy is also looking at to really harmonize those certificates that we have in Europe. And then I can just, invite the Commission to work with our members who are doing already a lot when it comes to attracting people to our industry. We ourselves, as an association, are running big campaigns around I love my solar job. I can also invite all of you as well to help us, also on TikTok, to attract young people, and solar works. So there's a lot of things that the industry is already doing, and I think it would just be good that we're joining forces here. Okay.
Thank you. You want to comment on this, or can I hand over to Giles? Europe.
When did you set up the Battery Alliance? 2 years ago, 3 years ago?
Even more. I think it was 17. The political idea was long.
Okay, it's been going 6 years, fine. And you have the battery within that academy, which is training people to work in battery factories. That's been going slightly less time. In 2 weeks' time, you're running an event to present the 50,000th certificate already from that battery factory. So this can move.
It can move
fairly
but
quickly.
Not next week.
No, sure. There's other low-hanging fruit out there.
Start investing now.
Sure. Other low-hanging fruit. There's a whole load of coal miners looking for jobs in Poland, Romania. We are actively reskilling them in Romania. At least we'll start doing it in Poland. It takes us 3 months to reskill a miner to work in a wind farm. It's great, and there's public money going into that. Then finally, and this is for the longer term, there's millions of people outside of Europe who want to come and live and work in Europe. This agenda needs to be somehow aligned with the EU's
Immigration
migration
policy.
agenda.
Well, I have no further questions for you, so let me thank you for being here today, for giving us this precious part of your time. A round of applause for our speakers. Thank you.
Avançamos agora para uma apresentação Smart Energy. Pedro Guedes de Campos, Director Business Development H2 and SAF da Smart Energy, falará sobre Green H2 adding value to local ecosystems.
Viva Pedro. Good morning, everybody. First of all, apologies. I realized that I'm stuck between two great performers, Giles and Valburga, and the lunch break, so really sorry for that. And in addition, I'm not indeed the professional presenter that you have seen before. Nevertheless, I have some content, so I hope it's good enough before lunch. My name is Pedro Guedes de Campos. I'm Director of Business Development for Hydrogen and ESAF at Smart Energy. Smart Energy comes with it's an investment firm coming with a business proposal, which is all about green hydrogen, but also different than others, looking at adding value locally. That's why the title of this presentation. I'll guide you through what Smart Energy is, how do we see the Iberian renewables market potential, and then jump into a case study that we have in Portugal, a project that we are developing and that we are highly committed to, which is on e-fuels. Starting where Smart Energy started first, 2011, this gentleman here, Horst Mahmoudi, he founded the company. It's an investment firm dedicated to renewable assets, developing renewable assets, and a very agile company, I would say, as he puts it, well, as you see in his words. We are highly committed to bringing renewable assets in place and being faster than anybody else. So we're building a strong team around this. Most certainly, with this slide, you will already see how such a young company has been gaining human power, but also conquering markets. We are now over 400 employees with presence global presence. I would signal that the American or the Central and South American market is coming as an add-on because we just acquired a company, an EPC company on renewables, and this is where we really got some of the track record in terms of assets built globally. But this company is fully already, let's say, integrated in Smart Energy Group, so it's really a great add-on. And we are highly focused on the European markets as we speak. So we have strong teams, and you see for the number of offices that we have, strong teams in Portugal, Spain, Italy, and Germany. Of course, with the headquarters in Switzerland, so the management sitting there, myself as well, and with a strong pipeline of projects, both on the side of PV and wind, but also on hydrogen and hydrogen derivatives. We cover the green energy project value chain completely, looking at the technologies and really delivering the assets of the future that enable the energy transition. We have 4 pillars, and we structure the teams accordingly. From a project, you see that Smart Energy logo is on all 4 pillars. We were doing this before, and then we have been adding different brands and different companies to make it even more compelling, the solutions that we provide. For example, for project sourcing, we have a highly skilled team in Portugal in those 4 markets that I mentioned before, but we also have Greenfield and Rewatt in Portugal and Greenfield in Spain, delivering assets, renewable assets. In terms of engineering and procurement and construction, we were doing the management. Now we have ProDL, the EPC that I was referring to before, and now we have the skills to really deliver the assets. Asset operation and asset management, we're doing this with our proprietary software. Really fine-tuning the installations that we deliver in order to add value to the electrons as much as possible. And then we are also tapping into the energy trading and sales with specific brands, both in Portugal and Spain. But what we realized, and that's the story, so we started in 2011 with green electrons, but we realized, and Mr. Mahmoudi realized that the more you add renewables into the portfolio or into the market, the more electrons or green electrons will push the boundaries in terms of cheaper electricity price further. And this means that it's difficult to extract value from this. And he realized that, and he wants always to add value. So what he thought 4 years ago is, let's jump into hydrogen. Let's do green hydrogen. And let's make it work and add value via the molecule that can transport the electron in energy content. So that's why he jumped into hydrogen. And that's why 4 years ago the journey started. And we have been developing the team as well on this front. Every day we're growing and growing. And basically we have one big competence center in Matosinhos in Portugal, where both hydrogen and hydrogen derivatives are really thought through and then support the project development teams across those 4 geographies that I mentioned before. But of course, hydrogen is complex. It's complex, it's difficult to handle, and the market is not there yet, especially green hydrogen. So we look at the opportunities to keep on adding value while not stalling our own development. So that's how we end up in SAF, Sustainable Aviation Fuels. Adding value to the molecule, a drop in fuel that can be immediately off-taken, and for which there is already a captive market. So that's the mindset, that's what we do, and that's how far we are committed. So from electron to hydrogen, from hydrogen to sustainable aviation fuels, and in between, whenever it makes sense and adds value, whichever segment we are. As explained, industry is an issue. Renewables came in also from offshore, as you see further on the bottom right. We come with the electrolysis, making it work, using hydrogen via infrastructure mostly with hydrogen pipelines, and then adding value either to the industry or adding further value with CO2 valuing, especially biogenic CO2, but also from the industry until 2040, in order to bring about the drop in fuels that can be used immediately, as I mentioned before. In terms of pipeline, it's in our core markets, that's the pipeline for renewables. Actually, there's the active development assets that we are doing and developing with the local teams, but there's also a big pipeline coming in, which is quite promising and meets the targets that I will tackle just after. In terms of green hydrogen, again, highly concentrated in Portugal, but also Spain. So Iberian market is seen by us as the one with the biggest potential because of the great conditions that we have here. Of course, Southern Europe in general is very interesting. Now we see also opportunities in Germany straight away because of the needs, the market needs up there. And because also increased installed capacity of offshore wind that will again have this same impact in terms of the electron price in the North Sea. Three examples of what we're doing, concrete projects that we are developing in Portugal, fully dedicated to SAF. We have Galileo with 360 megawatt that we're developing close to Lisbon. We have Project Lessa that I will mention later on, and we have another one that adds another 800 megawatt capacity that with the three of them, we can tackle 21% of the jet fuel consumed in Portugal. So that's, look at it on a local perspective. Actually, if you look at the blending potential, because nowadays SAF can only be blended at 50%, we're speaking about 42% market share. It's incredible. The sub-quotas for synthetic fuels, they just eat 35% in 2050. So we are ready. We are ready when these projects are ready. We will be ready to go beyond the sub-quota for 2050. That's really, I would say, impactful at the local level, because there's nothing deterring us from using these sustainable aviation fuels in Porto and Lisbon Airport or even Faro Airport. But there's a story, right? So that it's all about hydrogen, but if it's green hydrogen, it has to be linked with renewables. And the European Union perspective is very important here. You've seen the targets. I mean, Giles and Valburg already mentioned them, but there are the targets and there is the leap that has to be done. So we are in 2022 at 22.5% in terms of renewables, in terms of the energy content of renewables. We should go all the way to 42.5%. This is a huge step. I'm not speaking about the power grid, I'm speaking about full energy consumption. But if you look at solar, or let's start with wind. Wind, we have already 225 gigawatts installed in Europe. We need to go all the way to 440. It's huge, a huge leap and a huge challenge that lies ahead. And then for solar, it's even bigger, the jump, as you see there. And this all aligned with the European strategy for hydrogen consumption. By 2030, 20 million tons, half of it all green hydrogen, half of it being produced in Europe, half of it can be imported from elsewhere. So there's a market share that we are pursuing, and there's a market where we can extract value. But of course, this implies a lot of renewables, so we are very, very happy that we have in our own team and our goals delivering the renewables that come with hydrogen. And of course, there's a challenge in terms of manufacturing. We're speaking about 40 gigawatts per year electrolyzer manufacturing and installed capacity of 100 gigawatts by 2030. So it's a huge challenge. And if you look beyond for 2050, you see also that it is beyond solar. We need offshore. We need offshore wind. Otherwise, we cannot achieve the targets. And we also need storage. And 72.5% of that storage should be on a power-to-X basis, meaning power to hydrogen or to hydrogen derivatives. And this is not me saying, actually, it's the European Association for Storage of Energy that is saying this. And I mean, it's clear, the message is there. Hydrogen will replace natural gas, so that's the point. Now, back to Iberia. Iberia, given its abundant solar and onshore wind, is very, very interesting market. And as you'll see, I mean, better than elsewhere in Europe, but also competitive in terms of renewable electricity with the direct competitors nearby, so North Africa mostly. But also if you look at different geographies, the cost of transporting hydrogen in its derivatives fashion is high enough for us to believe that we have a market by producing it locally. And we don't look only at onshore wind, we also look at offshore wind. It has to happen. So the challenge is huge. We need offshore wind to make it work. Of course, the first auctions should be coming in Portugal, but also in Spain. There's already outlined what would be expected for the months to come in terms of 3.5 gigawatts in the first auction for Portugal and 10 gigawatts until 2030. In Spain, the targets are not there yet. I would just like to highlight from the maps that you see on your right hand, on the right hand of this slide, that the portion of areas that are being covered for offshore are less than half a percentage point of the area that is covered by the macro planning areas in the sea in Spain. So there's a huge potential. We are only tapping just a small portion. And this is very good because it tells us that there's huge potential that we can tap further later on. Jumping into the case study and being aware of the time and cautious on that, the case study on e-fuels, I mentioned before, LESA, the green hydrogen valley that we have and that we are developing in LESA. The goal is to decarbonize the industry and add value with biogenic CO2 into sustainable aviation fuels. And you might have seen that there are different, and you might know that there are different ways of producing sustainable aviation fuels. Our path is clearly on the power to liquid, which means synthetic fuels. We don't compete directly with advanced biofuels because we're not in that market and because we realize that the competition for biomass will be huge in the future. Also, that's the perception of the European Union. I don't have this slide with me, but the quotas, the evolution of quotas in terms of the refuel EU aviation regulation that just came out on October, tells you that even if the share of sustainable aviation fuels should reach 70% by 2050, the growth of the sub-quota of synthetic fuels is much bigger than the one on advanced biofuels. And there's a reason for that, shortage on the biomass. And of course, even if it's cheaper to produce bio feedstock related SAF, there is this sub-quota that allows us to keep on creating a market and keep on going in this direction. The beauty of this is that SAF is a drop-in fuel, already fully approved by the International Aviation Air Transport Association, can be blended already at 50%. All airplanes can do it, and there's already a mandate for that. It will go into 100% soon, once the oldest planes are renewed or replaced, but we're still at 50, and 50 is huge. Keeping the 50% market share on jet fuel is already quite impressive. LESA. Here, this project we structured in three ways. The opportunity was to cooperate and engage in an MOU with REN, the gas and power TSO in Europe, in Portugal. Of course, here focused on gas, because they have an asset that was mostly used for the refinery that existed in Leixões, which is now less used than before, and for which they feel they are keen to repurpose to make it a full 100% green hydrogen pipeline. With this in mind, we look at the opportunities to develop a hydrogen valley, and as you see, the pipeline actually goes under the airport of São Francisco Sá Carneiro in Porto. And so we thought about a coherent project that could handle this. It goes into the port, through the airport, and through an area that has industrial capacity in there. So we thought about a valley that could work, a hydrogen valley that could work on different fronts. Greening the airport, greening the port, but mostly greening the industry and using the CO2 of a waste-to-energy plant that is located just south of the pipeline from LIPOR. LIPOR is the waste-to-energy management entity in the greater Porto area, and they have this waste-to-energy plant. Waste-to-energy plant means that it's not just plastic waste or undifferentiated waste that they burn, it's also organic waste. Organic waste means CO2, biogenic CO2. And biogenic CO2 means a great opportunity to jump into SAF. So that's how we ended up with a valley that comes with greening the port, greening the airport, and greening aviation as well. Not only the hub of the airport, greening aviation as well, and in the industry that goes by. It's a sizable project. We do hybridization with photovoltaics and wind to meet the needs of the electrolyzer. But we are also tapping the grid. Why? Because it's an urban area for which it's very difficult to do direct connection. So we have to go into remote self-consumption mode to really make the case for this project. The difference between the output that you get is related with the load factor that we use the electrolyzer. But the concept is that the more we add green electrons to the grid, the cheaper the electricity will be in the future, and the easier it will be to operate at a very high load factor. This could not, so this is the ecosystem. It could not be done without a strong partnership between the partners. That's very important to highlight. With REN, we have already an MOU. With LIPOR, we are just finalizing, so we will have a three-party agreement. Again, some metrics about the project. Smart energy here comes with renewables, but also with electrolysis and jumping into also the technology to and the technology selection and hopefully operation of the unit that will produce the stuff. Again, key message, strong partners that are fully aligned in terms of objectives of greening their own activities, but also extracting value from this journey. And thank you very much. I hope you see the potential of green hydrogen and how it can create local value. Thank you.
Está terminada a manhã deste primeiro dia de conferência. Agradecemos a vossa participação e esperamos que tenha sido do vosso agrado. Da parte da tarde teremos 3 temas em análise: o ato delegado do hidrogénio, a flexibilidade e as renováveis ibéricas. Passamos agora à pausa do almoço. Lembramos que o almoço volante está disponível no piso inferior e no piso superior da Culturgest. Marcamos encontro novamente às 14h25. Obrigada. bem-vindo ao grande auditório da Culturgest. Damos agora início ao programa da tarde. Antes de avançarmos para o primeiro painel, lembramos que podem intervir diretamente na conferência, votando nas sondagens e deixando perguntas aos vários oradores através da aplicação de suporte do evento. Podem aceder diretamente utilizando o QR Code presente no vosso badge e exposto na sala, no ecrã aqui da sala. Passamos então ao painel, o ato delegado do hidrogênio e a vantagem competitiva da Península Ibérica, no qual irá ser discutida de que forma é que Portugal, Espanha e Espanha se destacam face à concorrência europeia global. Chamo então para o primeiro painel ao palco Ana Barilhas, Head of Iberia and Latin America da Aurora Energy Research. Também chamo ao palco Ana Calhas, Managing Director da área de hidrogênio da EDP, Christian Fodok, Chief Technical Officer da Smart Energy, Sérgio Goulart Machado, Head of Hydrogen da Galp e o moderador da sessão, João Marques Mendes, Partner da PLMJ.
Good afternoon, everyone. First of all, thank you very much to APREN for having me here again this year. Today I will be talking about the Delegated Act and the competitiveness of hydrogen production in Iberia, so both Spain and Portugal. I am Ana Barillas, Head of Iberia for Iberia and LATAM for Aurora. For those of you that may not know Aurora, Aurora is an energy market analytics company. We have grown very quickly. We are about 600 people now, kind of worldwide, and we're fully dedicated to the analysis of long-term energy markets. We have about 12 offices, one of the latest ones in Brazil. So we have a team of about 10 people focused on the Brazilian market and an office in Sao Paulo. So there's a lot of content to cover, so I will leave it there for the Aurora introduction. So first of all, I wanted to set the scene a little bit for the conversation by kind of highlighting kind of the complexity of the hydrogen business model. So obviously we're talking about a kind of profitability of a very complex asset, but beyond that, the interaction of capital costs, which are, of course, on the one hand, the equipment and the installation costs of the electrolyzer, for example, but also any CapEx support that might be available. There are operational costs, and that is both kind of linked to the business model that's used for the production of hydrogen, but also obviously the power cost. And I will be focusing quite a lot on that part of the business model today. And then, of course, there's the revenues, which are kind of the actual hydrogen purchase agreement that you have, but also any subsidy that might be available to the project. I will be using a metric known as levelized cost of hydrogen in a lot of the slides that I will present. And I will probably present you with some caveats about the correct interpretation of those numbers, but let's get to some of those numbers first. So the first thing to say is that it's a complex business model and it's a complex kind of regulatory environment. So hydrogen producers have to navigate a very wide range of standards to attract subsidy support. And this obviously makes the market quite complicated. This is a market and a product that should be, one of the benefits is that it can be transported easily, relatively easily. And obviously the fact that there's not a single standard to think about what the hydrogen, the CO2 intensity of hydrogen needs to be in order to access that subsidy support means that it becomes quite complicated to navigate. The Delegated Act is probably one of the most complicated ones. In fact, it is the most complex. And I just wanted to focus on kind of a little bit of an overview of what the Delegated Act is and what it means for compliance. So to be deemed green hydrogen, there are 3 criteria that need to be fulfilled for a project. The first is additionality. This is compulsory for assets after the 1st of January of 2028. And what it means is that the renewable assets that are providing the energy for the hydrogen project must not have come online more than 36 months before the electrolyzer, for example, in this case. And the RES assets must not be receiving any form of subsidy. The second one is temporal correlation. Now, temporal correlation is, what it says is that the production of the electricity that's used to produce the hydrogen needs to match until the 1st of January 2030, that is on a monthly level, but then it becomes an hourly requirement. It is also important to note that there is a deemed compliance if, for example, the price is less than 20 euros per megawatt hour or 0.36 times the price of a EUA. Okay, so there's a couple, even within that, there's a couple of kind of caveats. And then finally, you have the geographic correlation. This is, what it means is that you have to be within the same bidding zone as the electrolyzer. So the renewable and the electrolyzer have to be in the same bidding zone. And it can actually be in an interconnected region as well, as long as the price is the same or higher compared to where the electrolyzer is. So there's already a lot to navigate from the 3 kind of key criteria. But there are, of course, additional kind of exemptions to take into account. So, for example, if you have an electrolyzer co-located directly with the kind of renewable assets, then you are, by design, avoiding the temporal correlation and the geographic correlation. If you are taking electricity from a grid that's more than 90% kind of renewable, then you're actually avoiding all of that. So you don't need to comply necessarily with any of that kind of criteria. And then if there's another kind of slightly more obscure kind of approaches as well. So you can take electricity, as I mentioned before, if it's less than 20 euros per megawatt hour, or if it has been curtailed. Right, so if there's a redispatch downwards of the assets, then that electricity can be used in the production of the hydrogen. And of course, also if the carbon intensity is less than 64.8 grams of CO2 per kilowatt hour. So in those, then you don't need to meet the additionality criteria, but you do need to meet the others, which you would almost by definition as well. So that's a little bit about kind of what the Delegated Act is and what it says. Now, I wanted to deep dive on kind of 3 of those kind of exceptions. The co-located island mode, the taking electricity from a grid that's more than 90% renewable, and the curtailed power. So let's get into that. So the first thing to say is that the cost of island production, again, this is, you have your renewables and you have your electrolyzer co-located, and there's no grid connection to it. That obviously varies quite widely across Europe. We've done an analysis to identify kind of the key areas in where renewable load factors are the best across Europe, and then done an analysis about what the levelized cost of hydrogen production would be in those areas. There's some error bars in the graphs that you might see, and that's basically a range of load factors accounting for kind of what exists at the moment and how that load factor of wind, of solar, or a combination might evolve over the next 7 years or so. Now, an important caveat to these numbers is the fact that these are representing production cost for hydrogen. Now, we will discuss at some length in the panel. The reality is that the business model for hydrogen is a lot more complex than that. You are going to deliver hydrogen to an off-taker that may not be willing to accept a load factor or a profile of the generation that's consistent with what you would get from a combination of solar and wind. And so you need to account for the cost of storage and the cost of transport. In this case, we're looking solely at the production cost with the purpose really of identifying where Spain and Portugal kind of fit within the rest of Europe. And as you can see, it's Spain and Portugal have some of the lowest costs of production across Europe. There's the first two bars in the graph. Now, the next exception is producing hydrogen in a grid that's more than 90% kind of renewable. And so the only kind of systems that are able to do that at the moment, so that are more than 90% at the moment, are Denmark, Norway, Sweden, and by 2030 it would be Sardinia and another two parts of kind of Italy, the south kind of region of Italy, and Sicily. As you will see, Portugal, for example, based on our analysis, gets to this very important threshold in 2031, and Spain gets to that threshold in 2035. So what we're saying here is that this is a great exception, but the reality is that it's very complicated to build a business model given where we are in terms of decarbonizing the grid at a European level. Now, a couple of things to note in this graph. So you can see that the cost of production in the Nordics is significantly kind of lower than the ones in Italy. There's two factors there. The first is that grid charges, so the cost of actually taking electricity from the grid, how grid charges apply across Europe vary significantly. In the Nordics, you don't have to pay some of the charges, but in Italy you do, and that contributes to the different LCOH shown in this graph. But also the fact that even though the southern parts of Italy are 90% renewable by 2030, they're interconnected to regions that are not, and so the prices actually, and the wholesale prices actually end up being higher than what you would expect from a strictly speaking 90% system. Okay, so there's some, the reality is that within the rules there's a little bit of kind of wiggle room to ensure that, that we don't get any kind of funny things like this one in the case of Italy. Now, the final one and the bit more obscure one of them is taking kind of electricity when it's curtailed. So what we've done here is we've looked at how much curtailment happens at a kind of grid level. So there's two types of curtailment. There's economic curtailment that happens when you decide not to kind of generate because the cost of power is below your variable cost. And there's also grid curtailment, which happens because of grid constraints. And what we've done is we've calculated effectively what the load factor would be in the case of Ireland, Great Britain, and Belgium. If we account for, first, all the hours that are less than 20 euros per megawatt hour, that's in blue, and that plus the hours where you get grid curtailment. And what you see is that even though in theory this is a great kind of exception, the reality is that it only really makes a significant difference in the case of Ireland. Because of the way that Ireland is managed, it's a small island with a lot of renewables, then there is a lot of kind of grid congestion and grid curtailment precisely to ensure the operability of the island. But you need a lot of grid curtailment to be able to kind of make this work. And as you can see, in none of the other cases, this would be a viable kind of solution, looking at, for example, Belgium with a 17 kind of euro per kilogram of hydrogen production cost. So, what does this mean? It means that the lowest cost of hydrogen production varies significantly kind of by country. I think it's fair to say that the most attractive across most countries will be the collocated island mode. And again, we'll talk a little bit about some of those limitations. And so, again, what you can see here is the Nordic countries are better able to benefit from the high renewable kind of grid. Ireland has a bit of a idiosyncrasy in terms of kind of the curtailment of renewables. And then the rest of the business models will depend on collocating renewables. And we'll get a little bit into the details of whether that's with grid or without grid. Again, an important caveat, two important caveats in this slide. This is just production costs, remember, so there's additional costs to get this to the off-taker. And then the other one, and we were talking with the panel about this earlier, is we're talking about 2030. Aurora typically does its analysis in real 2022 euros. That's a lot of inflation to consider when you're kind of closing contracts in the next few years. So just keep that in mind when you're looking at these numbers. Now, very briefly, Aurora considers kind of 4 different types of business models when producing hydrogen. The first one is what we call an inflexible electrolyzer. Effectively, it's taking kind of energy from the electricity grid, targeting a very high load factor. It doesn't matter what the price of electricity is. It's really there just for comparison purposes. Clearly, it's not necessarily compliant with the Delegated Act. Then we have flexible electrolyzers. So these are electrolyzers that do not have a kind of renewable asset connected to it, but are taking energy from the grid and trying to minimize the LCOH. What that means is that the load factor will necessarily not be that high. And then you have the 2 modes of co-location, one without a grid connection, what we call an island, and one with a grid connection. So without getting into all of the details, I think it's clear that if you then look at the different business models, again, this varies significantly kind of by country. Unsurprising, kind of the Nordic regions have the kind of flexible business model. We talked about that. That's the 90% grid element at play. And then we have Portugal and Spain. Portugal and Spain, again, kind of feature very low on that kind of production cost, with slightly different kind of business models. I must say, you know, it's a margin of error at this stage, but I wanted to get a little bit into the details of that and leave you with that. So if we first focus on kind of Portugal. So by 2031, as I mentioned, Portugal meets the high renewable percentage in the power grid of 90%, which is what's required. So you can see the first business model, which is the flexible. Actually, let me walk you through the slide a little bit. So on the left-hand side, we have the flexible, co-located island, and co-located grid. The 3 green colors are 2025, 2030, and 2050. So you will notice, for example, that we don't have anything under the flexible electrolyzer for Portugal in 2030 because the grid doesn't get to the level you need to be able to do this in a RED II compliant way until 2031. So we missed it by a year, so the first one that you see is 2050. And then what you see is kind of the comparison of the co-located island and the co-located grid. Now, both in Spain and Portugal, what you have is very complementary profiles of wind and solar. What that means is that you can achieve a higher load factor for the electrolyzers that are island connected than in most of the other countries in Europe. Now, an important consideration here is that when you're co-located in an island mode, no matter how complementary the profiles are, they're still intermittent and they're still uncertain. And so the reality is that you will have to consider storage cost when thinking about your off-taker in this mode. And that's what's kind of shown just very illustrative as dashed lines on top of the island mode. And then there's a co-located grid in which you can manage some of that volatility with your grid connection. And so we've defined kind of the optimal configuration here, but the key takeaway of this slide is really how we see the production cost evolving in Portugal and in Spain, which are slightly kind of higher. What's interesting about kind of Spain, the dynamics are the same, the complementarity of the business models of wind and solar are pretty much the same. Obviously, power prices are very similar, but with the huge penetration of solar in Spain, we do start to see some different dynamics in power prices. And so what you get is a slightly different kind of LTOH across the 2 business models. I won't get into the details because I'm conscious of time, but the key takeaway here is that Spain and Portugal are very well positioned for the production of hydrogen. They're very well positioned for the production in co-located island mode and co-located grid. Now, comparatively speaking, that's true. Obviously, we'll get a little bit into some of the complexities of the actual kind of business models. So with that, I just wanted to end by saying, you know, obviously RED II compliance is required to participate in the EU Hydrogen Bank. And so understanding what this means and quantifying the implications of this is absolutely kind of critical. The cheapest RED II compliant electrolyzer business models will differ quite significantly by region, but they will also differ quite significantly by project. And that's, when you look at these numbers, that's an important caveat to consider. Storage and transport will need to be accounted for to think about the actual cost delivered to the off-taker. And then finally, the question was, how are Spain and Portugal positioned to produce hydrogen? And the answer is that they are some of the lowest cost producers. Some of the challenges that exist in terms of getting the hydrogen in the right profile to the off-taker will exist in other countries. And so I think there is a lot of potential in the market in Iberia, and probably the need for incentivizing and subsidizing some of the early development is quite critical to ensure that that potential is met. Thank you very much.
Thank you, Anna, for the presentation. So from now on, I will be asking you some questions, and feel free to submit also the questions from the app of this event. I will start with you, Anna. So the new proposal of a reviewed national and energy climate plan suggests an increase of green hydrogen production capacity from 2.5 gigawatts in 2030 to 5.5. And the Spain ambition is also very high. At the same time, or meanwhile, the European Commission published in July entered in force in July two delegated acts regarding additionality, temporal and geographic correlation. Do you consider that these criteria can interfere with the 2020 targets for the development of green hydrogen capacity, or are they welcome to allow legal certainty and avoid cannibalization of renewable energy capacity?
Okay, very well. Well, first of all, thank you very much. Good afternoon, everybody. Well, it's a very long question, and actually it's a very complex topic, so we could spend some time here debating all the questions under the one that you just asked. But when it comes to the fact that we do have regulatory certainty now on the delegated act, I think it's very welcome. Independently of the details of the regulation, having clarity on what it is. I mean, the industry was waiting for that clarity for a couple of years. So at a certain point, we were just, okay, whatever it is, we need to know it. We need to know it because the entire industry is on hold. We're not taking decisions because we do need clarity on the regulatory framework to really understand the implications that in practice this regulatory framework has on the way you design the projects, you set up the projects, like Anna just described very well. So I think it's very good news that we do have both delegated acts finalized. So it was a couple of years of discussions, which is a very clear indication of how contentious the topic was. The second, at least my reading, is that it's also very good news, the outcome in itself. We at EDP, we've been advocating ever since for a strict definition of renewable hydrogen, so in favor of all the three criteria, the additionality, strict temporal and geographical correlation. And I think at the end, the result with the monthly transitioning to hourly correlation, it's a very good outcome because otherwise, if we are not strict on that definition, we risk missing the entire purpose why we're talking about renewable hydrogen, which is the decarbonization. I mean, we're really talking about a product that is highly costly to produce. The cost is higher than all the alternatives. That's why nobody today is consuming renewable hydrogen, because there's no business case. So the cost is very high. So we should not miss the purpose that we're just promoting it and promoting this industry because we truly believe on decarbonization. So we should not do it at all costs. Mm-hmm. So our objective is to maximize the emission reductions and not maximize the utilization of hydrogen. Mm-hmm. So at the end, I think we're very pleased with the outcome. When it comes to the implications on the targets, I mean, the targets are ambitious. I think that what Portugal did on the revision is aligned with what all the member states are doing. So they're all revising their strategies and doubling or even a higher multiple of their initial targets. And this is consistent with the revision that Europe as a whole also made on its own strategy. So it started with Fit for 55, and then and the hydrogen strategy, and then the Repower EU, all of a sudden we multiplied by almost 4 the target of hydrogen consumption. So member states have to follow that strategy and have the ambition. I think it's a starting point, and we really need the policy tools to actually deliver on the policy targets.
Christian, as Anna says, this delegated act allows you as a developer, as an investor, to structure your projects. And two of the means that you have to do so in terms of procurement of renewable energy, electricity capacity, is do it through the grid or off-grid. We know that in Portugal in particular, we have a problem, which is the significant constraint that new wind and solar projects face in terms of grid capacity, achieving grid capacity. Do you think this poses a threat to the development of the green hydrogen capacity in Portugal, or are so-called island production off-site through private wires a means to these ends without losing enough flexibility?
Thank you for the question. First of all, also from my side, great to be here. And I remember 3 years ago, the first time I was on the screen from the COP. I remember I was on all green light, and next week we'll be back at COP, and all we do here is to try to decarbonize and to make the projects work. In fact, the delegated act has, besides having clarity, is great, but the design really needs to take into account all the details. And in fact, once you read through it, you get to a lot of specifics which you need to take into account, which very often are not fully considered. So on the one hand side, there is some timeline now with the routes, so you can try to do projects fast and have some exemptions until certain time, but obviously you need to factor in potential delays as well. So let's say from our side, we try to design already from the start that projects will be fully compliant even without the exemptions by time, and we can go into that rules more in detail, but just for the sake of time, I don't go into detail now. The second thing, in fact, as you say, we started a lot about the co-location from the start. Why? Because as Smart Energy, we are a renewables company, and that was kind of always the basis. We were not familiar with hydrogen production in the beginning, and still are not an expert there, but we obviously team up with partners, teamed up, made a team, so we think we start to understand much better. But our core understanding is renewables. So this is kind of a strong anchor, and this goes into the co-location option, and we started very early to develop such sites which have the co-location option. As long as you have a grid which can help you on top of that, it's beneficial. You can always calculate exactly how much percentage you additionally use the grid to get to which result. And very often the result is not you just take the renewables and then you top it up with the grid to get to 90% and plus loading, but rather somewhere below, because in fact the cost from the grid is a limiting factor in terms of competitiveness. So the less you need, usually the better. Then comes obviously the whole offtake and logistics behind. But I think with playing with these parameters, you can optimize. The other thing is the unsecurity. Once we do a project, very often you ask right away, what is your power curve? What is your assumption on the cost when you get it from the grid? Which PPA you have. So either you have your own resources which are co-located, or you have others you can do your own PPA with under controlled manners, and then the project you have needs to take into account, the renewable project, a certain selling price, and then both projects have a certainty, or you rely fully on the market. And then you have uncertainties which also are a challenge for you to have financing. So you see, there is no one way or the other way. You need to make the project work. If you can combine both, for us right now, it's the best approach. Pure island solution, the main topic is we get low LCOH, but we cannot really match the off-taking side. That's the challenge.
Thank you, Christian. So Sergio, Christian mentioned the possible exemption until a certain time of the criteria set out in the Delegated Act. This is obviously particularly relevant to additionality, but also to other criteria. But you need also to account for delays. So my question is, are you building, and when I mean you, it's you and who you see in the market, building your projects in order to comply with the additionality, despite if they enter into operation before 1 January 2028, they don't need to? Or how are you managing this?
Okay. Good afternoon, all. So let me start by saying that we also welcome the fact that we finally reached an agreement regarding this delegated act. We spent a lot of time debating that. It's not that we are 100% happy about, and we can discuss a little bit why, but we've reached a compromise solution that has allowed us to move forward and actually take FIDs with the projects, as we have done with our first 100 megawatts. Each of these criteria, if we take any of these on its own, they make sense, right? They make sense, additionality and synchronism and the geographical correlation. What I think that we've missed here on this discussion, and it's not that no one discussed this, I'm not sure that we were heard, is the objective is not to produce hydrogen. We're not doing this to produce hydrogen. We're doing this because we have an issue with climate and we need energy transition, and the use of hydrogen allows us to address some, important sectors of the economy that are needed to be decarbonized. And when we look at these criteria, I'm not sure that we've looked at the uses, okay? So answering, and we can go, I think that the most complicated one is with synchronism or temporal correlation. That really poses a question for off-takers. Any off-taker that is meaningful, sizable. And yeah, so we are building our projects. The exemption from additionality might be important. It's not that important for us as Galp, because we are also building our integrated business and we're building our renewables and all that. Might be even more important for some people in the room that are, renewables producers that might be ending up their feed-in tariff period, and because of this might not be an alternative for their production. In any case, so the exemption until 2027, it's okay. I think the most important exemption is, or it's having the monthly synchronism until 2030.
That's a good question on repowering that you mentioned, because obviously there is an exclusion from the procurement of capacity from wind farms and other plants that have received subsidies. But after they repower, if they expand up to or more than 30% of the cost of the initial plant, they are exempted and could be deemed as additional plants. So are you counting on this in your business case? The possibility that some 5 gigawatts of wind in Portugal might be available to comply with these criteria?
But we need to repower. So, and maybe, at least for some time, we wouldn't need to immediately repower because, many of these wind farms would still have, useful time to produce, and they won't have that option if we're targeting this for hydrogen.
Yeah.
But for sure we need this. If we're going to produce, to have anything close to 2.5 to 5.5 gigawatts, we've used not only the best places for wind, but also, the ones where it would be appropriate to build them on, considering environmental impact and all of that. For sure, we're going to need that.
Yeah.
I just wanted to add on the point that each individual kind of criteria makes sense, but a more kind of system-wide vision is important. I know that the situation in Portugal with grid connection is very different to the one in Spain, but if we just take the Spain example, for example, one of the key risks for Spanish renewables, Spanish solar, is the cannibalization of solar. There's just too many projects in the pipeline, and probably a lot of irrationality in terms of how much will get built over the next few years. We've done the analysis, and you need additional demand if you're going to mitigate that cannibalization of renewables. And storage can only do so much. It does a little bit, but not enough. Electric vehicles have a lot of infrastructure requirements that need to happen. Obviously, hydrogen has its challenges, but the incremental demand that it can provide, if you look at it at system level, is not just the production of hydrogen, is enabling kind of more renewables to actually come into the grid because they're economic. So I do think, each of those criteria makes sense, but looking at it slightly wider, and from a policy perspective, also considering that in this is quite important. Because, for example, in Spain, you have pockets of areas in where I think constraints will be a significant kind of issue, but that's not enough to kind of supply a whole electrolyzer, right? And so it needs to be taken a bit wider. The view needs to be taken a bit wider about the economic benefit of the additional demand of hydrogen.
Yeah.
Thank you, Anna.
Just to add something, Anna, as you mentioned storage, in fact, 2 days ago, by Bloomberg, not by Aurora, there was a data study on the storage, giving the lowest price now reached in 137, I think, euro per kilowatt hour. So although so far we only factor in a short-term storage in our projects, I think the trend is continuing. There's also, in this case, we'd heard about innovation this morning. We don't need too much innovation, but some innovation in the storage would be great. If this continues, I think it could really, the share we are so far considering for storage could increase in our projects, helping a bit the situation. Obviously not on long term, not on midterm, but from our approach we had so far, we start to consider more than we thought at the beginning. To help also the grid and the grid stability. You said the concerns we have also in Portugal, this could help a bit.
And just with another question, you estimate that in 2021 our Portuguese grid will be more than 90% renewables.
Yes.
31, exactly. These will in practice mean that we only for a year will be needing to comply with temporal correlation in an hourly basis. So, but of course this needs to be planned because it's hard to meet these criteria. So how certain is this conclusion, and by what time span may it vary in your opinion?
I mean, whether it's 2030, 2032, I think it's harder to tell. I think the reality is the Iberian market, but Portugal in particular, is on track to become decarbonized very quickly. And so, if I just look at our projections for kind of percentage of generation that's coming from renewables, it has steadily increased over the last kind of few years, right? Like technology costs are helping, the speed of development is helping. So I do think there's obviously, it might not be 2031, as I said, it might be a few years before or after, but I think it's, to me, it's pretty clear that the Portuguese kind of system will get there, and I think the Spanish system will follow fairly soon afterwards.
Thank you.
So I would really like to, be completely convinced of that.
Okay.
I cannot stress enough how important that this is for, large-scale use of hydrogen. If there is anything that we could, have policy-oriented to, is increasing this percentage of renewable penetration in the grid. Achieving the 90% makes a whole difference for the off-takers. I'm not that convinced that we are going to get there by 2030. And I'm actually, my skepticism comes from the details of what you need to consider here. For instance, it looks like we're not that far. I haven't looked at the end of last month, but we were just, by the end of September, I think we were 70% or 70% plus renewables in the grid, as we typically look at it. But the way that the European Commission in the Delegate Act is considering this is not that straightforward. For instance, all the imports count as 100% fossil. All the imports. So As we are highly interconnected with Spain, and by the way, we are having more and more imports from Spain because solar penetration in Spain is growing faster than in Portugal, and we are having more and more market split, which, by the way, ruins the geographical correlation with Spain. This target, it looks further away than it might look at the first glance. So I'm really worried about that. That depends a lot on, again, on the speed that we are able to build on the grid, to license and build new renewables, and so.
Yeah, and I think unfortunately where I think the difficulty lies is in the markets that are kind of used to manage the grid, right? So you have days at a time in where you have grids, the market is 100% renewables. The problem is when you look at the sub-markets, the grid constrained market, the technical restriction market in Iberia, then you have a lot of fossil generation because the way that the system is set up is such that it's fossil generators that can provide the services. And the direction of travel, I think, for those markets will be the key to decarbonize or to reach the 90% renewable penetration is my view. Because from an energy perspective, you can see how we get there. But then, to operate a 90% kind of renewable grid, you need to be able to manage inertia, kind of frequency, kind of voltage control, thermal constraints, and all of those things, unfortunately, are markets that are thermal kind of
I think that raises a good point, and I would like to ask in this regard, which is the fact that it will be hard to meet both the temporal and geographical correlation criteria, particularly in this last one, if you have Spain deploying faster solar capacity and exporting to Portugal. So what I would like to ask you is, should players manage and try to meet these criteria for the whole hours in which they buy green electricity, or how can they manage the risk that these criteria are not met? Because additionality is general, you say yes or no, but temporal and geographic correlation, it's unit by unit, right?
Yeah, well, I think it's a very good point that you're raising, and it helps us, maybe go a step further and come to the concrete reality of projects. And every time we're negotiating with potential off-takers, of course, they all come with the concept and the idea that they just want to buy hydrogen that is fully compliant. And if you ask them why, they don't really have a concrete or a very solid answer, because what's the purpose of buying 100% fully compliant renewable hydrogen? I mean, do you really understand the implications of that? Do you really understand the product definition and all the risks that I have to bear on a contractual arrangement with the off-taker to really deliver that product? Because in fact, the Renewable Energy Directive imposes a target of 42% by 2030 of renewable hydrogen that then increased to 60% by 2035. But the reality is that we don't even know the penalties associated for not complying, and we don't know exactly how member states will translate the directive into national law and the implications that has in practice for the specific industries or the specific applications. But there's an optimal, today there's an optimal that is maybe not fully compliant 100% with renewable, and the optimal maybe not 100% compliant, and also the optimal is not 100% load factor. I think you were the one that alluded to that, because I think some people still think that 100% load factor would minimize costs, and that's clearly not the case. I mean, if you increase your load factors, then you go into hours, you will produce into hours where it's really costly. So 100% is not the optimal. So there's an optimal depending on the application, depending on the requirements, depending on the market where you're playing in terms of the power market, which is a balance between really how much you really need to be compliant, the penalties associated for not compliant, and the costly to be, instead of producing 60% compliant, to produce 70%, maybe you go to a different level of costs that it doesn't pay off for the application that you have in hands. So it's much more complex than just the conceptual arrangements of fully compliant. And I think that what Anna presented us in her presentation, all of that was fully compliant. Even the grid connection was fully compliant. So in practice, maybe none of those cases will actually be a reality, because at least the way we're designing the projects, we're not designing them like that.
And the thing is that in geographic correlation, for instance, if you are a hydrogen producer in Portugal and do a PPA with a generator in Spain, and at a given hour there is a congestion
well,
leading
you
to
have
market
to
splitting.
do the math, because if the risk that you're bearing there has a cost.
Yeah.
And if that cost, if it pays off to assume that cost compared with the renewables that you get from Spain versus the one that you have in Portugal, it's the rational thing to do. So depending on the projects, and especially on the starting year of the projects, typically we at EDP were willing to bear that risk, and we're really looking at the Iberian market as a single market and assuming the market split. I think we also have the advantage of really playing with a large portfolio of renewables. So it's completely different when you source your product with a specific PPA or you have an energy management to play with a large portfolio of renewables. And I think that it's clearly an advantage for a player like us.
Christian, do you agree that basically hydrogen producers and off-takers need to acknowledge some part of the production not being fully compliant with the additionality and correlation rules? Do you think there should be a threshold or just price reflected? How do you think that hydrogen producers can manage this?
I tend to agree to Anna that while idealistic case is always nice, and also we saw that the design of the Delegated Act was in the spirit to have a rule which makes it as academically correct, reality, and to make project really work and to make supply demand work needs some flexibility. So I think by real case consideration, we'll get to some mixture where you need to acknowledge. Obviously, the price point then found is in correlation with the percentage, how much is really clean and not clean. I mean, the regulation on RFNBOs allows a mixed production. So there is a part which is clean, which is considered clean, and the other is not clean. So I tend to agree. I mean, we strive from our side to design project as green or 100% compliant as possible. The real challenge, in fact, comes with the off-taking side, that really you can then match the expectations and the demand on the other side, and then you start to discuss compromises and you make it work. So it's really when you get the next step. First, everything looks really perfect, but then you realize, okay, the factory needs to run all the time, the hydrogen needs to come with this balance. In winter time, you cannot just slow down so much in your production. So things like that are essential. And maybe also on the demand supply side, also on the electricity side, I mean, commenting to what also Anna and Sergio said, we consider a lot the electrolyzer as a big load which needs electricity. On the other hand, I think designing these massive loads in a flexible way that they support the grid is almost like having a lot of batteries supporting it. So this should be rewarded. I'm not sure right now how much the design of such mechanisms may be supported, but if you do 100, 200, 500 megawatt load, and then you can offer that you really support the grid by maybe also balancing and not using and responding in quite short term on the grid, you need less battery, or you need less capacity on the distribution. So this is also something which helps to balance. And then with that, again, you can maybe take the advantage on producing more renewable whenever possible, get your renewable share even higher. So this is all interconnected in the meantime. Maybe also the market design is a topic to mention, to incentivize such things, and also battery, and obviously if such services are given by the electrolyzer, there should be a market design giving an incentive.
Yeah, there will be a whole new discussion. So Sergio, on the offtake side, obviously securing long-term predictable offtake is key. Portugal does not have that many off-takers. Obviously, Galpin is an exception as a large consumer of hydrogen already. But do you think that the projects that will be developing more quickly are those located near large hydrogen consumers, cement, steel, glass industries in valleys. Do you think export is a realistic option right now?
It's obviously more comfortable for me as a hydrogen producer than I'm also the hydrogen off-taker. And if you look at most of the announced or the projects or ambition for projects, they typically miss one thing, which is the off-taker. And the off-takers are missing the business case. And we go back to the point that Anna was making, which is, do we need RFNBO hydrogen? We don't need RFNBO hydrogen in the sense that the molecule is the molecule of hydrogen. But the way that the business case is made, which is the incentive that we have to consume that molecule, is brought by a regulatory incentive. And that incentive was very clear. It's either RFNBO or nothing. So if it's not RFNBO, I'm actually spending even more, as Anna was saying, because base load production is even more expensive because you have to go after the hours that are expensive. I'm producing something which is not RFNBO, but I also need to produce it because as an off-taker, I need a stable demand. It will be really hard to have, scale up hydrogen production if we don't account for this, on my view. On what we are doing, so I can give you our perspective, and I don't think it surprises a lot of people that we are, again, actually the ones that have taken a large-scale FID. We are producing where we have consumption. Transporting hydrogen will always be, complicated and expensive, and I actually think that we are quite far away from that. I know that there are other projects that are targeting that, so I sincerely hope that good luck. I see that we have another opportunity here, and looking at what Anna was showing before, and how competitive Iberia can be on the production of hydrogen, and how hydrogen can be important to decarbonize important sectors of the economy. We have a real chance of industrializing Iberia, of bringing the demand of hydrogen near us. We never had this chance before. A lot of the industrial revolution was made after this. Industry followed, competitive access, competitive and secure access to energy. And we now have one of these forms of energy that is important. So I believe a lot more on this, on that story than the story of exporting hydrogen.
I would like you also to hear and Christian your perspective, because you are not hydrogen consumers, so you need to make some efforts to find these off-takers. How are you looking at it? For one project, you have, like, as a base case, a single off-taker, more than one. How do you conciliate these? How are you managing these?
So first of all, let's say it very clear. So we are playing on the entire value chain up to the consumption. So we're not the consumers of hydrogen, and we typically used to say that the off-takers are the most valuable partners that we can get, because that's the missing part that we have. I mean, and of course, all the equipments and all of that we will procure through a competitive process, of course, but the off-taking is the missing link. So we are developing projects in locations where not only we have good renewable resources, but in locations where the potential good candidates to incorporate hydrogen, industrial players, are located. And so I think I agree with Sergio when he says that, I mean, there's no logistics of transport and distribution of hydrogen today in place. So, but there are many opportunities to learn and to decarbonize from producing and consuming locally. And locally does not mean small scale. because you can really produce in this concept of hubs or valleys, where
Like
you can pull
building-
together many different off-takers.
Building a small grid and
nearby.
Nearby.
And so under this concept, we are developing several projects here in Iberia, not just in Portugal, but in Spain. We have 3 large-scale projects that we are developing in the sites where we have coal power plants. So we are closing the coal power plants, and we will become coal-free by 2025. So really, shutting down those power plants and taking advantage of the fact that we have on these locations. So first, we're there. So we're not looking for land, and we have infrastructure, grid connection, water access, all of that. But our neighbors are all the good candidates, the steel makers, the petrochemicals, the refineries, all the large industries that have a hard time to decarbonize. And we've been in those communities for decades. So that's also, of course, a very good advantage for us. We also have human resource that we're training and reskilling towards the hydrogen business. So really believe that on playing like this, and I fully agree that the market in the beginning will start in this decentralized form, and hopefully longer term it will evolve, and these spots will all be connected through the backbone or through maritime routes. But there's still, all of these infrastructures will take a lot of time. And if the transport and distribution for even short distance is already costly, imagine for long term. And when I say costly, maybe just putting some numbers here, because all the numbers that Anna just presented, if you're transporting even short distance to deliver to an industry, and you deliver by road, and you deliver to typically a tube trailer, either you compress it and you transport it in a tube trailer, or you liquefy it and you transport in a cryogenic form on the road, short distance. Even if you do that, just to compress and liquefy, you can double the costs of your hydrogen easily. You can put that 4, 5, 6, 7 euros per kilogram on top of your production cost just to transport it. Short distance. Of course, if you develop a pipeline long distance, thousands of kilometers, the transportation costs will be smaller, but that takes a lot of time to develop those infrastructures. And actually, from the first time that you start developing them, you're conditioning the way the market will evolve, because it's our heavy infrastructure, capex intensive type of assets, right? And if you talk about maritime routes, then it's a different complication, because then transporting hydrogen or liquefied form or organic forms, it's a lot of...
Or even ammonia.
Yeah, Anna, your comment fits very well what I wanted to add. Ideally, we collocate, obviously, and short distance, meaning 50, 100, 150, 200 kilometers already get you in trouble. But if most of our projects are designed to kind of really direct use close by. But if not, then actually, before my colleague Pedro has presented the SAF project, which is virtually increasing the demand at one site. And I'm maybe still a bit proud that 4 years ago I presented at ICAO, the International Aviation Organization, this book and claim system saying this airport here, Porto or Lisbon, doesn't have the demand of 100% SAF, for example. But if you have a rule that somebody else can fuel fossil kerosene, but pay for the clean one, get the certificates, then you can have a much higher demand locally. So somehow you create a demand locally, which is in reality not even locally only there. The others always also would have to comply with that. So this is also a mechanism which the SAF was something which was for us very, very appealing, besides the percentages which have to be reached. There is some specifics on Portugal, because we come now on the topic of CO2 for these kind of fuels. And CO2, besides the challenge to reduce CO2 in the atmosphere, to get CO2 for such projects, to do SAF or to do methanol, is a challenge. And there is a discussion in Europe to make use of waste, which is also non-organic waste, which if you claim for it in the ETS system, countries can kind of until 2040 use such CO2. Then you have much more CO2 for such projects, which already make sense for decarbonization. So that would be now a pledge for Portugal to to also follow that route and be a bit more flexible to allow higher volumes, for example, for SAF or others, where you can use then another, avoid this transport topic which we just mentioned.
So Anna Barides, so when you meet with off-takers, there is usually an agreement until you speak about price, right? So price is a big issue when you speak about green hydrogen. We have two sets of auctions being designed now and when soon to be launched. One in Portugal, targeting injection of green hydrogen into the grid, small annual amounts. Another, still a pilot, but a larger auction at the EU level, targeting the grants up to 800 million euros. So do you think these auctions are the way forward to ensure the competitivity of this sector? Or do you think something is still missing to ramp up these projects?
Yeah, so I mean, even if we just look at the numbers, right? So, you know, I was saying, you know, you can get something like kind of 3.7, just the production cost of hydrogen in Iberia. And I'm saying you can easily double that if you add kind of transport or storage. The maximum bid into the hydrogen bank is 4.5. So I think it's helpful, but I think the reality is that there needs to be a consideration of kind of how many other kind of support schemes can be kind of stacked together, right? And you know, and I was mentioning this kind of before. I think in isolation they're helpful because they're better than nothing, but I don't think they're the answer to help close the gap that we have in terms of the cost of hydrogen production and you know, kind of what the off-takers are willing to pay without a subsidy, right? And that's the big gap.
Do you think the answer will be more at the national level or at the EU level in terms of these grants? How do you believe it's the most probable way of achieving this competitivity?
I think it depends on the political ambition of each country. I think, you know, we're seeing a kind of national kind of support mechanisms kind of sprout. Obviously, Iberia has been pretty ahead of the curve in that. Other countries probably will do less so. So I think it will very much depend on kind of the positioning of each country in terms of producing hydrogen. If there is an area in where I think enabling that transition for some of the reasons Sergio was mentioning, that where it makes sense to kind of really support, to complement, I should say, in a European-wide kind of approach with local ones, it's where the economics makes the most sense, which, you know, as I showed, kind of Iberia is pretty up there.
So when this auction at the EU level, it's obviously good news, but at the same time, it's not able to be accumulated with some grants that would, in terms of investment subsidies. Do you think this is?
It's a handicap.
It's a handicap, but how much of an handicap is it?
I think it's really actually missing the entire point, because as of today, up to today, all the majority of instruments to support renewable hydrogen projects, being at national member state level or at European level, they are all targeting CapEx support. So all the tools that we have from the Recovery and Resilience Facility in Portugal, in Spain, elsewhere, the Innovation Fund, the Green Deal, these are European instruments, all of them target support on CapEx, by definition, on a portion of the CapEx. 40%, 45%, maybe 50%, depending on the tools. So these, by definition and by construction, these instruments are not meant to close the gap, because the CapEx represents maybe 1/3, 1/4 of your total cost of delivering the hydrogen, and the gap is enormous. I mean, it's not, you know, reducing 40% on your CapEx at the end may represent 0.4%, 0.5 euros per kilogram on your delivery cost. So it's very close from closing the gap, and it's assumed. I mean, it's assumed that because this is the definition, these are the rules. It's assumed. That's why in Portugal, I mean, in Portugal, we're counting on the expectation that you can accumulate that with the auction because obviously the government, Portugal has also assumed that it's not enough. In Europe, the European level, the H2 bank, at least in the first auction, the auction that is just open, in the first auction, you will not be able to accumulate with any of your existing capex, any support. So that means that the most advanced projects
are excluded.
Either they're excluded
Either
or
you waive the support.
or you forfeit the support. Exactly. Yeah. Either you're excluded to participate, and then you have to do the math and see if it's worth to actually go through this auction, because it's called an auction, but it's actually a very heavy administrative process. It's not an auction where you bid the price. You have to present a portfolio, a business case, a lot of documentation on your project. So it's more like an innovation fund where at the end, it's the price that makes, the price that you bid that defines the winners.
Let's see how the qualification criteria
It's just a qualification criteria, then the price is. So it's, I think we're missing the point. I think Europe is missing the point by not allowing the most advanced projects to participate and to actually close the gap and take FID. Apart from that, it's 800 million euros. So 800 million euros for 10 years. So 8 million euros per year. So even if you assume that the final bid will be 3, I'm saying 3 just because it's the
maximum.
No, the maximum is 4.5, but 3 is the IRA, the PTC in the US.
I thought you mentioned you cannot capture more than one-third of the
No, but let's assume that the winning bid is 3 euros per kilogram. That's the subsidy that you get. 800 million euros in 10 years at 3 euros per kilogram. It's enough to subsidize, to support 0.2, 0.3% of your target. So it's really a pilot tool in itself.
In that sense, even the auction for next year, 2.2 billion, is not even close to enough.
It's not even, yes, but I agree that the first one should be small because, I mean, it's a learning process. It's a learning process, so it's a discovery process. As we don't have any framework for price discovery of hydrogen. So there's a lot of literature on the topic, but there's no market, so there's no price discovery. So it's going to be a learning instrument also to adjust and hopefully incorporate the learnings in the next rounds of auctions.
There was there was an auction in Denmark recently that can give some clues on the pricing.
Commenting on just spontaneously on the reasoning on the accumulation of subsidies, you could also argue the other way around, actually, because you say, in fact, truly the OPEX is the main part. So if you get the H2 bank, then your main part is supported, and with that, you could say, okay, then this support could be for others, because who is winning the first auction? The first auction is set in the end pure by a price consideration. And now, obviously, and Sergio, you will be very happy because having a refinery, this is the one where you kind of have the lowest gap. And some other project may be in the high heat sector. There, by definition of the process, you cannot match this one. So in a way, as long everything is in a bucket, you have with these most advanced projects, because by nature they are most advanced because it's usage of hydrogen today, they have also a competitive advantage, which somehow would then accumulate. And so somehow you could argue the other way around and say, okay, you have anyway an inherent advantage, and now maybe on this 800 million, the next round which is announced. So first of all, this is in fact a test auction, and I met the commissioner in Brussels last week, and he said, please still apply even if you don't think you can win with the project by the gap, because we can do calculations and say, okay, almost no chance to win because there is calculation can make. But still go, because it will help the learning and also show that there are other industries which also need to develop. And so potentially there will be industrial buckets, meaning there is different applications which somehow all need to be developed. And if we wait 5 years until the first bid can be successful on another application, which is maybe more on the heat, then you will lose time to develop. So in a way, and last but not least, on the budget, member states obviously are really expected to think about the service, auction as a service. We know Brussels has a limited amount of money and it will just not be sufficient, as you said, it's just a fraction. So we will not get there if not every member state will somehow think about it. And not many, and also Portugal, Spain, have not shown quite any interest so far to do that. I think this should be also be reconsidered.
Sergio, and do you want to comment before we end?
Let me just maybe offer a different perspective here. It's not that I disagree with any of what Christian and Anna was saying on this, but to be fair, we have to realize that Europe has taken a different route than the US on supporting and incentivizing hydrogen. You know, the US has taken, typically you either support demand or supply. The US has obviously decided to go on supporting supply with the IRA. And they gone, you know, the pragmatic way. Let's see the equivalent to the Delegated Act in the US, by the way. The discussion there, it's almost a year now that they are discussing this. And so they are learning a lot with Europe, apparently. But they are targeting supply with up to $3 per kilo. Europe has gone a different way. In Europe, the decision was to support demand, mostly under the Fit for 55 package, a lot under the revision of the European Renewables Directive, and a lot of complementary legislation on that, addressing maritime and aviation and all of that. So Europe has decided to foster demand, and that might work. These auctions, the H2 auctions, or even the Innovation Fund, are complementary support mechanisms to, you know, scale up faster and all of that. I wouldn't rely on these. If we're looking at projects and thinking that we're going to develop an European sector counting on H2 auctions, I would not be too hopeful.
Yeah. Thank you. Thank you all. I think we reached the limit of our time. Thank you for your understandings in this matter. I think they were very relevant. Thank you all.
Thank you.
Avançamos agora para o segundo painel da tarde, dedicado à flexibilidade, o caminho para a estabilização do mercado elétrico. Este painel irá auscultar de que forma os vários atores do setor energético irão contribuir para um mercado elétrico flexível e estável. Começamos com uma apresentação introdutória do tema, a cargo da Energy UK. Vamos ouvir Naomi Baker, Senior Policy Officer da Energy UK.
Inviting me here to speak with you today. I'd like to start off by congratulating Iredes on delivering Portugal's first ever flexibility market trade. Oh, sorry, I should have said. I'm looking forward to seeing how the markets develop. So my name is Naomi Baker, and I work for the main energy trade association in the UK, which is called Energy UK. So that's who we are, that's who our members are. So our members deliver over 80% of the UK's power generation and 97% of domestic energy supply. So what is flexibility and what problems can it help with as we transition our electricity systems? Flexibility is about changing when and where electricity is consumed or generated. And what it can help with network congestion, helping network operators manage flows to defer or avoid capital investment. If you look at the chart on the bottom left-hand corner, those are the forecast constraint costs for the UK. As you can see, it's for the 10 years up to 2030. there's a big steep increase over the next few years as the constraints really start to bite, and then they fall away towards 2030 when some of the transmission upgrades are completed. So that's becoming a bigger political problem in the UK. As you can, the second issue that it can help with is balancing. If you look at the pie chart, about a third of the power in the UK at the moment, in GB at the moment, is from offshore wind and solar, mostly offshore wind. So because of that, balancing costs are rising. Demand-side response and storage can help manage the challenges and potentially cut costs. The third benefit that flexibility can help with is in optimizing renewable generation, storing surplus generation and altering demand to better align with supply. GB could have 50 gigawatts of wind by 2030. And along with increased solar, this could mean that generation exceeds supply for around 50% of the time. If that generation can't be time shifted with storage, or demand can't be time shifted to soak up that demand, then that surplus output is going to increase the cost of the system rather than decrease costs. So we're going to have increased costs for curtailment and constraints. Demand-side response and storage will enable more of this output to be used, and it will deliver a leaner and lower cost system. So that will cut the cost of cut the amount of additional generation and network infrastructure needed to meet the increasing future demand, and should deliver a leaner system with lower running costs. So whilst flexibility is often viewed as a way to reduce network spend, for example, smart grids, it's only part of the potential value, as you can see with the diagram on the bottom right. So the small circle in the middle is the network minimization. The larger value is the leaner system. So how's Great Britain GB doing here? So on the slide, you can see an overview of some of the markets. So flexibility is used quite a lot in some of for constraint management. If you can see sustain, secure, dynamic, and restore, they're the 4 core products that are used in the DSO flexibility markets at the moment. So flexibility is starting to play a bigger role, both in new markets or new products, such as the DSO markets, but also by making changes, evolutionary changes to existing markets. So if you look at the pie chart, this is a snapshot of some of our main energy markets in GB. GB now has around 4 gigawatts of batteries. That's up from 1 gigawatt in 2020, so there's been a really sharp increase. But those batteries are not having an equal effect on the markets. So on the graph, the lilac indicates batteries, whereas the brown indicates gas. So if you look at the line across the bottom, you can see that batteries are dominating some ancillary markets, such as frequency response, where they've had a really good outcome in terms of lowering costs. But if you look at some of the other markets, gas is still the main player. So I'm just going to run through and give a quick snapshot of some of our markets. So capacity market, as elsewhere, this helps keep the light on, with contracts for providers to respond in case of an emergency. Once again, we can see the same. Whilst batteries and demand-side response are starting to play a bigger role, gas still accounts for most of the additional capacity, both in the year 1 and year 4 year-ahead auctions. It's worth noting, though, if you look at the top right-hand corner, so the UK government is currently consulting on a range of proposals which will reduce the barriers in the capacity market for demand-side response, including domestic flexibility, batteries, and also long-duration storage. So those proposals should start to take effect from next year. So system balancing, what's the impact of demand side of flexibility, low carbon flexibility in those markets? So we can really see the same story again. If you look at the grey in the bar chart, the grey indicates gas. So once again, around 70% of contracted capacity is gas. So why? We know we've got 4 gigawatts of batteries. Why aren't they playing a larger role in balancing in GB at the moment? So the main reasons are around our control centre. So the IT systems that the control centre uses can't manage small-scale assets very well in aggregated portfolios. Also, the processes are still part manual, so they're not able to dispatch multiple providers at the same time. That could all start to change quite soon. Next month, our system operator is launching a new IT platform. So that's kind of an add-on to the existing processes that they use. And it will work to optimize the different bids and offers, and it will be able to issue multiple dispatch instructions. So it will be implemented on a phased basis, but by this time next year, we could start to see that sort of generation mix in the balancing mechanism, which is our main tool, shift. Something else, so there's lots of different sort of pilots and trials to see how we can adapt these existing markets. And industry, so I work for a trade association, my members are very supportive of the system being evolved in a gradual way rather than sort of more radical market change. So another thing relevant here is metering standards. So at the moment, the system operator requires small-scale assets such as EV, aggregated EV loads, to be down to 1% accurate. That's potentially not required. So there's a trial going on at the moment to see whether 2.5% accuracy to 2.5% would be sufficient for system balancing and the control room purposes. So that would enable a lot more aggregated electric vehicle loads to take a larger role in system balancing. So how are the GB DSO markets, the local energy markets, doing? So the picture that you can see on the slide is a high-level view of the European DSO markets. It comes from a recent report by LCP Delta and Smart EN. So GB is doing reasonably well on the DSO markets. It's had commercial markets for six years now, since 2018. And the contracted volumes have grown over this time from 160 megawatts in 2018 to 2.4 megawatts so far this year. Another positive is that the markets are much lower carbon than when they started off. The initial rules when they launched meant that there was an initial rush of diesel generation. So that's not the case anymore. If you can see from this pie chart, that shows the generation mix of the markets at the moment for this year. So only 20% of the generation mix comes from fossil fuel plants, from fossil fuel generation. About a third of the capacity comes from storage. So most of that will be from grid electricity. But you can see there's more of a mix, so it's quite a good market for different approaches and technologies. So that's good news. There are issues with market liquidity. So if you look at the graph on the bottom left-hand side, the orange charts are the requirements of the network operators. They're the volumes that they would like to procure. But if you can see from the contracted capacity in the blue, they're not managing to procure as much flexibility as they would like to. So the requirement is going up year on year, much faster than the actual contracted volumes. So what's the reason for this? The main reason is the lack of standardization across the 6 DSOs. Different products, different processes, different procurement rules. It makes the markets very difficult to operate in for flex providers. It increases their costs and their overheads and makes the markets less attractive than some of the other opportunities in GB. So this has been tackled through an industry program called Open Networks. It's been going for 6 years and it's making progress, albeit slowly. The different operators want different products, so there are some difficulties there. What's possibly been working faster is a greater use of independent market platforms. So Picloflex, for example, is now used by 4 out of the 6 DSOs and all the active DSOs. So that's starting to give the appearance of a common market, one market, rather than 6 individual markets. It's reducing the complexity for providers. Right, so that was a whistle-stop tour of our markets. I'm now going to just do some quick sort of case studies. There's links on the slide, so if you want to look into them, you can have a look on the links afterwards. So the first one is from one of our distribution network operators, or DSOs. They're called UK Power Networks, and they're based in the east of England. So they do a lot in this area, and they're very innovative. But they've got 2 products that I particularly like to flag. So the first is the demand turn-up product. So in the east of England, there's a lot of offshore wind. This is leading to network congestion. So the turn-up product helps ease potential wind curtailment and network congestion by paying flex providers to soak up some of the excess wind. They've held 1 auction so far in the summer and received 100 megawatts worth of offers for 600 megawatts worth of requirement. So there's really good competition there already. The second product that I'd like to highlight is a real-time product, which is going to be launching next year. The next case study is called the local constraint market. So it's a new trial market that's aiming to, again, address congestion, but this time on the transmission networks. So in GB, most of the wind is in Scotland, but most of the demand centres are in England. So the transmission networks between Scotland and England get very congested. So the market is a turn-up market, just like the DSO product that I mentioned. And the system operator holds auctions and pays providers to take surplus electricity off the system when there's excess. So access is open to a wide range of assets, from pumped hydro, there's quite a lot in the north of Scotland, in Scotland, to industrial and commercial users. And is also open to aggregated electric vehicle demand and aggregated domestic demand. So some of our innovative suppliers, such as Octopus Energy, are looking to do stuff in this space. So the final case study that I'd like to highlight is particularly relevant today because it's active tonight, because the system is quite tight in the UK at the moment. It's called the Demand Flexibility Service, or DFS. So this is a new product that the system operator developed in just 5 months last year. So it was developed in response to the gas crisis. There were real concerns about possible risks to the grid last winter, as in the rest of Europe. So this was what was developed just to provide an extra reserve, an extra margin. So it's a nationwide trial of a demand reduction service. It provided a way for flexibility providers, such as aggregators and suppliers, to pay their customers for turning down demand to provide system balancing. So this reduced the requirement for either sort of backups, such as coal-fired generation, to come on when system margins are tight. So the results, it was used by 1.6 million households and businesses last year and ran across 12 tests and 2 real events. The maximum volume that was contracted for any event was 350 megawatts. So about the size of a small gas plant, but so the turn down was used instead of that needing to come online to help with balancing. So in return, flex providers were paid £3,000 a megawatt hour. So that's clearly a big cost. It's about 10 times more than the average balancing costs in the UK, so it's a lot, but it's much cheaper than the cost for coal backup. So as well as developing this innovative service, our system operator contracted some extra coal plants to come out of retirement and act as a backup. So this innovative service was significantly smaller than the cost of having those coal plants sitting as backup all winter. So it was really well received and generated a huge amount of interest from both the public and industry. So because of that, it's being repeated this winter. So the new service started in November and it runs till the end of March. After it finishes, the system operator has committed to use that vehicle or something like that to try and transition domestic flexibility in particular until 2027, when the smart meter rollout will be complete, mandatory half-hour metering will have rolled out, settlement will have rolled out, and it should be able to sort of support itself commercially. So it will be supported in the transition. So as I mentioned earlier, the system is quite tight in GB at the moment. I think there's about 10% of wind that there would be at this time of year. 2 gas plants are down because it's also cold in Europe. There's not as much coming through the interconnectors as usual. So the service has been called for the 3rd time since it was developed. This time, the system operator is looking for 550 megawatts over 1.5 hours from, I think, over tea time, basically. So that will be the biggest test of the service so far. So those on the slide, there's some sort of key stats that the service has achieved, and also a graph about the costs. So there's lots of activity going on in GB in this area, lots of pilots, that sort of thing. But I also wanted to briefly mention the wider regulatory and policy context. The regulator Ofgem, is doing a lot of thinking in this space on what changes might be required to scale up flexibility. And it's making some significant interventions, both on governance. It's proposing some new rules. And it's also looking at shared digital infrastructure. So they did a proposal, consultation earlier this year, where they suggested that evolving the markets isn't going to go fast enough, and probably what will be needed is a shared sort of digital infrastructure that can really optimize flexibility, small-scale flexibility. I don't have time to talk about it now, but if you're interested, please come and talk to me later. So finally, how can Portugal build on GB's experience and scale up flexibility markets faster? So I think most important is the regulatory structure. So GB has a regulatory structure that incentivizes flex. A CapEx-based price control approach incentivizes network build-out, whereas clearly that's needed to everywhere needs network build-out yesterday. Particularly GB. But because of this, we also need to look at OPEX-based ways, alternative approaches for how we can free up headroom in the networks, both in the short term whilst we make those network improvements, and to reduce the overall amount of network build-out that we need. So we need to be doing both at the same time. So the second thing is to keep flex markets and flex products simple and standard. The way to make money from flex is to stack revenues. So it needs to be possible to move across markets and stack revenues. So the third lesson is that it's hard to do that, to make different markets and different businesses work together. So using third-party marketplaces like PicloFlex can reduce the friction for flex providers. And then 4 and 5, when looking to scale up the initial sort of pilot markets, I think a stronger focus on both overall strategic direction and governance is important. So in GB next year, we're moving from a system operator to what we're calling at the moment the future system operator. So that's going to be a public entity rather than a private entity, and it's going to have a lot more power and a lot more strategic direction for the network, both in terms of strategic network planning and in sort of planning some of the future rollout, the transition. So that's the end of my slides. Thank you for listening, and I'm looking forward to the discussion with my colleagues on the panel. Thank you.
Após esta introdução, avançamos agora para o debate. Convido Naomi Baker a permanecer no palco, acompanhada de Carlos Jordão Coelho, diretor executivo da Renewable, Diogo Leal de Faria, Executive Board Member da EDP, Rui Miguel Gonçalves, diretor de Estratégia e Regulação da E-Redes e o moderador da sessão, Pedro Carvalho.
Good afternoon. Okay, I would like to welcome my colleagues from the panel. So we have a very interesting panel on the flexibility, on flexibility and its potential use to solve congestions in the grid and solve also the imbalances. So let me start by just making a small introduction about the topic. So looking back at the last 4 years, the EU economy suffered significant disturbance, firstly because of the pandemic, the COVID pandemic, and then followed by the war in Ukraine, and more recently with the Israeli-Palestinian conflict, right? So renewables being endogenous have contributed to reduce the consequences of those disturbances. So they reduce the disturbances because they reduce our external dependence on energy supply. So this fact reinforced the drive to change from fossil to renewables, adding to the climate goals also the political objective of becoming less dependent from EU external countries. But as we all know, renewables are variable and non-dispatchable, with the exception of hydro. So when we increase the share of renewables, such as solar and PV, we also increase the share of non-dispatchable generation. So we need to compensate somehow by making demand dispatchable, or increasing the share of generation that is dispatchable, and also adding to the dispatchable loads also the demand. So grid reinforcement and stronger interconnections also contribute to that, can help a lot, okay, because they make the balancing areas electrically larger, and by doing that, they make the errors, the imbalance errors, relatively smaller. Okay, so even so, in a scenario that is compatible with the national climate objectives, we expect that flexibility needs are going to double by 2030. That's a lot, double in such a short period. This will not be possible without unlocking the potential of demand response. So demand response is much on the agenda as well. But we are not just limited to demand response. We also need to enable storage providers, energy storage providers to participate as well. Digitalization will also help. Okay, so to help us understanding how flexibility is being addressed today and their vision for how it should be addressed in the future, we have here in the panel both system operators. I have a representative of a system operator here from E-Redes in Portugal, the DSO. We also have a public policy advisor for the UK. You just have the pleasure of hearing her presentation. And 2 potential flexibility providers, right? So one from EDP with Diogo, and another from Renewable, Carlos, representing Carlos. So I will start by Carlos.
Okay.
So just asking a question. And then the first question is that renewables will create more frequent and perhaps larger imbalances, as we have seen. So because they are variable, they create imbalances, and that will be more frequent and larger. Okay, and by being larger, they create they increase the probability of congestions in the grid. Congestions need grid reinforcement to be corrected. and also to be anticipated, which is not easy in the planning stage. But they also create frequency deviations, right? So this is much more interesting for you, perhaps. Frequency deviations, right? Because and those require better balancing and ancillary services and better real-time operation. So these are very different kind of services, right? One is on the planning stage, the other one is on the operational stage. These are very different. In your opinion, and I will ask also that to the other colleagues of the panel, in your opinion, which services are the most urgently needed right now? And also, which of those services have the great potential and the greatest value for the system? Carlos.
Good afternoon. Thank you for the invitation to be present in this panel. For me, it's a pleasure. Well, as we know, the renewable generation needs to increase a lot in Portugal, and it is good. But we need some solutions to accommodate the extra capacity. In my opinion, as UK, Portugal needs a global strategy for storage systems that covers all value chain supply. Another important thing is we know that we have significant lithium reserves in our country, and thus can create an ecosystem that improve innovation solutions for battery and storage systems. The last but not least, I think we need, as soon as possible, create some service, like you said, some service like capacity and frequency markets. This is a key for the success. Okay.
Okay.
My opinion.
Thank you, Carlos. Diogo, do you want to add something?
Yes, I can compliment. And first of all, good afternoon to all. So, as mentioned, flexibility is not an expectation; is already a very clear need that we are witnessing right now. And so we have currently a system that already has a significant weight of renewables, and we already are witnessing switch in the generation needs and the capacity needs very, very quick. And so flexibility is no longer an expectation, a need that we will need to address. Is something that is very, very real and you have to tackle right now. And at the same time, we have this collective goal of the energy transition. And the energy transition, I believe we have been focusing a lot on one of the key pillars of the energy transition, which is the decarbonization. We have clear targets on that front. We have the ambition to deliver a significant capacity in the next years. But the energy transition cannot be done only by decarbonization. So we will need the other two, namely security of supply and affordability. And flexibility is the way for us to close this gap and to have these three pillars. And so it is not only relevant for us to ensure that we'll be able to comply with the targets they're committed to, and that we'll be in a position to deliver the capacity that we intend to do in a more affordable and secure way. And for that to happen, we really need to provide additional flexibility to the system, because this trend is going to accelerate. And on that front, we need markets to provide revenues to those services. And so we already have some assets that provide those services, such as hydro, and I believe we have room to further create the right incentives for those services to be provided, either from technology that already exists, either from new potential technologies that could be entered in the system. And we can do that by, for instance, remunerating services that currently are provided not remunerated. We can do it by capacity payments. We can do it by creating markets for non-frequency service, such as voltage control, inertia, a fast frequency response. And I believe this is an urgent need that we have in order to sustain the decarbonization part that we need, that we intend to do. And addressing if it should be generic or should be local, I believe this should be generic, and the local issues, we should design a system that we provide right incentives for the local issues not arise, and so that should be designed up front. And as we saw in the presentation of Naomi, we have other geographies, European geographies, that are already somehow in front of us in terms of services that are remunerated, in terms of non-frequency services that already have a market. And on those geographies, it's easier for us to have business cases for flexibility investments, either in new assets or existing assets. And so I believe it's a good reference for that.
Okay, thank you, Diogo. Naomi, what do you think is more urgent? Is the flexibility to correct for the imbalance in frequency control, or the flexibility that avoids investment?
I'd say it's not either, or I would say it's all of them, and fast, yesterday. What really struck me listening to this morning, and all the discussion was really interesting. One thing that struck me was lots of the discussions and the issues that are being faced in Europe are exactly the same as in GB. It's about anticipating investment, the difficulty of building out the infrastructure. It's about supply chain constraints, the impact of inflation on new wind. But I think the difference is that because Great Britain is an island, it's very gas dependent. 80% of our heating is gas, 30% of our generation is gas. And because of the sudden boom that we've had in the last decade for offshore wind, we're hitting lots of these problems. They might be a bit more urgent than in some of the other countries in Europe. So I think it's not about whether we should be moving. In Britain at the moment, we have to make changes. So the system operator is very ambitious. It's got some interesting targets. So the government wants to decarbonise the electricity grid by 2035. The opposition party wants to do it by 2030. But the system operator itself has a target to be able to run a zero carbon system by 2025 for short periods. So that means it really needs to look at how it can manage its ancillary services not by conventional means. So that's been driving a lot of it, sort of the ambition to do more. But I think that the way that balancing costs and constraint costs have shot up has sort of forced the issue as well. So it's not either or, it's all of them. And I think it's about thinking about flexibility and new approaches, like different forms of storage, different altering demand as maybe like a Swiss Army knife. So it's a tool that can be used to fix lots of different sort of teething issues in the transitioning system. So it's about where it can help and lower costs.
Okay, thank you. So let's hear the perspective from the utility. Rui?
Thank you, Pedro. Good afternoon. I think it's really important to underline that distinction that you made there between flexibility for the system as a whole, for frequency control, for balancing, and local flexibility to address, let's say, local grid constraints or local grid bottlenecks. So I would say that the first type of flexibility for the system as a whole is the type of flexibility that we rely on daily, hourly, and it's absolutely critical to maintain the lights on and the system working on an hour-by-hour basis. And it has traditionally been provided by large dispatchable power stations. So obviously, as we move towards a decarbonized generation system based on renewables, we will need to find other ways to procure this type of flexibility and procure it with other resources, including obviously demand, consumers, and storage systems. So in this sense, I would say that at least in the short term, this is clearly the most critical type of flexibility that we have to find. In contrast with this, when we think about local flexibility, we are talking about a new concept with the notable exception, I would say, of the UK. This is something that is not used in large volumes today to manage grids and certainly to manage distribution grids. So it's a new concept. At least initially, it will always be traded in much lower volumes and be provided in let's say, by smaller local resources. But it's let's say, the nature of the network. So networks are designed primarily to avoid local constraints and to enable a free flow of energy from generators to consumers. And I think this is the way it should be primarily, and it's a good thing to enable the market to work as much as possible and restrict. And that's why we heard today in the morning the importance of doing the investments that are necessary to make sure that this keeps happening going forward. But flexibility for us as grid operators offers us a new tool to be able to optimize these investments. So we will be able to postpone some investments, and equally important to provide a faster response to some network needs, because it's often faster to procure flexibility services than build new assets. So it's a tool that we consider very promising and very important. That's why we at APREN launched the firm flexibility project at the beginning of this year, still as a pilot project, precisely to give the first step in creating a flexibility market here in Portugal. We established a procurement platform. We identified 8 specific grid use cases. We conducted a tender last summer, which generated a lot of interest, and we are expecting to sign about 20 contracts until the end of this year to start operation next year. I should say that we got a lot of inspiration from the UK in things such as the design of the baselines, even the definition of the products. We even use some of the names that may be familiar to you, such as secure, restore, things like that. So naturally, we looked at the UK as one of the most developed markets, and we are very confident that this is a promising first step. We had, I was told, greater success in terms of volume than the first tender in the UK, so we expect that others will follow.
Very interesting, Rui. Very interesting. So we see that we need both things. We need more of the same for the balancing. So we need more, and it's not exactly the same because we are adding providers to that, new providers, demand as a provider as well. And we need something that is radically different, which is using flexibility locally, not in general, but in particular locations to solve particular problems. And by doing that, allowing to postpone some of the investments and still be able to integrate the renewables. It's very interesting. So the question now is, second question is about which technologies are mature enough to provide this service. So the second question, I will address Carlos again as the first to respond. The question is, technological advances in grid digitalization and battery storage have driven innovation in management and balancing of electricity production and consumption. Everybody agrees on that. So the question is, in your opinion, Carlos, which technologies are today sufficiently mature and to become relevant to the emergence of network flexibility service providers in the short term? And if you can talk about technologies from the generation perspective, also from the demand perspective.
Okay, thank you for the question. The technology innovation must be in two sides, like you said, in generation side and on demand side. In generation side, now it's possible have large-scale storage projects, and they will play a crucial role in electricity balancing. For information, for Green Vault in Poland, they have a pipeline around 1.4 gigawatts of these kind of projects in Poland, because Poland have this service that I said before, capacity and flexible market. And in the consumption side, this technology could and can empower the customers to participate in flexibility of grid, For instance, we have smart meters or energy management systems that provide the customers to optimize their consumptions and their grid needs. So I think the technology will help the generation side and the consumption side, demand side, to have better decisions.
So we're talking about batteries, but batteries on the utility scale, right?
Yes, batteries not in utility scale. Yes.
Okay.
Not the small batteries.
Okay. EDP is not planning to invest in batteries.
I wanted, in terms of technology, I wanted to highlight the following. So, as Naomi said before, we need everything. But I wanted to highlight that the challenge that you have is right now. And we need to plan the system for the next 5 years. And so we cannot wait for new technology and to bet only on new technology. And we have already technology that is in place that can be we can take advantage of, and we can build on this that existing technology. And by doing so, we can provide an answer much quicker and much cheaper, because you are leveraging on something that already exists and is mature. And so this relates with what I mentioned before in terms of we need to have decarbonization in an affordable way and ensuring security of supply. And being from EDP Produção, I would highlight the hydro. Okay? And as you mentioned, hydro is the only renewable technology which is dispatchable. And so it ticks all the boxes of the energy transition. It provides renewable generation, so it has the decarbonization part, but is also a way to provide flexibility for the system in a cost-effective way. And so this characteristic of being a renewable technology that allows the development and acceleration of other renewables, I believe it's a key a competitive advantage of hydro. And there is also a study from the Hydro Alliance that says that we can add 3.5 terawatt hours of renewable generation by increasing 1/3 out of hydro generation. And also we saw this year, we had 6 days of renewable generation. We have the whole country with renewable generation for 6 days, and this was because we have a significant amount of hydro and we have the water available. On top of this, hydro provides a ramp up which is very quickly, and I believe something that we will need in this weather-dependent system is to able to deal with strong fluctuations. And we have seen in the system fluctuations of 4 to 5 gigawatts in a very, very, very quick way, and hydro can address that. And also we have pumping, and pumping is the only long-duration storage, and is the most cost-effective and competitive storage. And if we leverage on infrastructure already existent, is even more competitive. And so by reinforcing that, for me, the key priority is to leverage on existing assets and adapt those assets to provide the flexibility that is needed. And for that, we'll need to have that flexibility remunerated, either the existing that is already provided, either other potential services that can be provided. In parallel, we need to develop the new technologies, and so we need the utility scale batteries, and we should gain experience on those. We will need. We will have to address inertia either with synchronous voltage control with the synchronous compensators. We can have scientific inertia and so on. So those technologies will be needed, but for the technologies to arise, we have to have a business case for that. And for us to have a business case for that, we have to have a market for that allows and provides incentive for the investment. And I believe this should be a key priority going forward. So in conclusion, we need both. But since the need is real, I believe we should also focus on the existent and adapt that and leverage on that to provide that answer.
Okay, Diogo, and we still have room we still have room to increase the hydro capacity in Portugal, right? The pump hydro.
Pump hydro, yes, and we are developing projects on that front and leveraging on the existing infrastructures. And pumping, I believe it's a flexibility provider by definition, and there is other technology that can be included in the hydro, such as hydraulic short circuit, providing variable speed,
but as of today, nothing can compete with pumped hydro.
No.
So the thing is, but we still have room to increase capacity in Portugal. Portugal is an exceptional country with respect to this, so we can increase hydro pump.
On our portfolio, we have 40% of the portfolio is reversible, so 2.5 gigas are of pumping capacity within 5 gigas that we have, and yes, there is room for more, and I believe it should be developed and incentivized.
Okay, very good. So, Naomi, in UK, we don't have too much pumped hydro, right? So you are relying on which technologies for those services?
We've got about 3 gigawatts of pumped hydro. So not in England, but a couple of plants in Wales and some in Scotland. We've got a pipeline of about twice that. What we don't have at the moment is a business model for it.
Okay.
So in terms of the question about what technologies are viable and what should we be looking at, I think we should be careful not to pick winners, because it's not necessarily about what the costs are now. We're still really in the foothills of the transition. Prices will swap around. We need to enable competition. So I think it's about. I think industry needs clarity on what the system needs are going forward and how those will develop. And then it's about regulators and the government looking, and network operators looking at how they can design really technology neutral markets. So they set out the system need and then allow technologies and approaches to come forward and companies to innovate, rather than sort of prejudging what technology is right for what system need or niche. Yeah, I guess the future system is going to be very different from the system we're operating in now. So in GB, for example, if we have 50 gigawatts of wind in the system, we're going to have, sort of potentially quite big fluctuations, particularly once heat is electrified. At the moment, 80% of heat is from gas. So looking at how we sort of manage wind droughts, say in January, that's going to be quite challenging. We could have, up to 3 weeks of low wind, and if it's a wind-dominated system, those sort of periods are going to be very challenging to deal with. So that would be very different from probably Portugal and Spain, where solar is going to play a much bigger role. So it's much more a reliable source, predictable source. So long-duration storage and low-carbon dispatchable power is going to have a much bigger role, I would think, in GB just because of our system need. So I think it's very much about sort of how that will look like, whether it's gas with CCUS or whether it's hydrogen generation or whether it's hydrogen storage. I mean, I'm sure we will need a mix of those, but what proportion we will be, I think it's about ensuring that all viable technologies have a route to market and then allowing those competitions, that competition to play out.
Very good, very good. Rui, what is your experience with respect to this? So your providers, the providers that are bidding in this pilot project of firm of yours, what kind of technologies are they using? Do you know that?
Yeah, I'll touch on that. So, but focusing on local flexibility services. So the services can be provided by 3 types of technologies, of course. So demand, generation, and storage. And I think it's worth to touch on each one of them. So starting with generation, here in Portugal, and this might not be true everywhere, at the distribution grid, typically the service that we require more, or that we need more, is lowering consumption. So this is the type of service that can easily be provided by consumers. So it's a matter of reducing consumption, obviously by storage, and by reducing charge or increasing injection, and by controllable generation. So it might be a bit more challenging for renewable generation, which tends to operate at maximum capacity possible at every given moment. So for generation, I think an interesting development can be hybridization with storage, so the inclusion of storage generation centers, and this will enable them to provide this type of service. Then, of course, the other technologies, storage, which is obviously the most flexible one, and one which I think it will be very important, not just for local flexibility, but for the system as a whole. One thing that for us, DSOs, is important, and I think that it happened the right way in England, is that a lot of the storage that was connected at the distribution level. So at that level, storage can provide services not only for the system, but also to the DSO. And so I think this is an important policy consideration to bear in mind. Then, last and certainly not least, we have demand. And as we already mentioned and you touched on, the local flexibility is by definition local, so the service has to be provided at very specific points of the network, a low voltage substation, a substation feeder. So it's very much localized, and demand is by far now the most ubiquitous resource that is connected to distribution grids, and the one where it is easier to find a match between demand and offer. So in terms of technology, what I think is critical for local flexibility now is the development, and I think Naomi touched on that, the development of an ICT infrastructure that will lower the costs of participation of consumers, of demand in flexibility markets. So control systems, actors pooling together a large number of small resources and integrating these resources in the control systems, dispatch systems of grid operators. So this, I think, is one of the key enablers for this. And you asked about FIRM. FIRM, I would say, confirmed this idea that demand is the easiest, the most available resource. Of the 21 contracts that we expect to sign. Only 3 are from small-scale generation and storage. In all other cases, we are talking about consumers willing to reduce their consumption. One development that I think will be critical is electric mobility. So electric mobility, I'd say, ticks all the boxes. So it will be everywhere, which is critical for us as DSOs, and is at an extremely flexible load with storage embedded. So that's also one of the areas that we consider very promising. And as you might know, we have some projects in the pipeline to try to harness that potential.
Very good, Rui. Thank you. So one last question, and because we are running out of time. In fact, we ran out of time already. So very quick answers, please. So the question, I will also try to integrate a question from the audience in my own question. So the question is, focusing now on political and regulatory context, what instruments should be created to incentivize promoters to invest in storage systems and collaborate with the system operators in adopting flexibility mechanisms or strategies? Should the instruments be designed in cooperation with Spain, given the context of a single electricity market? We are not talking now about local. It's not local now. It's for the wholesale market in Iberia. And the question from the audience somehow relates to this as well. So the question is, shouldn't we change as up the prices of energy and tariff for all consumers aligned with the costs? So you see this alignment of the costs with the tariffs as somehow promoting the flexibility services. Carlos, do you want to say something?
Well, we know that Portugal and Spain have strong targets for solar and wind power generation for next years. I think these projects need flexibility solutions, like we said before, and I think both countries must create as soon as possible this kind of service to promote the private investment, is my opinion. Okay.
Diogo?
I can build on that and very quickly. So regarding what you have to do in order to make storage possible, I believe the answer is we need to have a market that compensates the investment and provides a business case. And we can do that by the things that have been discussed, such as capacity payments, remunerating services that already provide, such as the FCR, is not yet remunerated, provide other revenue streams, such as the non-frequency, flexible revenue. So we need to have incentives that will allow a business case, that will allow the players to invest. And on technologies that are very emergent, we may have the need to subsidize those investments in order for us to collectively gain experience on those technologies and to start having those on the system, and then before making it a fully sustainable investment without the subsidies. And so I believe in order to make it happen, we need this. And this is already very present in other geographies, as we mentioned, so it's not a unique thing. There are other geographies that are already doing so, and I believe we should follow. In terms of collaboration with network operators, I believe the right way to do it is through the public consultations, and so I believe it's a very, very important practice in which the promoters have the opportunity to share the contributions, have opportunity to share their views in order to provide that input for then the network operators, taking consideration when defining the change that are needed. And so we are very keen on contributing to those, and I believe it's a very important instrument. In terms of principles, I believe we should follow the European principles. So should have market-based mechanisms. We should have technology-neutral mechanism, and this should apply not only for the new technology, but also for the current ones that are already operating. And so we should provide the service and technology more suited to do so. And as mentioned before, having the service remunerated. And I believe, and so addressing the question, should it be Portugal and Spain? For sure. So we have a common market with Spain. It should be market-based and with Spain.
Thank you, Diogo. Naomi, you want to say something about this? Or?
In terms of Portugal and Spain, I don't have any
Yeah,
particular insights, but just larger markets generally become more liquid. It's much better for flexibility providers if they can operate over a larger region, so that would seem to make sense and should bring down costs. On sort of tools, I'd just say markets, and it's about ensuring all viable technologies have a route to market as before, and it is about really changing existing markets. So there is a level playing field, and that batteries can, try and, or whatever technology can access if they could potentially play a role and can bring down costs.
Okay, thank you. Rui?
Okay, so regarding storage, I can say that from our experience with FIRM, what we saw was a very strong interest of storage promoters. Also, when I look at Spain, I see a large pipeline of storage promoters wanting to connect to the grids. So I don't want to take too broad conclusions from my particular experience, but my feeling is that regarding storage, the main bottleneck now is licensing and grid access rather than the need for financial incentives. So it's just my particular experience. In more general terms, regarding flexibility, I would say that the most important consideration to incentivize the emergence of these markets is that all key actors involved in making it happen should have the right incentives. In terms of not necessarily subsidies or anything like that, but in terms of market design and in terms of regulation. And the two key actors are grid operators and market agents. So flexibility, if things are done right, and you may know one thing or two about how that is done, if things are done right, creates value for the system as a whole. So the regulation and market structure should enable this value to be divided among service providers, network operators, and obviously customers. So, and if value is created, value can be shared, and if the incentives are right, I think it will happen.
I agree with you completely, but trying to bridge to the question from the audience. So, do you think that by mapping the costs, structural costs and volumetric costs of energy into the tariffs directly would contribute to that somehow? So, because we know that most of the energy costs are in fact not volumetric in the sense that they reflect the investment in the infrastructure, right? So when I pay certain amount of energy for a kilowatt hour, I'm paying, in fact, much less for the energy than for the infrastructure. So by making the tariffs more direct in the sense that they translate the real cost, would that incentivize the flexibility of service providers? Does it need to go for you? I don't know if you want, as an idea on that, that you have any thought about this?
Yes.
Yeah. Okay. Great.
It's quite a big political. It's quite a big issue within the industry in GB at the moment. So policy levies account for quite a lot of the electricity costs. So they're really stalling the take-up of, say, electric heat pumps, things like that. So whilst industry think that should be borne, that should come from the exchequer from taxes, government is unwilling. So there's a bit of a sort of stalemate about what you do, where you sit those costs. And I think that's only going to increase as sort of network, the part of the bill that pays for networks inevitably has to get bigger because we need to build out the network. So where do we put all these different costs? Yeah, it's tricky.
Thank you. Okay, let's thank Rui, Naomi, Diogo, and Carlos for this discussion. We have a coffee break now.
Fazemos agora uma última pausa para coffee break antes do último painel do dia, que terá como tema as renováveis ibéricas e tem início às 17h15. Obrigada. Regressamos para a última parte do dia de hoje e com um tema de extrema importância, as renováveis ibéricas. Chamo ao palco José Donoso, diretor-geral da UNF, União Fotovoltaica Espanhola, Juan Virgílio Marques, diretor-geral da AEE, Associação Eólica de Espanha, Ignácio Cobo, da APREN, e, para moderar, teremos Pedro Amaral Jorge, presidente da direção da APREN.
Como quieras.
Bueno, pues como se dice en inglés, last but not least, yo creo que es de los temas probablemente más importantes y como veréis vamos a ir englobando un poco todo lo que hemos ido tocando en el día de hoy, ¿no? Desde transmisión, almacenamiento, temas regulatorios, porque un poco al final la piedra angular y en torno a todo lo que gira es básicamente lo que venimos a hablar hoy, ¿no? Renovables. Y uno de los principales mensajes que yo creo que ha lanzado Pedro esta mañana, que es, cuando hablamos de renovables, no es España o Portugal, sino al final tenemos que considerar que somos un mercado integrado, un mercado ibérico. Y lo hemos ido viendo. Todo lo que pasa en uno de los mercados tiene un gran impacto en lo que le pasa en otro, ¿no? Desde la canibalización solar, que probablemente el principal driver o la razón que ha pasado ha sido todo el deployment solar de España, pero los precios se canibalizan igual en Portugal, hasta el impacto que puede haber con medidas regulatorias, ¿no? Todo el cap del gas que hemos visto últimamente, al final, o tomas una medida que esté unificada, o al final lo que pasa en un mercado va a acabar pasando al otro, ¿no? Entonces voy a presentar un poco cuáles son nuestras perspectivas y qué vemos en cuanto a desafíos, riesgos y temas que hay que considerar, y después ya daremos paso al panel con algunas preguntas muy interesantes. ¿Quiénes somos? Voy súper rápido porque creo que no es de interés aquí. Somos una empresa de análisis de mercado, básicamente, y un poco similar a lo que ha presentado Ana Varillas antes. Nos dedicamos a proyectar el futuro de los sectores energéticos, no solo electricidad, sino también commodities, cómo va a evolucionar el sector de las emisiones, cada vez más biocombustibles, hidrógeno y demás, ¿vale? Tenemos nuestra propia visión independiente de hacia dónde van los diferentes vectores energéticos y a partir de ahí asesoramos a nuestros clientes con todos sus proyectos, sus estrategias y sus desarrollos. Entonces, empezando con dónde estamos, ¿no? Estamos en un entorno en el que hace muy poco, unos muy pocos meses, se publicaron lo que ya conocéis todos, ¿no? Los borradores de los planes nacionales de energía y clima, los PNIECs o NECPs en inglés, y no os voy a descubrir nada. Son planes muy ambiciosos, planes en los que se aboga por un deployment renovable muy grande, y básicamente lo que indica es que para 2030 puede haber muchas oportunidades, pero también muchos challenges, que es un poco de lo que también venimos a hablar aquí. Por recalcar, como veis allí, pues tenemos básicamente 3 barras, el punto de partida en el que estamos a día de hoy, finales de 2022. La barra extrema a la derecha, los valores que dicen los diferentes planes climáticos, y en medio es un poco nuestra visión. ¿Por qué me gusta poner nuestra visión? Básicamente, de la manera en la que trabajamos nosotros, nuestra visión te indica lo que entraría puramente por mercado. Es decir, que sin un entorno regulatorio, sin un esquema de subsidios o sin un apoyo específico, eso es a lo que el mercado básicamente va a acabar entrando. Más que eso, provocaría una gran canibalización, unos retornos no atractivos para inversores. ¿Qué nos indica esto? Como veis, hay un gap entre lo que es nuestra visión y lo que vemos en las columnas de los PNIECs, ¿no? Básicamente ese gap es un gap que necesariamente se va a tener que cerrar con regulación, con apoyo, con un entorno que permita cierto tipo de inversiones que de otra manera inversores no harían. Entonces el challenge que tenemos por delante es bastante grande. La buena noticia, y no me quiero parar mucho aquí en las cifras porque me dan un poco igual, es existe un apetito inversor y de desarrollo bastante amplio, existe un pipeline suficiente para poder llegar a estos objetivos, es cuestión de ponernos manos a la obra. Ponernos manos a la obra de, ya lo han dicho algunos compañeros antes, acelerar todo lo que viene siendo el proceso de permitting, facilitar acceso a la red de transporte, ayudar a los desarrolladores, sobre todo a los desarrolladores pequeños, en temas de financiación, a firmar PPAs, un clearing house común. Entonces, digamos que el músculo está ahí, ahora solo es cuestión de ejercitarlo y desarrollarlo. ¿Qué es lo que va a pasar? Acabaremos viendo más situaciones como las que tenemos en el gráfico, ¿vale? Que es el famoso curtailment de mercado. El mercado spot, cuando básicamente hay más generación de la demanda que hay en un día, pues básicamente se tiene que tirar generación. El mercado acaba resultando a precios ceros. Como vemos un poco en las líneas azules, estos son 2 días específicos, 14 y 15 de mayo del 23. Y básicamente, entre el recurso renovable que había entre solar y eólico, era más que suficiente para cubrir la demanda. Es decir, que se va a acabar tirando generación renovable. Esto, ¿por qué lo digo? Es algo que ha pasado en España, concretamente, curtailment eólico, las primeras veces que hubo de manera indiscriminada fue en 2013, hace muchísimo tiempo, no es algo nuevo, y es algo que va a pasar más y más. A mayor penetración renovables, el curtailment en mercado va a ser mayor. ¿Qué quiero decir con esto? Esto no es un fallo de diseño de mercado, es un feature o unas características que van a acompañar al deployment de renovables, y es algo con lo que hay que vivir. Es algo que va a acabar pasando y es algo que los jugadores tienen que entender, los financiadores tienen que entender y los diferentes agentes de mercado, pues, jugar con ello. Sin embargo, uno de los riesgos o desafíos que podemos tener con una penetración renovable tan alta es un poco lo que estamos mostrando en el mapa, ¿vale? ¿Qué estamos mostrando? Básicamente, desde 2022, en el caso español, estamos viendo que la red de transporte es incapaz de acomodar toda la generación renovable que se quiere poner en ella, ya sea por insuficientes subestaciones, líneas, porque las obras de soporte no han llegado a tiempo, lo que sea. Estamos viendo episodios muy grandes de lo que llamamos curtailment técnico, ¿vale? Que este curtailment en realidad sí que no es esperado y sí que puede tener un impacto bastante grande, tanto en los financials de un proyecto como en commitments que pueda tener de entrega física de energía, PPAs, etcétera, ¿vale? Entonces, es uno de los grandes desafíos y riesgos que nos podemos enfrentar. Y yo creo que ya hemos hablado hoy de esto, ¿no? Por un lado, los TSOs son los primeros interesados en que esto no ocurra. Entonces, está el proceso de cómo podemos flexibilizar el proceso de planificación para hacer que todos estos problemas desaparezcan. Medidas de almacenamiento, baterías o pequeñas unidades de almacenamiento colocadas en nodos específicos en el sistema pueden ayudar a aliviar este tipo de problemas. ¿Cómo vamos a impulsar este tipo de desarrollos? ¿Qué señales vamos a enviar a los inversores, ¿no? Son oportunidades y desafíos que tenemos por delante. Y ya por último, ¿cuál es venimos aquí a hablar sobre todo del mayor desafío que vemos, ¿no? Que es, no voy a descubrir nada nuevo, el meter muchísimas renovables en cualquier sistema provoca una canibalización de precios. La famosa curva de pato, ¿vale? Precios deprimidos durante horas del día, porque hay mucha más generación que demanda y los precios acaban cayendo, ¿vale? Entonces, aquí hemos traído 3 escenarios en los que lo que vamos a pretender ilustrar es la importancia que tiene el almacenamiento en el sistema ibérico, almacenamiento adicional al existente. Hay que recordar al público que en sí Iberia ya es un sistema que tiene mucho almacenamiento de por sí. Entonces hemos estudiado 3 escenarios. Un escenario en el que directamente solo metes renovables sin acompañarlo de ningún tipo de almacenamiento. Un escenario en medio en el que básicamente acompañamos el desarrollo de renovables con cierto almacenamiento de tipo baterías, 2-4 horas, nada de largo plazo. Y un tercer escenario, un poco linkado con las charlas que teníamos antes, de un escenario en el que damos un almacenamiento de largo plazo en forma de economía del hidrógeno, ¿vale? Y los principales takeaways, a mí los que me gustan son, en la parte de la izquierda tenemos un poco cómo va a cambiar el mix de generación. De nuevo, no os voy a descubrir nada, pasará a ser la mayoría renovable, muy poco térmico, y pasará a tener una gran importancia el almacenamiento, que es toda la parte negativa. Pero si nos fijamos en la última parte, en la última gráfica, vemos cómo durante las horas de sol la demanda eléctrica básicamente está aumentando una barbaridad. Estamos dotando al sistema de una flexibilidad enorme para convertir electricidad en hidrógeno y ya en otros tipos de productos sintéticos, que nos va a ayudar enormemente a integrar las renovables en el sistema. ¿Y cómo lo hemos reflejado? Pues en la parte derecha hemos puesto unos precios del mercado spot ilustrativos y lo que vemos, ¿no? En la línea verde, que es un poco un escenario sin ningún tipo de almacenamiento, los precios colapsan durante horas de sol. Llegan a niveles en los que probablemente inversiones a merchant o inversiones con contratos de PPA sean imposibles. ¿Y qué es lo que vamos viendo en los diferentes escenarios? Línea marrón, a medida que metemos más almacenamiento, estamos controlando esa canibalización. Y no solo estamos controlando canibalización, estamos haciendo que los precios fuera de horas de sol decrezcan. Y ya por último, la línea azul, ¿no? Que es el escenario del hidrógeno. Te ayuda a contener muchísimo los precios, pero si te pasas un poco de frenada y el sistema tiene muchísima demanda de hidrógeno, esto también te puede afectar en horas fuera de horas de sol. ¿Esto qué es lo que implica y cuál es el mensaje? El almacenamiento es crítico, pero hay que entender qué aporta cada uno, a qué nivel tenemos que desarrollar, y una de las cosas que yo creo que falta a nivel de Iberia es una estrategia centralizada de almacenamiento y que vaya todo junto, porque como aquí vemos, si falla una de las patas, todo se cae. Entonces, tenemos que conseguir acompañar las tres, ¿no? Y ya para terminar de enfocar este tema, estos son lo que llamamos nuestra curva de precios capturados, básicamente los ingresos que van a acabar teniendo tecnologías solares o eólicas. Y como veis, estamos hablando de diferencias de 5 euros si metes más baterías en el sistema, 5 euros versus tu situación normal. Os podéis imaginar, los que sois financieros o desarrolladores, cómo cambia tu modelo de negocio si a tu parque solar le metes 5 euros más o 5 euros menos megavatio hora. Y lo mismo en un escenario más agresivo, como el que vemos en la derecha, de hidrógeno. Tu precio capturado va a cambiar un montón, ¿no? Entonces, ¿esto qué es lo que indica? Pues de nuevo, para promocionar este tipo de desarrollos renovables vamos a necesitar acompañar el sistema con unidades de almacenamiento y sobre todo también para paliar un poco un tema que ya hemos hablado bastante, ¿vale? El tema de curtailment de mercado. Como veis aquí, nuestra visión para 2025 no es nada positiva en España. Estamos viendo a día de hoy, si no me equivoco, hay valores del 8% de producción que ya se está cortando por mercado. Con el pipeline que vemos que va a entrar en los próximos años, básicamente estamos diciendo que se va a duplicar. Valores de en torno al 20% de la generación de tu parque que no vas a poder evacuar por mercado, lo cual es mucho, ¿vale? De nuevo, no es un fallo de diseño, o sea, es un feature que tiene la penetración y el deployment de renovables y que hay que entender y saber que eso no va a desaparecer. Pero sí que podemos mitigarlo. Y como vemos aquí, la línea superior del rango azul es qué es lo que pasaría si no hacemos nada. La línea inferior es qué pasa si le metemos baterías en el caso de la izquierda o le metemos una economía del hidrógeno, ¿no? Podemos estar decrementando todo este periodo de curtailments y favoreciendo el desarrollo de estos proyectos renovables que de otra manera algunos de ellos podrían sufrir. Y ya por último, un picture, ¿no? que es la otra pata que falta de lo que hemos comentado, de lo que hemos mencionado al principio. Existe un problema ahora mismo en España, afortunadamente no todavía en Portugal, de problemas de evacuación técnico, que la red es incapaz de acomodar toda la energía renovable. La integración de energía en estos sistemas, en estos casos, es muy determinista. Hay muchos escenarios, desde un escenario como puede ser el primero, en el que básicamente no haces nada y ves cómo el curtailment señalado en las áreas de rojo, las que más sufren, tarda unos años en paliarse hasta que la red de transporte coge un poco de carrerilla y va acomodando esas cantidades adicionales de renovables, hasta en los casos 2 o 3 en los que ya eres más proactivos, como decíamos antes, nuevos desarrollos de la red, control flexible de las líneas de transporte, DSOs, como hemos visto ahora, que actúan en mercados locales y ayudan a esta integración adicional. Hasta en el caso 3, en el que, pues mira, seamos proactivos, hagamos deployment de baterías en nodos específicos y ayudemos al sistema, de alguna manera, a acomodar estas cantidades que de otra manera no sería capaz, ¿no? ¿Qué señales le vamos a acabar enviando? Entonces son temas importantes, son temas que tienen una solución muy fácil y son temas que hay que valorar, ¿no? De nuevo, como decía, en esta estrategia probablemente unificada de almacenamiento. Y ya por terminar, conclusiones, vamos a un futuro muy incierto. Las renovables solo van a aumentar. Yo creo que todos estamos aquí para eso, por eso y gracias a eso y por muchos años. Y esto solo va a incrementar la dificultad del juego. Va a meter más volatilidad en el sistema. Al operador del sistema le va a complicar más la vida de cómo operar. Desarrollos merchant que hasta ahora han sido más o menos posibles o con PPA se van a volver más complicados. El juego se va a complicar, ¿no? Entonces es necesario sofisticar un poco la tesis de inversión, la tesis de desarrollo, de los modelos de negocio y entre todas los parties que jugamos a este juego, desde consultores, desarrolladores, reguladores, TSOs, pues un poco guiar la dirección y hacia dónde tenemos que ir. Segundo punto, que es lo que ya hemos comentado, el almacenamiento va a ser crítico. Va a ser crítico para asegurar que podemos integrar todas esas renovables en el sistema, para asegurarnos que esos objetivos del NECP, que de otra manera serían imposibles, los vamos a conseguir, para asegurarnos que los primeros ponentes que teníamos en el día de hoy, los TSOs, van a ser capaces de operar el sistema en total seguridad. Y para eso, ¿qué necesitamos? Una estrategia unificada de todo tipo de almacenamiento y de renovables. Todo tiene que ir de la mano. De nuevo, quiero recalcar el mensaje. Si una de las 3 patas falla, lo más probable es que se caiga todo y alguien va a acabar sufriendo. Entonces, la única manera de hacer que esto no ocurra es haciendo una estrategia íntegra y unificada. Y ya por el último punto, también por darle algo a los TSOs que sé que sufren, flexibilidad, que lo han dicho esta mañana, flexibilidad en el proceso de planificación. A día de hoy no la tienen. Flexibilidad de poder hacer inversiones que les ayuden a ellos a paliar problemas que van a surgir puntualmente, ¿no? Y relacionado también con el tema de almacenamiento. Iremos viendo, y lo estamos viendo ya poco a poco, los modelos de negocio y las renovables van a ir cambiando. A medida que te vas a encontrar con restricciones para evacuar en la red, te buscarás otras maneras de sacar dinero, servicios auxiliares. Ya estamos viendo agentes, tanto en España como Portugal, que con las renovables proveen algo de servicios auxiliares. Veremos nuevos servicios auxiliares apareciendo en Iberia a medida que los TSOs lo necesiten, ¿no? Y es un poco el paradigma que tenemos a día de hoy. Espero que os haya servido y creo que vamos ahora al panel con unas interesantes preguntas. Así que muito obrigado.
Então, vamos fazer um painel que é misto idiomaticamente entre português, portunhol e espanhol. E, portanto, como todos os portugueses têm a facilidade de conseguir entender, nós vamos pedir aos nossos convidados para falarem despacio, por favor. E vamos começar, basicamente, ou seja, depois da ponencia de Ignacio, não sei se há boas notícias ou não, não? Y yo les preguntaba a vosotros, y empezaba por ti, sí, hay que ir, ¿no? Es la verdad. Así, muy sucintamente, en 3 puntos, ¿cuáles os parecen ser los principales desafíos para que nosotros consigamos ibéricamente lograr el éxito de cumplir los PNIEC hasta 2030? Y os voy a pedir que tengamos 3 puntos de abordaje, porque después tengo más preguntas de detalle para ir a cada punto de las dimensiones que están en riesgo. Juan, por favor.
Muy bien, pues muchas gracias, buenas tardes y muchas gracias por permitirme hablar en castellano.
No, un placer. Nosotros aquí somos así.
Hay que agradecerlo. Muchísimas gracias.
O próximo foro de eólica te invitan a falar y tú falas portugués.
Me parece muy bien.
Ahí está. Bueno, a ver, los planes nacionales tienen que ser documentos ambiciosos, tienen que ser documentos objetivos, tienen que ser documentos claros, con unos objetivos claros y que no sean interpretables, porque si no lo hacen los gobiernos, no sé quién lo va a hacer. Entonces, vamos a ponernos los niveles de ambición lo más altos posibles. El reto quizá ahora no es en cuestionar el plan nacional o los planes nacionales, es en establecer cuáles son las medidas para llegar al cumplimiento de esos planes nacionales año tras año. Porque yo estoy convencido que si nosotros vemos los libros de historia dentro de 50 o 60 años o 100 años, dirán que la primera década del siglo o la segunda década del siglo se consiguió un avance en renovables enorme, se consiguió una descarbonización de la sociedad enorme y se consiguió un cambio radical en todos los vectores energéticos en el planeta. No quedará el fine-tuning de qué es lo que va pasando cada año, qué es lo que va ajustándose. Pero es que en ese fine-tuning es donde estamos, ¿no? Entonces, ¿qué es lo que necesitamos? Pues necesitamos avanzar en 3 vectores claros de la forma más sincronizadamente posible. El primero es la generación. Nosotros somos eólicos y nuestro objetivo es instalar parques eólicos, que los parques eólicos se construyan con una cadena de suministro europea y cumplir los objetivos del Plan Nacional. Pero también tenemos que ser conscientes de que tenemos que depender de una red, que esa red tiene que estar sincronizadamente desarrollada al mismo nivel, con la misma velocidad y en los mismos sitios que requieren los parques eólicos. Pero también tenemos que ser conscientes que tenemos una necesidad de una demanda, de una electrificación de la economía que tiene que estar a la velocidad sincronizada en los sitios adecuados y en el momento adecuado. Si esos 3 vectores no avanzan a la vez, alguno tendrá que esperar. Y si alguno tiene que esperar, tiene que plantear dónde están esos fallos de rentabilidad o cómo planteamos los objetivos a largo plazo. ¿Por qué? Porque yo creo que el principal mensaje aquí es inversiones a largo plazo. Los parques eólicos ahora mismo se certifican por 30 años. Inversiones a 30 años, un inversor que tenga sus cuentas bien hechas, que sepa que se va a enfrentar a un escenario de ciertos riesgos que son asumibles porque hemos pasado de un escenario con poca penetración renovable a un escenario con mucha penetración renovable, y evidentemente va a haber vertidos, pero hay que saber gestionarlos y hay que ir reaccionando sobre la marcha. Ese inversor no tendrá problemas en seguir invirtiendo. Inversores cortoplacistas, inversores que tengan estrategias más financieras, pues tendrán que hacer sus cuentas claramente, porque igual en ese periodo de tiempo en el que ellos tienen la propiedad de la planta, la rentabilidad de la planta no es la necesaria, ¿no? Entonces, yo creo que esos 3 vectores son los 3 caminos necesarios.
Muchas gracias. Solamente espero, antes de pasarte, que no tengamos las renovables como los hoteles. El único dueño que gana plata es el tercero, los otros 2 se quedan fallidos. José.
Sí, eso es interesante. Bom, em primeiro lugar, muito obrigado, Pedro, por o convite de venir aqui.
Prazer.
É um prazer para mim, venir sempre a meu Madeira, Lisboa. Aunque esta vez só vou a ver esta sala, pero é um prazer sempre. Bueno, tú planteas en tu pregunta cuáles son los principales desafíos para el PNIEC. Primero, el PNIEC español, en lo que respecta a la energía fotovoltaica, 79 gigavatios de objetivo al año 2030, 19 de ellos en autoconsumo. Creemos que es un objetivo ambicioso, pero realizable. Realizable si damos respuesta a todos los desafíos. Y ahí entra fundamentalmente la reglamentación, las decisiones que tome el gobierno, pero también las decisiones que tome cada una de las empresas. Y en ello, para mí, el principal desafío, y estoy de acuerdo en tu intervención, pero no en la que consideras que es el principal desafío, es y seguirá siendo la aceptación social. Somos una tecnología que viene de un momento, en particular la fotovoltaica, pero todas, en que ningunos éramos competitivos a nivel de mercado. Si hemos llegado donde hemos llegado es por ese apoyo público que pidió a los gobernantes que apostaran por unas tecnologías caras. Ahora hemos devuelto el favor a la sociedad, siendo, sobre todo en la península ibérica, la forma más barata de producir energía eléctrica. Pero no podemos perder ese apoyo. Si somos un sector regulado, dependemos de los políticos dependen de las opiniones de los electores. Si perdemos ese apoyo, todo se va a hacer mucho más difícil, y conseguir que el regulador, que el político nos dé las regulaciones que queremos para crecer va a ser mucho más difícil. Necesitamos territorio para poner nuestras plantas, y si no le tenemos, si algún nivel de la escala a nivel nacional, regional o, nunca nos olvidemos, del nivel local, se nos ponen muchas barreras, por mucho que nos hagamos planteamientos muy interesantes de ingeniería financiera o de ingeniería de cualquier tipo, no vamos a poder desarrollarnos y no vamos a poder tener nuestro objetivo. Entonces, para mí, esa aceptación social ante las campañas de desinformación que existen, es muy fácil decir, creo que hoy habéis tenido un pequeño show aquí, una muestra, aunque sea indirecta, de los problemas a los que nos enfrentamos, es fundamental para que luego a partir de ahí construir todo de la forma adecuada. Segundo desafío, las tramitaciones administrativas. El éxito de nuestras tecnologías, el gran interés, el gran apetito inversor ha colapsado a las administraciones, particularmente en nuestro país. Estas no se mueven a la velocidad que a nosotros nos gustaría y no nos dan la certidumbre que a nosotros nos gustaría. En nuestro caso particular, en España, ahora mismo es fundamental para conseguir los objetivos que hablaba antes del Plan Nacional de la Energía, el que haya una prórroga a los hitos. Tenemos una regulación de hitos que marca una fecha que es de imposible cumplimiento para la mayor parte de las plantas. Necesitamos 2 años de prórroga sin ningún tipo de nuevas barreras para poder conseguir ese objetivo. Y tercero, fundamental, el que se ha hablado anteriormente. Porque claro, nadie invierte para decorar el paisaje. Los inversores invertís para coger una retribución. Y nos encontramos con un sistema, que decías bien, no es que presente fallos, es que este sistema de mercado que tenemos marginalista es así. En el momento que tú tienes unas tecnologías cuyo coste marginal es cero, el precio que te va a marcar se aproxima a cero. Y nuestro objetivo a final de la década es tener una tecnología prácticamente, un sistema eléctrico, y lo podemos conseguir, prácticamente descarbonizado, que significa un sistema que, si se cumple en puridad el sistema marginalista, va a estar ofertando a cero. Esta es la gran paradoja de la situación. Cuanto más éxito tenemos, más daño nos hacemos. ¿Qué alternativas tenemos? Almacenamiento se convierte en una alternativa fundamental para poder gestionar. Pero no nos olvidemos, no deja de ser un parche a una situación, un parche necesario. No por el precio solo, sino también porque necesitamos, en esa electrificación total, extender nuestros beneficios a más horas posibles del sistema. Si no hay otro sistema, necesitamos las subastas. Pues, hazlo es. Las subastas se convierten en el único sistema que te da certidumbre. No nos gustan. Todo el mundo nos hemos acostumbrado muy bien, al menos en España, en los últimos años, a trabajar con contratos bilaterales, con ir a mercado. Pero cuando ese mercado, por mucho que demos garantías y apoyos a través de la reforma que se hace de la Unión Europea al sistema de contratos bilaterales, la referencia que va a tener el off-taker es ese precio de mercado. El off-taker hoy en día, con una previsión que nos están diciendo los expertos de que ese precio baja, nadie te va a querer firmar contratos o no está incentivado a firmar contratos a largo plazo a un precio razonable para ti, que es lo que te va a pedir el banco para financiar.
Yo no estoy de acuerdo con eso, que los precios van a bajar, pero es solamente la idea.
Los precios a lo mejor no bajan.
No bajan.
Pero la teoría, o sea, si pasa, lo que termino de decir. Pero si no pasa, los precios por lógica van a bajar, porque tienes un coste marginal. Si tú tienes una subasta, si el que busque certidumbre, tiene que ir a la subasta. Pero unas subastas que, si quieren buscar certidumbre y el regulador, perdón, el político quiere certidumbre en sus objetivos, tienen que ser unas subastas, primero, que estén correlacionadas con el volumen que quiere alcanzar, en nuestro caso con esos 79 gigavatios. No quiere decir que todos sean subasta, pero sí unas cantidades importantes, que sean estables, que den certidumbre al mercado de que se van a convocar en unos periodos determinados del tiempo por unas cantidades determinadas, y eso se va a cumplir. Y además, que te den una señal a largo plazo, que que sea por lo menos para 15, 20 años lo que te van a dar. Después, para que ese precio, como tú dices, no baje, no se derrumbe, ¿qué necesitamos? Demanda. La demanda ha caído. Si algo está fracasando hasta ahora, el proceso de transición ecológica en nuestra península ibérica es en la electrificación. La electrificación no entendida como incrementar la demanda, sino como sustitución de combustibles fósiles por energía eléctrica. Eso no se está produciendo. Se está produciendo en unos datos muy limitados hasta ahora. No suficientes para compensar este incremento de la oferta que estamos dando de forma tan importante y que más se va a dar en los próximos años con todo lo que queremos y todos vosotros os gustaría introducir en el mercado. Entonces, hay que avanzar en esa electrificación. Pero luego tenemos una gran esperanza. Ese incremento de la demanda como resultado de la ventaja competitiva que nuestra tecnología va a dar a la península ibérica. ¿Qué quiero decir? Bueno, la energía solar fotovoltaica produce en la península ibérica en el entorno de 1950-2000 horas por planta. En Alemania, 950 horas. En Centro Europa, 950 horas aproximadamente. Y menos. En todas aquellas industrias cuyo input, la electricidad, sea un input importante en el coste final, van a estar incentivadas, como ya está pasando en algunos casos, a venir a la península ibérica, a instalarse aquí. Pero esto tiene que estar acompañado por los gobiernos con unos fast tracks de tramitaciones administrativas, con unos apoyos. Es nuestro dumping para la industria, que es un dumping real, natural. Por primera vez, la península ibérica tiene ventaja competitiva en una revolución industrial. No hemos tenido buen carbón, no hemos tenido uranio, petróleo y gas ni para un mechero, pero ahora sí tenemos nuestro sol. Y eso nos da ventaja competitiva. Hay que saber aprovecharlo. Y eso puede hacer incrementar esa demanda también. Tenemos ya cantidades importantes de industrias, luego veremos a ver lo que se concreta. Pero que
Tienes un minuto más.
Uy, pues me queda todavía...
No, porque tienes más 3 preguntas.
Pero esto es tiempo de descuento, lo que me interrumpes.
No.
Bueno, nos queda eso, nos queda esa posibilidad de aprovechar ese factor. Tenemos centro de datos, industrias y hidrógeno. El hidrógeno es otro factor importante que puede cambiar la situación. El hidrógeno es muy intensivo en consumo de energía eléctrica y eso puede incrementar esa demanda. Tenemos que incrementar esa demanda. Almacenamiento, incremento de la demanda por todo eso y, si no, la certidumbre que nos queda es esa otra. Que también nos afecta de la parte del autoconsumo, porque al final el autoconsumidor funciona como un off-taker. Si el precio de mercado no es suficientemente alto, no va a invertir en autoconsumo. Necesitamos encontrar vías. Si el gobierno quiere conseguir, los gobiernos quieren conseguir ese desarrollo del autoconsumo, que además nos sirve como justificación que estamos haciendo todo lo posible por el autoconsumo de cara a esas plataformas de oposición que nos lo están demandando, pues habrá que ir. Las subvenciones no funcionan. Estamos viendo en España, tienen un gran efecto incentivador, pero tienen un problema de gestión. Mejor por la vía de las desgravaciones fiscales. En Alemania, en Reino Unido, el IVA es 0 para el autoconsumo. Aquí, como mínimo, se tendría que conseguir por esa línea. Bueno, no me voy a extender más. Solo un apunte del tercer desafío, cambiar la mentalidad de REN y de las redes eléctricas. Hay que pasar de una planificación estática a un concepto de planificación dinámica. No estamos en la época en que se hacían 5 centrales nucleares o 5 plantas de cualquiera que se hacían fijas en unas partes del territorio y se podía planificar de forma fácil. Ahora no. Nos enfrentamos, la red se enfrenta a un desafío de decenas de instalaciones que a lo mejor se hacen o no, y el desafío de aprovechar esas oportunidades de incremento de la demanda. Entonces no se puede esperar 5 años, no se puede decirle a un gran proyecto que puede cambiar la situación o que puede ayudar a cambiar la situación, que tiene que esperar 5 años. Esto tiene que verse.
Te voy a cortar la contestación, perdona. Porque...
Tienes que aprender una cosa, Pedro. El que me invita a mí a hablar en un foro sabe que yo hablo.
Sí, pero tengo que dividir el tiempo. Sabes que esto es una democracia ainda. Y entonces tenemos que dividir el tiempo por toda la gente igual.
Yo no tengo
pero
problema.
Vale. No. Te voy a dar la oportunidad de decir que Iberia también tiene condiciones fenomenales para eólica, antes de pasar a Ignacio.
Ah, muy bien, me das a mí otra.
Claro.
Ah, muy bien, muchas gracias. No, por supuesto, vamos a ver, la eólica es la primera tecnología del mix en España y la que más genera a día de hoy, ¿no? Y es un lujo tener que una tecnología renovable liderando un mix eléctrico en un país en Europa a día de hoy. Entonces, bueno, yo creo que eso es una de las cuestiones que tenemos que mantener, columna vertebral del sistema eléctrico y la tecnología que está llamada a ser la primera fuente de generación en los PENIEC, ¿no? Es una referencia que a nosotros nos preocupa desde el punto de vista de cadena de suministro, como sabéis. Es decir, al final para nosotros hablar de energías baratas, competitivas, sin tener una cadena de valor detrás, se nos queda un poco cojo, ¿no? Entonces la eólica es lo que es gracias a que tiene detrás una industria y que genera las externalidades positivas que genera la industria eólica, los empleos, el desarrollo e innovación. Y eso es lo que tenemos que seguir manteniendo en España, pero también en la península ibérica, porque para nosotros es, desde el punto de vista de cadena de suministro, como podéis entender, las empresas no entienden de países, entienden de distancias logísticas y de mercados, ¿no? Entonces, para nosotros es una única cosa. Y dejo a Ignacio ya.
Vale, Ignacio, 3 puntos fundamentales de desafíos, pero cortos, ¿ah?
Cortos, no te preocupes. Lo primero es, has empezado con irónico de malas noticias. No son malas noticias. Honestamente, estamos a tiempo. Es 29 de noviembre de 2023. Hasta 2030 tenemos todavía 6 años. Es verdad que quizás soy el más joven de esta mesa y tengo menos experiencia, pero a mí lo que me pide el cuerpo es en 6 años da mucho tiempo a cambiar cosas. Si miras 2017 y lo comparas como estamos ahora, no tiene absolutamente nada que ver. Y mucho de este cambio que ha surgido en España, en Portugal, ni siquiera está impulsado de manera regulatoria. O sea, ha sido resultado de mercado, resultado de asociaciones que habéis impulsado el cambio, resultado de los inversores que estáis al otro lado. Y entonces en 6 años puede cambiar todo muchísimo. Lo que pasa es, tenemos que ponernos todos a trabajar y a trabajar en la misma dirección. Yo creo que Juan lo ha dicho muy bien. A lo mejor fallan unas patas, entonces alguien tendrá que esperar. Pues vamos a hacer que nadie tenga que esperar, ¿no? Entonces yo creo que estamos a tiempo de impulsar todo esto. Desde nuestro punto de vista de consultores, que es, y retomando un poco lo que ha dicho José, ¿cuáles son los principales fallos o las dificultades que vemos para llegar al PENIEC? Tanto desde el punto de vista de permitting, que yo creo que ya hemos tratado aquí largo y tendido, ahí tenemos un bottleneck muy grande, como desde el punto de vista técnico. Yo creo que se ha hablado poco. Hay falta de suministros. Si tú vas ahora a pedir un quoting para transformadores, vete tú a saber cuándo te traen un transformador para tu subestación. Inversores pasa lo mismo, hay pecistas, hay falta de pecistas y creo que también en la parte de regulación hemos hablado de esto, ¿no? Faltan profesionales para que todos estos tipos de bottlenecks que tenemos a día de hoy se acaben solucionando. Y ya el último punto, para cerrar el gap, financiación, o sea, es necesario. Y lo linko un poco con probablemente lo que ha dicho José de subastas. La financiación, o tienes unos ingresos garantizados, como puede ser un PPA, con las dificultades que sabemos que hay a día de hoy, de encontrar un off-taker, si la contraparte tiene un riesgo crediticio correcto o no para el banco, o vas con un CFD. Y yo aquí difiero un poco de lo que dice José. Las subastas gustan si están bien diseñadas. Y creo que aquí me voy a tirar una cuña publicitaria ahí free. Las subastas que diseñamos en Portugal 2019, 20 y 21, yo creo que tuvieron un gran apetito.
Barting aquí es más caro, ¿eh?
Entonces, de nuevo, no son malas noticias, pero sí que hay que ponernos todos manos a la obra.
Bien, gracias por la primera pregunta.
Una precisión.
Por favor.
Yo he dicho que al sector no le gustaría tener que recurrir a subastas, pero ante un sistema de mercado que no es el adecuado para una tecnología que no tiene costes marginales, la subasta es la solución para poder dar esa certidumbre que te pide el banco para financiar. Por no extenderme ahora más.
Sí, y ahora estamos acordando y mañana tenemos un panel con eso que va a salir del diseño de mercado europeo en términos de CFDs, PPAs y spot market y entender cómo esto se va a estructurar en términos de estructuración de precios y de demanda. Pero
por supuesto que tienen que estar bien diseñadas. O sea, ya hemos hecho nuestra propuesta. Si no, no funciona.
Bien, entonces una preocupación que tenemos aquí y creo que vosotros también con vuestros asociados es que, como sabemos, los planos nacionales de energía y clima son lo que llamamos policy driven. ¿Y vos parece que los inversores y financiadores continuarán a invertir de forma, vamos a llamar, más o menos continua y a instalar centrales renovables si el consumo no nos proporciona señales de que se puede aumentar de forma sostenible, porque cuando lo miramos hace 10, 15 años que llegamos a la conclusión que la demanda va a subir y al final, porque tenemos más eficiencia energética, porque tenemos más electrificación más eficiente, no conseguimos desplegar el consumo. Y yo voy a preguntar a cada uno de vosotros en 3 minutos qué os parece. Si tendrías que invertir hoy en activos que van a funcionar 15 a 30 años y el precio no te da y el consumo un señal de que se va a subir, ¿qué te parece que va a hacer, Juan?
Bueno, el consumo, la demanda eléctrica es un macroindicador. Nosotros lo que creemos es que hay que ir ya... Se ha acabado la época en la que uno tomaba decisiones en base a una Excel con unos precios orientativos de mercado, con una evolución de la demanda y con una capacidad de producción de la instalación. Y daba una TIR y eso iba uno al banco y el banco se lo creía. Ahora se ha acabado.
Ese tiempo está muerto, ¿no?
Eso se ha acabado. Ahora lo que tenemos es que ir al proyecto concreto, al nudo concreto, saber qué curtailment va a tener, saber qué precio vas a ver, saber qué proyectos están junto con el tuyo, qué proyectos van a ir detrás del tuyo y cómo va a evolucionar el centro de los centros de consumo alrededor del tuyo para ver si realmente esa instalación va a tener una rentabilidad. Yo os voy a contar una anécdota. Hace aproximadamente 15 días estuve en una cena y estuve sentado en una de las mesas y tenía 2 representantes de 2 bancos, uno a cada lado. Y entonces cuando empezamos a hablar de esto yo les preguntaba si en los proyectos, en las due diligence que tienen que analizar para tomar las decisiones, si piden análisis del nudo en el que se conecta el proyecto y me decían que no, que eso es muy caro y que eso lleva mucho tiempo. Nosotros en la asociación hemos desarrollado este año un estudio y os voy a decir por qué os lo cuento, no por que nos ha costado 8 meses desarrollar aproximadamente, donde nos hemos modelado una serie de nudos muy ejemplarizantes en España y hemos puesto encima de esos nudos los proyectos reales que están ahora mismo en tramitación. Sobre esos proyectos reales hemos aplicado unos porcentajes de éxito que van desde un 20 a un 80% de cada una de las tecnologías, proyectos reales que están en tramitación con la autorización ambiental aprobada y en algunos casos con la autorización de construcción aprobada. Y hemos modelado qué es lo que pasa en esos nudos real, es decir, con la planificación de red implantada, con el consumo que hay planteado en diferentes escenarios. Y nos enfrentamos a curtailments en algunos casos y dependiendo de la tecnología de más del 50% de forma estructural. Significa que eso no lo soluciona un almacenamiento a 2-3 horas, porque claro, cuando ese almacenamiento a 2-3 horas tiene que empezar a verter, tiene otra tecnología que es más competitiva que esa tecnología con almacenamiento que está ocupando ese hueco. Y tampoco lo soluciona al día siguiente, porque vuelve a tener la tecnología la misma capacidad de generación. Bueno, ese es el escenario al que tenemos que ir. Y tenemos que ir a sofisticar esos análisis para que los inversores evidentemente tengan la visión real de lo que tienen. Los PPAs ya no significan nada, es decir, no quiero tampoco un PPA firmado como un concepto de pay as produced. Si no tienes un análisis del nudo no te garantiza nada. Tú no sabes si vas a invertir 2.000 horas al año o 850, o en el caso eólico 3.200 o 2.100, porque la congestión del nudo te va a decir exactamente la cantidad de energía que vas a poder vender. Y eso es un círculo que tenemos que conseguir que no sea vicioso, que sea virtuoso, es decir, que empecemos a trabajar ya con este esquema para poder saber que estos proyectos que se tienen que financiar, porque insisto, se tienen que financiar, si no, no avanzamos, y tenemos que avanzar, se tienen que financiar sabiendo todo este tipo de análisis que hay que realizar. Esa es la visión que tenemos. Ahora, en el largo plazo hay que seguir desarrollando eólica y fotovoltaica, y es que no podemos parar. Entonces, independientemente de que el mecanismo de toma de decisión financiera sea más sofisticado, evidentemente hay soluciones, ¿no? Por supuesto que sí.
Gracias. José, en términos de fotovoltaico, la cosa también es exigente porque tenemos, creo que son 30 gigas para instalar nuevos, ¿no? Ya tenemos señales de vertidos, curtailment en el mercado spot. ¿Cómo afecta esto las intenciones o la visión de los inversores y financiadores de proyectos?
Vamos a ver. Creo que en parte he respondido antes, pero primero, el inversor que viene a este sector tiene que saber que este es un sector, como cualquier otro, en que la inversión tiene un riesgo. O sea, no hay... Para empezar, tienes un riesgo regulatorio. Y eso, por más que el gobierno de turno y tal te diga que no, que tal y que cual, yo llevo en esto desde el 89. No he conocido un secretario de Estado en España o en Portugal que no haya cambiado la regulación. El que no la ha cambiado es porque no le ha dado tiempo y la han cesado antes de que la cambiara. Entonces, tenemos siempre un riesgo regulatorio. Y después tenemos el riesgo en este momento, que es un riesgo real, el desacople entre el modelo de mercado que tenemos con las características de nuestra tecnología. Y también tenemos un riesgo que que se nos dé el efecto inmobiliario. Es decir, que el inversor considere que este es un mercado de crecimiento infinito, cuando tiene un mercado finito, que es el límite que te marca la demanda. Porque no vamos a producir más energía que la de la demanda. Entonces, por eso la importancia que tiene en buscar esas soluciones para extender las horas de producción y para entender esa demanda natural. Si no, nuestro mercado tiene un límite y eso hay que entenderlo. Ahora, dentro de eso, yo creo que el inversor en general tiene ganas de seguir invirtiendo, es optimista. Yo soy optimista porque creo que al final vamos a ir ajustando. Si no hay cambios regulatorios o cambios políticos que nos alteren la estabilidad, vamos a poder ir ajustando el sistema un poco y el sistema se va un poco a autogestionar. El inversor a un punto determinado, si ve que la señal de precio no es la adecuada, o se refugia en las subastas o va a ir desapareciendo. Y eso es un poco la situación. Por eso, y repito, para mí es clave almacenamiento para extender y hacer todo lo posible para dar confianza a esos inversores que vienen buscando una energía barata para poder hacer crecer esa demanda. Si no, tenemos un tope claro.
Yo voy a volver a vosotros, pero Ignacio, ¿y vosotros lidáis con inversores y financiadores todos los días? Cuando ellos miran el comportamiento del mercado spot en los últimos 2 años, con horas de curtailment ya significativas y mucho más longas do que está en los modelos financieros, ¿qué vos dicen la percepción de riesgo y las ganas de invertir o siguiendo invirtiendo?
Obviamente el riesgo está. Y la primera pregunta es ¿qué está pasando? Y estos 2 últimos años hemos tenido muchísimo movimiento de educar otra vez a la gente en temas que hasta ahora no nos habíamos enfrentado. Vamos pasando. Primero eran PPAs. ¿Qué es un PPA? Tienes que ayudarle al banco a entender qué es un PPA para que lo entienda, para que su comité de riesgos te lo acepte. Ahora surgen nuevos temas, curtailments. Entonces entras en una nueva fase. Al final, yo creo que José lo ha dicho muy bien. O sea, la gente que invierte en renovables sabe que hay riesgo. Entonces esto es cuestión de entender el riesgo que tienes, medirlo, intentar mitigarlo de alguna manera y vivir con ello, porque va a ser una parte del juego, ¿no? Entonces, vemos que los bancos financiadores están en ese camino, ¿no? En entender lo que está pasando. Yo creo que Juan lo ha dicho perfectamente. Algunos de ellos ni siquiera lo tienen en cuenta porque dicen, oye, una complicación más, ya me enfrentaré a esto. Pero sí que cada vez se va pidiendo más y más en procesos de due diligence, en procesos de M&A, incluso para nuevos desarrollos, ¿no? Entonces, yo creo que estamos todos aprendiendo y lo que sí que vemos del sector es que en general se está complicando todo. Estamos todos aprendiendo a medida que pasan las cosas. Y aunque los mercados sean mercados con un solo precio en España y un solo precio en Portugal, yo creo que nunca van a ser ya mercados zonales. Vamos a ir a mercados incluso nodales. Juan lo ha dicho perfectamente, de saber en el nodo específico en el que te vas a conectar tienes que entender cuáles son las dinámicas, cuál es el pipeline de proyectos que se pueden conectar ahí, qué planea Red Eléctrica o REN para reforzar la red, ¿no? Entonces es lo que estamos viendo, este proceso de aprendizaje que llevará su tiempo, pero yo creo que lo hemos dicho todos bastante bien en el panel, apetito inversor hay, seguirá habiendo, lo que pasa es que las reglas del juego van a ir cambiando y se trata de irnos adaptando a los cambios.
Gracias. Entonces, pasaría solamente para que vosotros, en las asociaciones que tenéis con distintas tecnologías, vuestros asociados siguen invirtiendo y mirando la inversión como algo que hay que incrementar la velocidad, o lo ven se abrandar un poco la velocidad hasta que se arregle el diseño de mercado, hasta que estas condiciones macroeconómicas se queden más favorables. ¿Cómo es vuestra opinión en eso?
Bueno, a ver, en nuestro caso, no sé si tenemos suerte o desgracia, pero la realidad que tenemos en el caso eólico en España es que la velocidad que llevamos es más lenta de lo que deberíamos llevar para cumplir el FENIEC. Entonces, claro, nosotros estamos viviendo ahora un nivel de instalación de parques eólicos equivalente a lo que se aprobó a nivel ambiental hace 2 años. Y hay que tener en consideración que desde el punto de vista eólico en España, hasta el último trimestre de 2021, y hay que tener en consideración que veníamos de un COVID, de una recuperación posterior, una crisis global que afectó a los países donde administraciones públicas estaban evidentemente enfocadas y priorizando la urgencia que teníamos en ese momento, ¿no? Pero hasta el último trimestre de 2021 nosotros no empezamos a tener una tramitación más o menos constante del orden de 1 gigavatio al trimestre. Antes teníamos tramitaciones de 200 megavatios, 150 megavatios al trimestre. Eso fue así durante todo 2022 hasta el último trimestre de 2022, que pasamos a tener 4 gigavatios tramitándose con autorizaciones ambientales aprobadas, y el primer mes de 2023, qué casualidad, porque como decía antes José, ahí cumplía un hito importante, tuvimos 7 gigavatios. Claro, lo que podemos empezar a ver desde ahora en adelante es cómo se va trasladando esa gran cantidad de proyectos en tramitación al desarrollo real, ¿no? Pero también tenemos que tener en consideración que todo esto no tiene que asfixiar las cadenas de suministro. Las cadenas de suministro que nosotros tenemos y las que queremos mantener, y como esta mañana también Giles Dixon ha comentado perfectamente, el Wind Power Package viene justamente a equilibrar esta situación. Queremos que los aerogeneradores se fabriquen en Europa o en Estados Unidos, en el ámbito occidental. Queremos seguir viendo cómo se generan empleos industriales. Y para eso necesitamos que estas cadenas de suministro tengan cierta confortabilidad para poder desarrollar todo esto en un tiempo razonable, sin generar por una avalancha o por una aceleración que quizás no es del todo lo buena que tiene que ser desde el punto de vista de una cadena total, de una cadena de valor, y dilatar un poquitito más este tipo de planteamiento. Nosotros también estamos de acuerdo con una dilatación mayor de los hitos y con conseguir que estos proyectos se hagan con más tiempo. Ahora hay que tener en consideración que el que va a encargar un trafo tiene un deadline de 2 años y medio aproximadamente. Es decir, ahora mismo quien no haya encargado el trafo ya sabe que en el año 2025 no llega, ¿no? Pero es que eso no es positivo. Tenemos que conseguir que el trafo se haga en nuestro territorio y que el trafo se haga con las condiciones y las calidades que nosotros queremos, ¿no? Entonces, esta visión de cadena de valor condiciona también los ritmos y las velocidades. Lo que puede parecer que no es bueno, porque no estamos cumpliendo unas metas y un plan nacional, es lo que la cadena de valor asume como sostenible para seguir siendo como tal una cadena de valor, ¿no? Si aceleramos más o paramos más, lo que hacemos es que la cadena de valor sufre, ¿no? Por tanto, hay que llegar a ese equilibrio. Ojalá podamos llegar a un equilibrio, llegar a meter o introducir 4,5 gigavatios, que es lo que tenemos que introducir a día de hoy para cumplir el nuevo PENIEC, que está ahora mismo en desarrollo, que nos asigna 62 gigavatios de eólica 2030 en España. Ojalá podamos hacerlo, pero si no, lo que queremos es que en donde nos quedemos tengamos una cadena de valor saneada, saludable, sostenida y que todo el mundo gane dinero y tenga rentabilidad en el proyecto.
Gracias, Juan. José.
Bueno, en España no tenemos, con la regulación que tenemos, si no hay prórroga, no hay mucho wait and see. O sea, hay que construir antes de junio 25 o abandonas el proyecto. Es cara o cruz. Si hay prórroga, pues lo que estamos pidiendo son 2 años, tendrías 3 años para poder dimensionar, o sea, para poder decidir. También es otro de los argumentos, es para poder tener un poco de wait and see esta prórroga, para ver un poco cómo evoluciona el mercado, cómo evoluciona toda la situación que hemos dicho antes, para que se tomen las decisiones. También, por decir, el tema de los nudos, nosotros estamos pidiendo transparencia, al menos de los vertidos técnicos. Es importante que los inversores en este momento tengan transparencia de cuál es el porcentaje de sus ingresos que se va a ver afectado por esos vertidos técnicos y en qué plazo Red Eléctrica piensa resolver el problema, para que lo pueda integrar. Consideramos que es fundamental. Una de nuestras ventajas competitivas, yo siempre cuando llegué aquí, yo vengo del sector eólico, y cuando llegué aquí al fotovoltaico me di cuenta que tiene tremendas ventajas competitivas. Siempre se piensa en el precio. La gran ventaja competitiva, en algunos momentos ha sido su maldición, es la rapidez, la certidumbre en la inversión. Uno hace bien su trabajo, tiene una certidumbre casi total que el proyecto va a salir adelante. Mientras que en el eólico no quiero contar todo lo que he sufrido en mis 10 años de eólica. Y el riesgo que tiene el inversor. Aquí los periodos, repito, si se hace bien el trabajo, los periodos de maduración de un proyecto son cortos, hay una gran certidumbre del resultado en que vas a tener éxito, no hay riesgo de recurso, riesgo de emplazamiento, pues es porque te has complicado tú la vida, si lo tienes. Entonces, ¿esto qué hace? Que podemos crecer muy rápidamente, a veces demasiado. Tenemos 43 gigavatios aprobados con declaración de impacto ambiental positivo el pasado mes de enero en España. construir todo eso en un año y medio es una locura y tampoco tiene sentido de cara a la cadena de valor. O sea, pero sobre todo nos puede alterar mucho el mercado. Es verdad que de esos 43 gigavatios no sabemos cuántos son reales, cuántos son realmente que se pueden ejecutar, porque hay problemas con algunas administraciones locales, pero sobre todo muchos de ellos tienen unos condicionantes ambientales que afectan en un entorno que no se ha hablado y me ha extrañado que hasta ahora no ha salido. Somos un sector intensivo de capital, el precio del dinero está subiendo.
Mucho.
Mucho. Tenemos el sol gratis, pero el dinero no es gratis. Esa mezcla de precio de coste del dinero con unos requerimientos que en muchos casos la moda en alguna comunidad autónoma ha sido pedir enterrar líneas, puede hacer que muchos de esos proyectos no salgan. Entonces, tenemos una gran incertidumbre sobre cuál será ese número. Y eso puede afectar fundamentalmente a ese mercado. Pero no lo sabremos hasta el final de la película, cuántos se van a conectar más o menos, porque también sabemos que la experiencia es que nadie abandona su proyecto hasta el último momento. Claro. Eso es algo inherente a nuestro
Porque tiene valor capturado, ¿no?
Y a lo mejor ya no tiene ninguno, pero dice a lo mejor...
No, pero asumir que no tiene es siempre muy difícil, ¿no?
Es muy difícil, es muy difícil. Entonces, tenemos ahí esa gran incertidumbre y de ese potencial que hace imprescindible esa prórroga. Y ha salido el tema de la cadena de valor varias veces aquí. Quería decir algo a este respecto. Primero, contra España, eso generalmente la gente no sabe, somos un país exportador. O sea, el año pasado exportamos al sector fotovoltaico por más de 4.000 millones de euros. Porque nuestro sector tiene una peculiaridad. El panel fotovoltaico es apenas el 35% del LCOE de la planta. En cambio, en España lo que tenemos son buenas empresas muy competitivas y líderes mundiales de inverters, de trackers, de estructuras, etc. Entonces, económicamente, dejamos mucho tejido, tenemos casi 200.000 empleos, directos e indirectos, en España, y somos un sector francamente exportador. Pero tenemos un talón de Aquiles, el tema de los paneles. No es un problema económico. ¿Qué nos importa si seguimos el liberalismo y la teoría de Ricardo? Si en China nos producen baratos, pues los compramos baratos. Pero esto es lo que vivíamos muy confortablemente antes del COVID, antes de la guerra de Ucrania. Ahora las distopías existen. Y como existen las distopías, podemos tener una distopía que afecte al comercio entre China y Europa. Entonces, ahora se convierte en un factor geoestratégico tener esa capacidad de producción local. Ahora bien, eso tarda y puede tardar si no se dan las señales adecuadas. Pero esas señales tienen que ser a medio y largo plazo. Cualquier entorpecimiento, cualquier barrera que se ponga ahora mismo a ese comercio va a ser darnos un tiro en el pie. Va a ser simplemente hacernos que se transmita al consumidor final un precio mayor de la energía o se afecte a este proceso de transición ecológica.
Pues gracias. Vamos a otro tema. Gracias por vuestros puntos de vista y que tiene que ver con precios y con almacenamiento y volver un poco a uno de los puntos que Ignacio ha presentado en su ponencia. Y más o menos lo que quería preguntar es lo siguiente. Y Ignacio, puedo empezar por ti y después cogemos la opinión de José y de Juana. Los PNIEC en Iberia tienden a ser agresivos en términos de desarrollo del almacenamiento y mejora de la demanda flexible, como por ejemplo puede ser el hidrógeno. ¿Cuál os parece el riesgo de no cumplir esos objetivos y cómo esto podría afectar eventualmente el despliegue de energías renovables nuevamente, o sea, centros de autoproductores, fotovoltaicos, eólicos? ¿Existe el riesgo de ambos, es decir, fuentes de energía renovables y almacenamiento, se desarrollen por separado y, por tanto, el fracaso de uno de los dos que no está vinculado al otro? ¿Y cuáles os parecen las medidas específicas que tendríamos que implementar para conseguir más almacenamiento en el sistema y asegurar la integración de renovables con precios razonables que sean económicamente viables? Y os voy a pedir, para que estamos entre nosotros, la cena de toda esta gente, 3 minutos a cada uno, por favor. Empezamos por ti, Ignacio.
Claramente la hora de la cena en Portugal no es igual que en España. Sí que lo hemos visto bastante claro, ¿no? Si no hay almacenamiento, y voy a meter en el saco de almacenamiento tanto corto plazo, baterías o soluciones térmicas, almacenamiento de largo plazo e hidrógeno, los precios no se sostienen. ¿Qué es lo que pasaría en ese entorno? Toda la oleada de proyectos que estamos viendo que se están desarrollando ahora, que están en pipeline, los que han entrado en operación los años anteriores, que tienen contratos, son los que acabarían sufriendo, porque vamos a ver una canibalización de precios si no hay almacenamiento, la demanda que bien ha comentado José, que también va un poco de la mano, y acabarían sufriendo, y viviríamos, yo creo que otro clásico parón de inversión en Iberia, ¿no? Como ya hemos visto alguno, de moratorias, unos años en los que no haya ningún proyecto hasta que todo se vuelva a recuperar y se desarrolle las patas necesarias. ¿Qué es lo que estamos viendo positivo? Yo creo que el almacenamiento empieza a estar en todas las agendas. Ahora en España, pues mira, en marzo se abrieron una ronda de ayudas con el dinero de la Unión Europea para proyectos de hibridación. Ahora, en 31 de octubre, se han cerrado una serie de ayudas para bombeo, almacenamiento térmico y almacenamiento electroquímico. Y se están dando poco a poco esa serie de incentivos, y esa no es una guía clara, pero poco a poco al menos ir direccionando a los inversores para hacer florecer todos esos activos y toda esa escasez que a día de hoy, lo que es el activo escaso en el sistema, ya no es la energía barata, sino que es la capacidad de almacenarlo, ¿no? Entonces, poco a poco, las señales positivas indican que todo va por ahí. A día de hoy, como tú dices, todo está yendo un poco por su lado. Las renovables, pues el pipeline que hay, más o menos todo tiene su modelo de negocio, todo está basado en un poco las expectativas que tienen los diferentes agentes, con nosotros los consultores o cada uno de los desarrolladores, y el bombeo, baterías y demás, pues también va por su lado, ¿no? Entonces, un poco, ¿qué es lo que hace falta? Honestamente, sentarnos todos en la mesa, decir, oye, punto de partida o punto de llegada que queremos llegar en 2030. Queremos 7 gigas de baterías, 2 gigas más de bombeos y mismo ejercicio en el mercado portugués. Y hacer un poco un plan de cómo queremos llegar a ello. ¿Vamos a llegar a ello con rondas de subsidios como estamos viendo a día de hoy? Subsidios al CAPEX, perfecto. ¿Vamos a implementar mecanismos de capacidad que permitan que estos activos se desarrollen, similar a lo que vemos en Reino Unido? Perfecto. Pero vamos a, por lo menos, asentar las reglas del juego para asegurarnos que todo se acaba desarrollando a la vez en bloque, porque ahora la sensación que tengo es que vamos improvisando, que yo creo que esto es muy, muy ibérico, ¿no? Voy un poco renovable, cuando la renovable me empieza a fallar, voy rápidamente al almacenamiento, y sabemos que desarrollar almacenamiento no es fácil, lo han dicho muy bien, baterías son un parche. Almacenamiento de largo plazo, muchos de los que estáis aquí sabéis lo que cuesta desarrollar un bombeo en cuánto tiempos. Son soluciones muy costosas, muy complicadas, entonces yo creo que hay que poner un poco ese ejercicio teórico muy sencillo, ver el punto al que queremos llegar, ver cómo nos tenemos que mover todos juntos, y siempre tener claro que habrá que tener planes mitigantes, porque nunca todo va a salir de acuerdo al plan.
Gracias. Juan, ¿eólica con el almacenamiento es necesario para que los proyectos se echen adelante o no?
Bueno, el planteamiento que tengo, varias ideas, 3 rápidamente. La primera es, para mí el almacenamiento, bueno, para mí no, el almacenamiento no es una tecnología de generación, es una tecnología de gestión, y que tiene un sobrecoste.
Pero que se puede instalar en centros de lactoproductores.
Efectivamente. Entonces, esa tecnología de gestión, si nosotros conseguimos trasladar de forma totalmente proporcional al valor de la instalación ese sobrecoste, pues es un negocio rentable. Que hay diferentes perspectivas. Está la perspectiva más centralizada, en la que bueno, pues hay diferentes planteamientos donde yo quiero grandes centros de almacenamiento, que yo pueda operar la red, pueda operar el sistema y decidir en qué momento pues tiro del almacenamiento, consumo o no consumo. O que cada uno de los promotores pues tenga la capacidad para incorporar más gestionabilidad a su instalación incorporando el almacenamiento. Para nosotros es un tema clave, o sea, nadie duda del almacenamiento. Nadie duda de que a día de hoy todavía es caro, y de que si queremos implantar de forma masiva el almacenamiento tendrá que haber algún tipo de mecanismo de apoyo. Pero para mí la cuestión clave es cuál es la estrategia clara del despliegue del almacenamiento de la forma más eficiente para todos. Porque lo que no puede ocurrir es que el almacenamiento se despliegue y termine siendo un sobrecoste para todos, sino que sea un ahorro. Y eso requiere de un enfoque muy enfocado a aquellas zonas donde tienen congestión, aquellas tecnologías en aquellas zonas, en aquellos nudos donde están sufriendo más, en aquellas zonas donde los centros de consumo van a poder absorber en determinados patrones de consumo esa energía, porque, como comentaba antes, incorporar un almacenamiento en una instalación renovable, en un nodo congestionado, que no va a poder utilizar esa energía almacenada nunca, es tirar el dinero. Entonces, entendemos que requiere de una estrategia que puede ser de alto nivel, pero requiere de una planificación del despliegue del almacenamiento de forma eficiente para todos. Por supuesto que para la eólica es interesante. La eólica genera todas las horas del día. La eólica puede tener una curva de producción desacoplada de su captura del recurso con almacenamiento que pueda permitir buscar esos momentos del día. Pero tenemos que decidir en qué puntos es mejor, en qué momento es mejor y con qué nivel de almacenamiento es mejor. El arte está en sincronizar el número de horas que tengo que almacenar con el coste que eso implica, con el valor que le voy a sacar a la instalación, en el nodo en el que esté conectado, para cuándo va a venir el consumo y con qué patrón tiene consumo. Y si no hacemos esa ecuación, pues vamos a plantear esquemas de apoyo al almacenamiento e instalaciones que a lo mejor no lo necesitan. No es que no lo necesitan, a lo mejor creen que lo necesitan, pero no lo van a poder rentabilizar nunca y a lo mejor el sistema tampoco se beneficia, ¿no? Por tanto, eso requiere, como he dicho al principio, de un nuevo approach totalmente diferente de cómo planificamos ese tipo de vectores.
Gracias. José, ¿fotovoltaico necesita energy shifting o no?
Por supuesto. O sea, no veo en este momento, por cierto, tienes suerte que tengo que coger el avión, no voy a la cena, pero tengo que coger un avión.
No, tenemos 3 minutos y sacamos.
Yo en este momento no entiendo una planta fotovoltaica que se desarrolle y no lleve consigo, pensado al menos, la solución de almacenamiento. O sea, esto ya se hace imprescindible. Estoy de acuerdo con Juan en el tema de la eficiencia y dónde se debe instalar, sobre todo para los standalone. Hay que buscar esa eficiencia en desarrollo. Porque estoy empezando a ver el mismo fenómeno, conozco el sector, el mismo fenómeno que con las plantas fotovoltaicas o eólicas. Ya hay proyectos de almacenamiento por todas partes y a lo mejor eso no es lo óptimo. Hay que buscar, sobre todo, priorizar la eficiencia. Bueno, luego cada uno con sus inversiones haga lo que quiera, pero luego no se queje. Pero hay que construir todo. Hay que empezar, con lo que tú decías, primero por un marco regulatorio adecuado, un marco administrativo. Es que ni siquiera se sabe en este momento cómo tramitar adecuadamente una planta de almacenamiento. Segundo, acabar con la doble imposición, ya más allá. Y después hay que buscar esos marcos retributivos. No sé si es que el almacenamiento es caro, el almacenamiento cuesta lo que cuesta. Es una necesidad y hay que retribuirla a lo que cuesta. ¿Cuesta más que producirlo con fotovoltaica o con eólica? En este momento sí. Veremos a ver cómo evoluciona la tecnología, pero eso no quiere decir que sea caro o barato, es que cuesta eso, que tengamos esa seguridad. Y lo que hay que hacer a lo mejor también, primero, mecanismos de capacidad, que es uno de los grandes aspectos positivos de la reforma del mercado, el darle patente de corso a estos mecanismos de capacidad, que hasta ahora costaba mucho y que lo aprobara la Unión Europea y se daban de forma excepcional, pero ya se ha reconocido en esta reforma del mercado. Y segundo, esas subastas que hablábamos antes, bien diseñadas, es que a lo mejor tienen que venir ya con incorporado en el incremento del CAPEX el coste de ese almacenamiento, y lo que tienen que ofertar es esa solución con ese almacenamiento ya. Y tiene que ser complementario. No va a haber una sola forma de retribuir, va a haber que hacer seguramente ingeniería entre participación en servicios de ajuste, lo que recibas vía mecanismos de capacidad o que optes por la subasta, etcétera, etcétera. Pero se va a necesitar, yo estoy viendo un gran apetito inversor por acudir al almacenamiento y no veo alternativa a que no se haga para un crecimiento sano del sistema, pero sí veo alternativas que no se están desarrollando y que hay que desarrollar por el bien de la sociedad y del sistema, que es gestión integrada de la demanda, que avancemos en esa línea. Hay que hablar de incrementar la oferta, pero también de cómo gestionamos mejor esa demanda y también que avancemos en algo que, bueno, fue un bonito lema de marketing, pero que tiene una realidad. Ciudades inteligentes, smart cities, smart islands, son realidades que hay que empezar a construir de verdad y en serio para tener una sociedad que de verdad optimiza su consumo de energía, porque no nos olvidemos una cosa, no podemos ver el sector, ni siquiera el renovable. Por supuesto, tiene que ser un negocio para que atraemos los capitales para invertir en él, pero no podemos olvidar el concepto que estamos dando una respuesta a una necesidad social, tener una energía limpia. Y también nosotros ocupamos espacios, tenemos un impacto, aunque sea muy bajo. Entonces, esa optimización y esa visión global del sistema es lo que no podemos perder de vista y construir. Y tenemos que hacer que todo eso sea negocio para que los inversores vengan a él, inviertan y construyamos ese modelo, pero sin perder de vista, digo, la globalidad.
Pues gracias. Estamos llegando al final. Vos pedía 2 minutos a cada una de notas finales, puntos de nuestro futuro de aquí hasta 2030. Y que vos parece que es importante tenernos en mente para que consigamos que no consigamos cumplir 100% de los PNIECs, qué cosas tenemos que hacer para que consigamos algún éxito en esto y que no abandonemos lo que es la cadena de velocidad de la transición energética. Juan, 2 minutos por ti.
Pues menos. Resumen de las principales ideas. Los objetivos son buenos, los objetivos son ambiciosos, tienen que ser así. Necesitamos la planificación para poder hacerlos en el corto plazo. Cambia el paradigma de la gestión de los proyectos, de las tomas de decisión de los proyectos. Cambia la forma en la que la profundidad de los análisis hay que realizarla para tomar las decisiones a la hora de invertir en los proyectos o desechar los proyectos. La necesidad de la regulación, la necesidad de acelerar el permitting, la necesidad de pensar siempre en el factor humano, en la aceptación social de todo esto, tanto en tierra como en el mar. La biblioteca marina es uno de los puntos que además mañana tenéis varias mesas, o espero que tenéis todas las mesas para hablar de esto, y es un mundo más desconocido, pero es un mundo tremendamente interesante y con muchísima sensibilidad social. Y desde mi punto de vista, el trabajar en lo técnico, trabajar en todos los actores, todos los vectores y todas las tecnologías para conseguir justamente esa sincronización entre todos los vectores que tienen que avanzar en todos los ámbitos, ¿no? Confiar en que los proyectos son proyectos a largo plazo, confiar en que tienen que sobrevivir a legislaturas, políticos, decisiones, guerras, crisis, etcétera, y confiar en seguir atrayendo un tejido inversor de largo plazo a la península ibérica, que yo creo que nos va a posicionar como un gran hub de desarrollo de industria competitiva, clean tech, de competitividad en costes de la energía para todos los ciudadanos y de desarrollo tecnológico para las tecnologías que tienen que venir.
Muchas gracias. José.
Yo sí que voy a ser menos de 2 minutos. No voy
¿verdad?
A repetir, no voy a repetir todo lo que ha dicho Juan, pero voy a volver al principio de mi intervención. O sea, la clave para mí está en que no perdamos el apoyo social. Somos los buenos de la película. Y si somos los buenos de la película, tenemos que hacer las cosas bien. Estamos en el lado correcto de la historia. Y la responsabilidad está en cada uno de vosotros, en cada empresa, actuar con transparencia, con equidad, cuidar el territorio, que una planta fotovoltaica debe ser vista como un matrimonio entre población, territorio y la empresa, la planta. Si esto se rompe, se nos cae todo por los cimientos.
Muchas gracias. Ignacio.
Y pues por último, porque poco más que aportar, ¿no? Yo creo que de aquí a 2030, lo que ya comentaba, ¿no? Vamos a ver un periodo muchísimo más dinámico, nuevas tecnologías apareciendo, nuevos problemas apareciendo, nuevos agentes, una sofisticación de las inversiones, los desarrollos van a cambiar. Entonces, un poco lo que decía Juan, de cambio de paradigma va a pasar, ¿no? Pero yo creo que todo este cambio de paradigma va a pasar en lo que espero que sea un entorno más estable. Yo creo que desde el lado político ya se ha entendido que esto ya no es un juego de un lado u otro, sino que todos con sus peculiaridades y especificidades por lo menos van avanzando hacia adelante y esperemos que sea un carro que no se pare, ¿no? Y lo que sí que espero que se acabe solucionando es temas de barreras técnicas y de permitting, que a día de hoy es a mí personalmente lo que más me preocupa. Ya lo estamos pidiendo aquí, que se tienen que aumentar los deadlines para los hitos de desarrollar renovables, porque es que si no, básicamente vamos a ser incapaces de llegar a ese objetivo tan ambicioso. Entonces yo creo que es un bottleneck que acabaremos solucionando. Ya hemos visto que por parte de la Unión Europea muchas de las medidas van encaminadas por ese lado y ya se están implementando de alguna manera en la península ibérica y esperemos que sean successful.
Muchas gracias por haber venido, por vuestro tiempo. Cerramos aquí nuestro panel. Hoje é o último evento este painel. Cuidado com os climáticos à saída, nunca sabe o que vos pode esperar. E amanhã cá estaremos a partir das 9. Obrigado.